Python is the most widely used programming languages. Companies like Google, Ola, Uber, Spotify, Facebook are currently using Python for their software development. So keep that in our mind. We came up with a tutorial where you will learn about what is Python and how can you start your journey with Python. Then we will see what is data manipulation, what are the libraries we have in Python. So before start the tutorial, let me introduce that Great Learning has come up with a brilliant idea, that is Great Learning Academy, where you will get almost 80 plus free courses, and after complete your course you can claim your certificate as well. And if you want to do these courses in your mobile application, that is also possible using Great Learning app. So let's get started with the tutorial.
Go to start here and write Jupyter. You will see this. If you don't see this, that means you have not installed Anaconda. Yeah. So Anaconda, I'll tell you what Anaconda is. We'll be using Python, okay? Just like, so all of you are comfortable in R, right? You have been using R for a long time, okay? So throughout this class, I'll be making a lot of comparisons with R. I hope that will not confuse you. That will help you, okay? Because you are already comfortable with R and Python is very similar to R. So I'll be making analogies everywhere so that you can relate to things, okay? So just like you use RStudio to write your R codes, in Python we have several platforms. So these platforms are known as IDE, Interactive Development Environment, just a sci-fi name, okay? So there are multiple platforms like Jupyter, PyCharm, Spider and so on. Whichever you use, the codes wouldn't change, okay? The codes would remain the same. The only difference is the frame. You will have some fancy windows in some, you will not have some fancy windows, okay? But the codes remains the same. So what I will be using for the class is Jupyter. Now why am I using Jupyter? Just a random choice. One reason I have, because it displays the graph in the same window. Let's say if I plot a chart, in RStudio when you plot a chart, you get the chart somewhere on the right hand side bottom, right? Here if I draw a chart, it comes in the same window. So I'll have just one single window which will be like a browser for me. It will be like a browser, like Chrome tab or something, okay? So it is very easy to follow. That is why I have preferred Jupyter over other IDEs. Okay, clear? So here in this system it is installed already, so I'll just click here. So once you install this and you go to your start menu and write Jupyter, you will see this. Okay, so if I click on that, you will see a small black window. This is the console where your codes will run, and you will also see a browser tab coming up. So it will come in some time. So you see a browser tab. So this is Jupyter. This is where you will be writing your codes. Okay, so it's just like a browser. It opens in Chrome. Okay, so now these are the folders that you see on your home directory. Just like in RStudio, at the right window, files, there's a tab called files there. If you go there, you will see all the files in your home directory. Similarly, these are the files or folders that you have on your home directory. Okay, so let's say if I want to go to a particular folder, so let's say I'll create a folder on desktop. So Python, and inside within Python I'll create a folder day 1. Okay, so let's say I want this to be my home directory. I'll first show you how to reach there by just clicking, not writing codes. Just like you have get working directory, set working directory in R, you have codes in Python also, but first I'll tell you how to go directly using button clicks. Okay, so I'll open the tab again, this particular tab. I'll go to desktop from here. Okay, when I go to desktop, I'll see that folder that I have created. Where is that? This one, Python. This is the one I created. Inside that I'll see day 1. Okay, so I'll go inside this folder. So this is the location I am currently in now. Okay, now what I'll do is I'll go to new on the right hand side and I'll create Python 3. I'll click here. So what this will do is, in the home directory or in the directory that I have selected, it will open a Python notebook for me. Okay, so when I click here, it opens a new tab. Now this is the ID where I'll be running the codes, and this is linked to that particular directory which I just showed you, the folder on my desktop. Let's say you join a company where they are using Spider. The codes wouldn't change, but Spider is good when you are in a company. But while you are learning, Jupyter is good. Because in Spider, what happens, I am not sure if it is here. In Spider, what happens is this output that you see here, I see it immediately, right? In Spider, you will not see it here. You will see in a RStudio type environment where the output is shown in a separate window. So when you are working in a company, you wouldn't want to see the output every time. It becomes irritating. You want that in a separate window. You want all the codes together. But while learning, we want to see the output immediately because we'll be making a lot of mistakes and learning. So I prefer Jupyter. But again, the codes remains exactly same. Don't worry about the frame that you're using. Okay. PyCharm also same. It's just another frame. You want to go to the D drive and set your folder. For that, I'll share some codes. But first, I'll teach the basics. Then I'll go to those codes. I just created a folder on my desktop or anywhere. So, for example, you want to go to your D directory, right? So, when you see this screen, instead of going to the desktop, you go to your D directory. So, you would have seen this screen, right? When this opened, you would have seen this screen. So, from here, you go to your whichever folder you want as your home directory, you go to that folder. Okay, D drive is not showing here. Then create a shortcut for that on your desktop, and then you can go. Or wait for a while. Right now, you create a folder on your desktop. I'll tell you the codes. Okay, I'll tell you the codes. But that code requires something which I haven't covered yet, which is why I'm not telling you now. I'll tell you after some time. Okay. So while it is downloading, let us proceed, and maybe in 5 or 10 minutes it will be downloaded. Then you can follow. Anyways, the first maybe half an hour or 1 hour we will cover the basic data structures. Like in R, you would have seen, right? Vectors, matrices, data frames, lists. So similarly, we will cover the data structures. Okay. So this for the first at least couple of hours, it will be a pure programming class. So please bear with me. Okay. Don't think that I'm here for a data science class. Why am I learning just programming? Because this is the basics. Without learning this, you cannot move to concepts. And my topics that I am supposed to cover is mostly the programming ones, because this is an introduction to Python. Tomorrow I'll try to cover all the modeling techniques that you have learned, linear logistic, decision tree, etc. Whatever you have learned, as much as I can, given the time constraint, I'll try to cover those techniques in Python. Okay, but again, I will not be able to go deeper into the concepts, because you might have learned, let's say, linear regression in maybe 1 4-hour class or 2 4-hour classes, right? I cannot cover all of them in one just 4-hour class. So I'll not go into the concepts. I'll give you a brief of the concepts. What is linear regression? What is decision tree, etc. I'll be asking a lot of questions to see how much understanding you have, and wherever you have doubts, you can ask me. Okay, but I'm here just to teach Python, and which is mostly a programming class. Okay, so I'll try to make it very interesting. Maybe in the middle, I'll also bring some concepts, some random concepts which you have already learned. I'll try to interact on those concepts so that it acts as a revision for you guys. So which data structure did you learn first in R? Probably vectors, right? What are vectors? Just a collection of elements. Can the elements be of multiple data types in R? No. What happens if you give multiple data types? No, that's a list. That's a separate data structure. Let's say in a vector I give 2 data types or multiple data types. What would happen? Will it show error? What happens? Gives an error? No. It will convert the simple types to the most complex type. So one of the data type will be the most complex one, right? Let's say you give numbers and a string. So string is more complex compared to the number. So what it would do is it will convert the number to a string. It will just put quotes around it. Okay, that is what it does for a vector. Now the first data structure that we will see for Python is list. Okay, this is not the list of R. Okay, it's called a list, but list of R is different. But it is very similar. Just like a list, it can have multiple data types. Okay, this can have multiple data types. It is indicated by double square brackets. Sorry, square brackets, not double. Okay, so it can have any data type, something like this. It can have a number, it can have a string together. Okay, so this is the difference between a list and a vector in R. And I can write something like x is equal to this. Okay, now in R you have indexes, right? Index starts from 1 in R. So you can access elements from a vector, for example, using the index. Similarly, in Python also you can. It starts from 0, but that's the difference. It doesn't start from 1. It starts from 0. So this is the index. Okay. So if you write x 0, it will give you 1. If you write x 1, it will give you r. Okay. So there's a slight difference between R and Python here. Now lists, here the indexes can also be taken from the reverse order. Okay, let's say you have a very big list and you want to access the last one. So you either need to know the length of the list or you will have to count. Either ways you will have to know the length of the list to access the last one. But in Python you can use -1 also. So the index of this one is -1 because it is as the last. Okay, so -1, -2, -3. So if I write x -1, I will get the last element, whatever it is. Okay. Lists can also be nested. So inside the list I can have another list. Okay, nested list. So I can have something like x is equal to, let's say 1, 2, r and another list here. So I can have something like this also. It's a nested list. Now can you help me get this element out using indexes? What should I write? So what should I write? X, then 3. So this is 0, this is 1, this is 2, which one is 3? This entire thing? Yes, this entire thing is 3. This is 4 and this is 5. Now if I write x of 3 and I close it here, what would I get? I will get this entire thing, which is again a list. Now you know how to access within a list. So what would you write then? Not comma, you just repeat this, the entire thing. Now what is the index of this? 0. This entire thing is 1. This is 2. Now you want something here. So I will write 1. Now this would give me both R and SAS. But I don't want both. I want just R. So what would I write? 0. Yeah. Okay. Now can we do this in the reverse order without using any positive index? Let's use all negative indexes and see if we can do. How would it change? Tell me. X of -3. Okay, then -2. -2. This is -1, -2, -3. Then I want -1, -2. So I will give -2. -2 will give me both of these. Then -1, -2. So once again -2. Okay, do you follow? So this is all you need to know about lists. Okay, it's easy, right? It's not difficult. How long will it take to learn? Like we have around 6 or 7 more data structures. All of them are similar to some other data structures in R. Okay, you just have to remember the syntax, which is a matter of practice. You practice for a few days, 2 weeks. 2 weeks if you practice. Let's say forget the weekends. Weekdays if you practice for, let's say 1 or 2 hours max. For let's say 10 days. So around 20 hours if you give, you will become very comfortable. So I have seen people becoming more comfortable in Python than in R, though they have learnt R for almost 8 months. Okay, the second data type, let's see, it's a dictionary. Okay, just like you in a dictionary, what do we have? We have a word and we have a meaning, right? You will never find a word in a dictionary without a meaning, or a meaning without a word. That won't be there. So similarly in dictionary you have something called key and value. Okay, you will have a key and you will have a value corresponding to the key. How do we write this? We use curly braces to write this. So we will write key, let's say key 1, and I will write value 1, and the key will be separated from the value using a colon. Okay, that's the syntax. Nothing to understand here. That's the syntax. Yes, you can see. Okay, so key 1, value 1. Now you might have multiple key value pairs, not just one. So how will I separate them? I will use a comma. So key 1, value 1, I can write key 2, value 2, and so on, as many as I want. Okay, now why did I write in 2 lines? You can write it in the same line. But if you write in multiple lines, it becomes easy to read. So I wrote in 2 lines, otherwise I could have repeated here. Okay. So always remember, it will have a key, it will have a value, and these can be, you can take them as a number or as a string, whatever. I can write 1 also instead of k1. But if I am writing a string, obviously I'll have to give this. Okay. So a key and a value. This is a dictionary. Curly braces is what you'll have to use. Okay. Yes, or both. This also can, this can be numeric, can be a string. This also the same. This can be anything. We will see now. Okay. So key is like the address at where it is stored. It indicates the address where this value is stored. Okay. Now, whenever we learn about any data structure in Python, there are 2 characteristics which we have to keep in mind. Okay. One is ordered. Is the data structure ordered or not? So what do I mean by ordered? Ordered means, can individual elements in the data structure be accessed using indexes? So what do indexes represent? Index represents that the data structure is ordered, because element number 0 is a particular, so at index number 0 there is a particular element, at index number 1 there is a particular element. That means there is an order in the data structure. You can't jumble them. You can't put py here and r somewhere here, because it is ordered. First you will have 1, then r, then Python. There are indexes defined in a proper way. So it is a ordered data structure. Okay. So if I have to say for a list, so let me write here 2 things we will talk about. So one is order, and we will talk about something called mutable. Okay. So the first one that we are looking at is list. So are lists ordered? Yes. So I'll give a tick here. Okay. So these are asked in interviews. Now what is mutable? What is the English meaning of mutable? Which can change, right? That's the English meaning. So here also it's the same. Can I change any of these values? If I write x0 is equal to, let's say, will it work or will it give an error? Try. So if it works, will it be mutable or immutable? It will be mutable, right? Mutable means you can change. So if it works, it means it is mutable. If it doesn't work, that means it is immutable. So just try quickly. Tell me, does it work or not? So how you run any code in this notebook is shift enter. In R you use control enter. Here you will use shift enter. Okay. So let me just brief you on the different buttons that you have here. So everybody has downloaded now. Is it done? Installing. Okay. So I'll just show you how you use everything here. So these are the buttons that you have. Okay. So how do I run a code here? I'll use control enter. Okay. I can use this run button also. What the run button will do is it will run the entire line or entire this is one line. It will run the entire line. Okay. Shift enter. Shift enter. You can change it. So if you're not comfortable with the shortcuts, go to help and edit keyboard shortcuts. You can change it as per your own wish. Okay. But usually in Python we keep shift enter. You will get used to it in some time. Okay. And the moment you run a line, it automatically creates a new line for you. So if I run shift enter, I automatically move to the next and I go on creating new lines. Okay. So let me create a list. Okay. So if I print, so if I write, let's say x of 2, it gives me 3. If I write x of 2 is equal to, let's say, 11, it runs. And now if I print x once again, it gives me 11 instead of whatever it was earlier. So that means it is mutable. We can change the values. Okay. So lists are ordered and they are mutable also. You can change the values of a list. Okay. You can give headings in your Jupyter notebook. Why I say it is good for learning is because you can give headings. Comments you can give using same hash as in R. If you want, you can give headings also. So let's say I want to give a heading. So let's say I'll write lists. So what I'll do, I'll click on this drop down. I'll go to heading. Okay, I'll just click OK. Now I'll run this. Now this becomes a heading for me. Okay, it will appear in bold. So you can give headings, and so it's like a notebook. You give a heading, a topic heading, and then you write something. Then you move to the next topic, give a heading and write something. You can give comments also. So these comments will not be run. Okay. You're not able to access these. How do you see what? I have given those square brackets, right? Okay, I removed the original command. So the moment you define those square brackets, that means you are creating a list. Okay, one second. Let me put this in the second line. Yeah, you saw that, right? It was asking in which. So first time it might ask you, should I open in Internet Explorer or should I open in Chrome? So first time you will have to give that. Okay, so it will wait for your instruction. So once you give Chrome, next time it won't ask you. Always it will open in Chrome or whatever browser you give. Okay, now let's come back to dictionary. So dictionaries, are they ordered or not? First let us find if dictionaries are ordered or not. So how do I find if it is ordered or not? How do I find if a dictionary is ordered or not? I will try to access the key and values using indexes. If I am able to access, that means it is ordered. If I am not able to access, that means it is unordered. So let's say if that is my dictionary, let's say this is my Y, I will write Y of 1. If this works, it is a ordered data structure. If it doesn't work, it is not. So try this, it wouldn't work. Okay, it will not work for a dictionary because dictionaries are not ordered. It will throw an error. Try somebody quickly. No, not needed. You should not be connected to the internet, even though this is a browser. Yes. It will work. This is also the same. It just opens in a browser. You have a console running at the back. If you see, there will be a black window at the back. That is the console for it. Just like in RStudio, you have the console at the bottom. You'll have a window where the codes are run. The moment you write Control Enter, that code will go and run at the bottom. Similarly, here you have a console at the back. That's a separate window which you don't see at all, because this is where you're writing everything. And you can Control S you can do to save your file, or you can click this button to save your file. Okay, and you can also download your files. So the advantage of using Jupyter, another advantage of using Jupyter is you can save it as a HTML file. Okay, so if you save it as a HTML file, even people who do not have these installed on their system can see your codes as well as your results. Okay, now let's say so one advantage is pretty apparent here. Let's say if you want to share a plot with somebody, okay, in R for example, how would you share? You will have to separately save the plot somewhere and then send it to somebody. Or R Markdown. This is exactly like R Markdown. This is R Markdown. So this concept was taken from R Markdown, where you see the plots in the same window. This is exactly the same. Okay. So this also can be viewed. So you can click on File, Download as. These are the options you get. You can download it as a HTML, as a PDF. You'll have a PDF also. Okay, all those things. Jupyter notebooks will have this extension IPYNB. Okay, if you are using PyCharm or Spider, that will have .py extension, but the codes remain the same. Only the extensions will differ. Okay, this is known as IPython also. Jupyter is also known as IPython. I have never tried that, but as far as I know, you will run into issues. So you will end up writing the codes in Python from scratch, because that's what we also do. We have a lot of projects which are in R and we migrate to Python, so we have to write everything. See, because R, when you run a machine learning models, there are a lot of default parameters, right? Default parameters. Let's say you're running decision tree model, you might have Gini index parameter, you might have a min bucket parameter. So the default values of those parameters are different for R and Python. So if you don't give the same parameter as in R, your output will change. So for that you end up writing it again. Okay. Okay guys, so what we were talking about is ordered and mutable. So what do you think? Dictionaries, are they ordered? Did anybody try? No? You are getting error? What is the error? Name error or key error? Okay. So it will not work. So it is unordered. Okay. Now let us see if it is mutable or not. Okay. Now in dictionaries, you can access the value using the key. Not using indexes, but using the key you can access the value. Okay. So instead of 1, you write K1. Then this will work. Because your key itself was 1. That is why you were getting the value corresponding to the key. Now you are not getting. Okay. If your key itself is 0, let's say instead of K1 I write 0 here. And then if I write Y of 0, you will get V1. But that doesn't mean it is ordered. That is just because your key itself is 0. Okay. So it is unordered. Now mutable, can you try to change its value? So YK1 will give you V1. Can you see if you can change the value? You are able to change the value. Okay. So that means the values are mutable. But if you are writing a string, you must give the quotes. You cannot just write A. You must give the quotes and write A. Quotes are necessary if you are giving a string, otherwise give a number. Okay. You cannot do half of it. That I will write A but without the quotes. That will not work. For any language that will not work, not just Python. Even in R that will not work. You define a vector, give some string without quotes, it will throw error. Okay. So it is, the values are mutable. You can have, so okay, she has asked a very important question. Can I have a list inside a dictionary? So what do you think? Can I have a list here? Why not? This is a question which is asked. Because, so I can have numbers also here, right? I can write number also here. Why not? Why the key value cannot be a list? Has to be unique. So list is a unique thing, right? I'll create a list which is, it's a combination. Or in other words, just now I mentioned that keys are not mutable. But what is a list? List is a mutable, right? So you cannot have a list there, otherwise the keys will become mutable. Okay? Or in other words, you can say it points to a location. How can you have a list which has so many numbers as something pointing to a location? Doesn't make sense. Okay? So I will write here, keys are immutable. Okay? Let's move to the next. So try to practice as we move ahead, okay? A few lines, write a few lines of code and then move ahead. So whatever files I'll be sharing with you, it will have enough comments which will help you understand. So let's say somebody has missed the class, he or she will also understand because I have given enough comments there. Okay, and there are a lot of examples. So you don't have to go anywhere else to learn all of this, okay? Just refer to this. That's it. Okay, I have given comments what you can do and what you are not allowed to do. There are a few extra lines of code, how to insert a new element somewhere in the middle, and all those things are there which are not very important. You can go through it at your own pace. Okay, I don't want to go too deep into the codes because otherwise this is like endless. Okay, I'll quickly cover the very important things and we'll move to concepts. Okay, we'll save some time for the concepts. So what happens if you give a list as a key? See, I have tried to give a list as a key here. I get an error, unhashable type list. Okay, so you're not allowed. No lists or dictionaries can be used as keys. You cannot use another dictionary also as a key. You can use it as a value, but not as a key. Okay. So the next data type is tuple. Okay. So what are tuples? Again, these are also collection of elements. The way to denote them is first bracket, not the C. Okay, not this C as vectors in R. Just first bracket. So x is equal to 1, 5, whatever. You can have a mix of strings and whatever. Okay. And the way to check, let's say if you have defined a variable x, you want to check what is the data type of this. What function do you use in R for that? Class. Class will give you, right? Class of x will give you whether it's a vector or whatever. Here it is type. Type of x, it will give you what is the data type of. Okay. So tuple you define using first brackets, very similar to vectors in R, but the C you do not use the C. Okay, and it can have multiple data types. It can have a list or a string. Now let us find out if tuples are ordered or not. Can you quickly check and tell me if tuples are ordered? So from now on, whatever codes you write in Jupyter, write the comments also in Jupyter. You don't need the notebook now with a pen and paper. You don't need a paper now because this is as good as a paper and pen, right? You can write all your comments here. These are ordered. Okay, now are they mutable? What is the error you are getting? Try to change any of the element. Yes. So account numbers in banks are defined as tuples because you never change the account number, right? You might change anything else, your first name or whatever, but account number it will remain the same for a customer, bank's customer, as long as he or she is with the bank. So they are and they do this so that hackers won't be able to change. Yeah. So we use, so you have the codes here. Okay, I have not given it here, but you can delete. You can use the delete function for that. You can delete because using index you can access it, right? So you use the delete function, along with that you are able to delete it. Okay, so there are always way arounds of doing things, but directly in tuple you cannot change. Okay, so guys, quickly moving to the next one, which is sets. This is the same sets that you learnt in high school. Okay, so sets, what is the special characteristics? They only contain unique elements. Okay, they will always have unique elements. Even if you give repetitive elements, it will just delete them. So what have I done here is, I have created this sets also you define using curly braces, just like a dictionary, but it will not have key value pair. Okay, it will just have elements, not the key value pairs. Sets. Okay, so I have defined a set which has repetitive elements. When I print it, all the repetitions are gone. I just have the unique ones. So that is the characteristic of a set. Now are these ordered or unordered? What do you think? Without writing it, what do you think? Will they be ordered or unordered? Yeah, now let's come back, and before I walk you through some other data types. So we are slowly moving towards data frames, and finally we'll end up with data frames, the same data frames that you have in R. Okay, I have some loops and all in Python. I'll just show you the structure and all. So before that, just a quick revision, because I'll be covering some machine learning also. So I just want to make things a little diverse instead of just going into codes. So what do you know about machine learning? At least the basic structure of machine learning. If I have to divide machine learning, how would I divide it? Supervised, unsupervised? Okay, so what do you have? What is supervised? What differentiates the two? You have a target variable here. You don't have a target variable there. What is the target variable? Labeled data. What is the labeled data? So does that mean we are doing something without a target there? Yes. So why are we doing that then if it doesn't have a target? Why is it called supervised? Okay. So in supervised, yeah, so you guys are right. I'm just trying to like lay around. So yeah, you guys are right. Supervised because you have labeled data. What is a labeled data? A data which has a target variable. Target variable is primarily the variable that you are interested in. You might have a few other variables also, but you are interested in the target variable and you think there are some other variables which influence the target variable. Okay. So why is it called supervised learning? Because the other variables, the non-target variables or the independent variables, they supervise. Now why is it called supervised? I'll tell you. So in supervised learning you will have this. Okay. You have a target variable and you might have one or more than one independent variables. So what happens, these independent variables that you have, this supervises the dependent variable or this controls the dependent variable. That is why it is called dependent variable after all. Okay. So that is why it is called supervised learning, because this supervises this. Okay. And what is the goal of supervised learning? What is the goal? Yes, exactly. I thought somebody will say finding why. You already know why. You might not know why for the future, but in the history you already know why. But your goal in supervised learning is to find this function. What is that function which gives me a relation between the two? Now why do I need this function? Yes, so that in the future, even if I don't have this, I will definitely have this because this is independent variable. I can find this out, but this I may not know. So what I will do, if I know this function f, if I know this, I will just plug it here and I will get it. Okay. Now this function f might be found using different machine learning algorithms. Okay. Each algorithm has its own characteristics, features, assumptions, whatever. Okay. So primarily there are two ways of finding this function f. You might have learned that. One is called a parametric modeling technique and one is non-parametric. Okay. Parametric, very high level, if I have to tell you, parametric where you get equations. Non-parametric you will not get equations. Random forest you don't get equations. But this is a linear regression, logistic regression, you get a equation, you get betas. So that is a parametric model. Okay. Most others are non-parametric models. But they have the same goal, finding the function f. What is the function f which gives a relation between my independent variables and the dependent variable? I need the relation so that for the future data or for the future I can find out my y. Okay, and for that I need labeled data, because in the history, so what we do is in the history I will know this and I will know this. I don't know this in history. In historical data I don't know what is that function. So I will use the historical data to find this function f, and then once I have found that function f, for the future data I will put this y in the function or put this x in the function, sorry, and then I will get the y. Okay, so that is the very basic structure of supervised learning. Now here each algorithm will have their own assumption. Linear regression will assume that this function is linear in structure. So beta naught plus beta 1 x1 plus beta 2 x2 and so on. Some other model will assume something else. Decision tree will assume many if else conditions. Okay, and so on. SBM will assume there is a hyperparameter, hyperplane somewhere which separates the two classes and so on. Okay. Now within supervised you have again two types. What are those? Classification and regression. So here let me write, we have a y here, right? We have a target variable. Now how will these two be decided? Whether it is classification or regression? Whether the target is continuous or categorical. Okay. So classification is where y is categorical, then where y is continuous. Okay. That will decide whether it falls under classification or it falls under regression. Now let's say you have found your function f. Okay. Now, before we go ahead and use that function to predict for the future, we must know what error is the model making, right? No model is perfect. Whatever model you build, it will always have error. So you must see the error, and whenever you build a model and you show to your stakeholders, you also show the errors, and you have to take permission from your stakeholders, your clients, whether they are okay with this much error or not. If they are not okay, they'll come back and tell that this is too high error. The business can't run with this much error. So do something and bring down the error. Okay, then you again do something and try to reduce the error. Okay, now there are different ways to evaluate a model in classification and in regression. Different ways, because your output is different, right? So what are the different ways? Let's say classification. How do you evaluate a model for classification? Accuracy. So basically confusion matrix. What are the other parameters? So what in confusion matrix? Accuracy. True positive is like going too much into details. So first high level. Yeah, accuracy, precision, sensitivity, F1 score, AUC score, gains chart, left chart, so many things, right? So all those come under classification, right? Why do we have so many parameters? Very logically, if you see which parameter makes the most sense. What is the first parameter which you found the easiest? Accuracy. What does it see? What do you evaluate in accuracy? Correct classification rather. So how many ones did you classify as 1 and how many zeros did you classify as 0? Simply put, right? Now, if you have accuracy which makes the most sense, because it makes a lot of sense, right? Something which is 1, did you say it's a 1 or not? And something which is 0, did you say it's a 0 or not? Then why do you need the other parameters? Why not just accuracy? Do you understand what he said? Everybody understands that? Yes. So accuracy doesn't make sense there. If you have 99 0 and only 1 1, which is there for a lot of businesses, credit card fraud transactions in a bank, they happen very rarely. Out of 1000 or not even 1000, out of 10,000 transactions, you will have one fraud transaction. So there, if you just predict 0, just guess that everything is 0, your accuracy will still be 99.9%. But is that model useful to the bank? No. The bank has to find that one fraudulent transaction out of 1000. So if you just use accuracy, it's a useless model. So how can you take care of this? Which parameter do you need in this case? Let's say precision and recall. Why 2? Why not just 1? Which one comes to your mind next? So ask these questions to yourself when you're learning. Everything is logical. You don't have to memorize anything. So what is the next which comes to your mind? Accuracy fails here. We saw one example. So which is the next which comes to your mind? F1 score. That is too complex. That will not come to your mind first. Sensitivity. Yes. Sensitivity will come to your mind first. What does it measure? What is true positive? Yes. 1 being classified as 1. So sensitivity measures how many were actual ones and how many you classified as 1. So will this be the correct parameter to evaluate the bank scenario which I just gave? Yes? No, sensitivity. Sensitivity, we are talking about, you said sensitivity, right? So sensitivity evaluates how many ones you classified as 1. So if the bank has 1 fraud transaction out of 100, it will just, sensitivity will just check out of that 1, how many did you catch? So even if your accuracy is 90%, which will be the case when you predict all our zeros, what will be your sensitivity? How many ones did you catch when you said all our zeros? 0. Because you said all our zeros. So you did not catch any one. So what will be your sensitivity then? 0. So you can easily know whether a model is good or not, because you were not able to catch even a single one. So sensitivity is able to fix this problem of data imbalance, class imbalance. Then why do we need others? Have you asked this question to yourself? Why do we need another one then? If accuracy did not solve a problem, so we had sensitivity. But now sensitivity is solving the problem. So why do we need something else, precision or whatever? So that means there must be some problem which sensitivity is also not solving. So what is that problem? Can somebody tell me that example? where sensitivity will also not solve the problem. Exactly. So what if you say all are ones? Then what will be your sensitivity? 100%. So you say all the transactions are fraudulent. Then your sensitivity will be 100%. And you will think you have built the best model. But that also is a useless model. So that means you need something else to check this. So what do you have then? What comes to your mind next? Specificity is the equivalent of sensitivity for the zeros. Sensitivity targets ones, specificity targets zeros. Okay. So next, what comes to your mind? Precision. Okay. Precision measures with respect to your prediction, not with respect to the actual. Sensitivity, what it was checking is, what is the actual ones? Actual ones compared to your predicted ones, right? But precision will calculate with respect to predicted ones. How many were actual ones with respect to how many you predicted? Okay, if you look at the formula, you'll understand. Okay, how many you predicted versus how many were actually ones. So you might predict all 100 are ones, but if only one of them is an actual one, your precision will be 1%, which is very bad. So precision is the parameter which will help you to over predict or to predict too many ones. Okay. Sensitivity is the parameter which will help you capture the ones. Precision is the parameter which will help you to not predict too many ones, which is also not good. Predicting too many ones is not good. You cannot say all the transactions are fraudulent and get a 100% score on sensitivity. So these parameters are very important, and these differences is asked in interview. Why do you need these parameters? Tell me the difference between them. You might know the formula for them, but unless you are able to explain. So all concepts in data science, if you ask the right questions at the right time, you will know the answers. Use Google, use Quora, you will get a lot of good answers. Very easy to understand answers. And you will never forget these answers once you understand. You don't have to memorize anything. Don't worry about the formulas. If you know the concepts, why need the formulas? Okay. So moving to the other side now. No, it's okay. So classification, these are the parameters. You also use area under curve. Okay, which is also a parameter to evaluate. It gives you as a percentage how well are you doing. Okay, it comes between 0 and 1. So area under curve is area under the ROC curve. What is the ROC curve? What does it have on the axis? X-axis, what is that? Sensitivity on the x-axis, and sensitivity is y-axis, and 1 minus specificity is on the x-axis, right? And you have the curve. The higher the area under curve, the better your model is. Okay. And then you have lift, gain, and those charts. Okay. So which more or less evaluate the same thing. Okay. In lift chart or gains chart, you first arrange the output in decreasing order of probability. You might have learned, right? Has this been covered? Yeah. You first arrange the output in decreasing order of probabilities, and then you check that. So we usually use gains chart and lift chart when you have a budget. See, predicting a 1 for a model is easy, but whenever you predict a 1, you might incur a cost for it. Let's say you are into marketing. Okay, a lot of people would have given you lectures on marketing, and also they would have talked probably about it. So let's say when you are in a marketing, let's say you have to give out coupons. Let's say you are into idea retail. Okay, prepaid customers you are targeting, a lot of churn you are looking. Idea prepaid customers are moving into Jio. They have already moved into Jio. Idea shares, if you see, it is at I think 18 rupees now. I bought it at 60 rupees. I lost a lot of money. Okay, because I have a very close friend. So the head of analytics of Idea is like my senior, not my friend. Obviously, he's a very old chap. So he's my very close friend, and he said we are doing good. So I went ahead and I purchased a lot of shares, and now it's really bad. Okay. So let's say Idea customers are churning. So what you want to do is you want to give them coupons, or you want to give them let's say 100 rupees free to all the prepaid customers. 100 rupees you want to give them off on their bill or whatever. Now giving 100 rupees off, you'll have to give out those rupees, right? It is a cost to you. So you cannot give it to everybody. You cannot give it to, let's say you have 1 lakh customers. You cannot give 100 rupees to 1 lakh customers. That would be a huge cost for you just in one circle. So what you will do, you will first try to identify which are the customers which are planning to churn. Okay. And then you will give out those 100 rupee gifts to them. So what you will do, let's say you build a model using demographics data, their past information, what was their last bill amount, or how much data have they used, how many calls did they make, how many call drops did they face, okay, whatever data. And then you build a model which predicts with pretty good accuracy and all the parameters that these are the few people out of, let's say, 10 lakh people. It predicts, if you take 0.5 as the threshold, it predicts that these, let's say, 20,000 people will churn in the next 1 or 2 months. Now you have to stop them from churning. So you plan to give them 100 rupees each. But let's say 20,000. So your model has predicted 20,000 once. Now let's say you don't have budget for 20,000 once. So 20,000 into 100. How much would that be? 20 lakh rupees, right? You don't have 20 lakh rupees. You just have 10 lakh rupees. So how will you shortlist from those 20,000? You have 10 lakh rupees. So that means you can only give to 10,000, right? Out of those 20,000 ones, you can give 100 rupee coupons only to 10,000 of them. Now, which 10,000 will you select? The ones which are bringing higher revenue? So, I say the answer some time ago, right? You have built a model already. So, some might have 98% probability of churning. That is a 1 for you. Some might have 51% probability of churning. That is also a 1 for you. So, obviously, if you have to decide between these two, which one will you prefer? Obviously, the 98% one. But if you just decide based on ones and zeros, you will never know. So, probabilities are important here because you have a budget. So, there in those cases, you need lift chart, gain chart, because they give you on a cumulative basis. On a cumulative basis, how well are you doing? How much well is your investment doing? So, for that, we use those charts. Okay, so if you go into the details of the charts and ask these questions to yourself, you'll understand. Yeah, so this is classification. Now let's come to regression. Okay, on the other side. So how do you evaluate a regression model? So there are two ways, high level, there are two ways to evaluate a regression model. Okay. How do you evaluate a kid who has appeared for an exam? Again, this applies for both classification and regression. You see how well has the kid scored, or you see how many questions did the kid not answer. So let's say a kid scored 80. You look at he scored 80, he or she scored 80, or you look at he or she did not score 20. Right? Two ways you can evaluate. Our parents look the other one, that he or she did not score that 20. Okay? But there are two ways of looking at a performance. Similarly, in both these, you have those two ways. Look at the accuracy or look at the error. You had accuracy in there, you had error also, which is 1 minus accuracy. So similarly for regression also, you have error parameters, you have accuracy parameters. Error parameters are root mean square, error, SSE, RMSE, MAPE, all those things. Okay, and on the accuracy you have R square, adjusted R square, and so on. Okay, now let's talk about the errors first. What is the first error parameter which comes to your mind? RMSE. What is that? Root mean squared error. So what does it give you? Let's say I tell you a model has a RMSE of 15. What does that mean? I tell you a model has a RMSE of 15. What does that mean? Is it a good model or a bad model? Unless you know what is the value, what is the scale of your target variable, you will never be able to say. What if your target variable is the price of a 5 BHK villa in Gurgaon? The price will be into crores. If 20,000 is the RMSE, then it's a pretty good model. It predicts with almost 20,000 plus or minus. So RMSE gives you on an average how good is your model compared to the target variable. So if your target is in crores and your model makes an error of 20,000, it's very good model. But if your target itself is in thousands and your model is giving an error of 20,000, it's a very bad model. So it depends on your target variable, which means that just looking at RMSE, you cannot decide whether your model is good or not, right? So what does that mean? We need something else, right? That means we need something else. So what is that something else? Mean absolute percentage error. That is the something else, because that gives you as a percentage. that, okay, I tell you I'm making an error of 5%. Now you will be in a pretty good situation to say whether it's good or not. Obviously, depending on the domain. But you have a very good idea compared to RMSE that the model has 5% error. So yeah, it's a pretty good model. 5% error is okay, right? So that is why you need RMSE also. RMSE, then you will be able to evaluate well. But again, that might not be very well understood by your business if you standardize it. Let's say the real estate developers of Gurgaon came to you and asked you to build a model, and you say your error is, let's say, 0.25. So you will say that on an average it is making an error of 0.25 compared to the standardized values of prices. Now they will not be able to understand what is standardized value and all. So it becomes difficult for them to understand that. So you generally don't change the Y target value. You might do for your internal calculation, but when you finally present the results, it must be in the same format you got it. Okay, and that is a very important part of data science. Yes, but mean absolute error will have, the units will be squared. That will not make like even more sense. That will be on a worst part. It's like SSE. So you will say your client, the client gave you prices for 100,000 villas in Gurgaon or NCR, and you are telling the client that your model is making error of 20,000 square rupees. That would not make sense to the client, right? Square rupees will not make sense. So the best parameters is RMSE and MAPE. Yes, maybe. So they are not comparable. They are two different things. Okay. MAPE is usually more relied on. I personally like MAPE more because that gives you as a percentage, 5%, 10%, because you have the actual values in the denominator. You guys know the formula for all of them, right? So when we talk to our business stakeholders, we use both usually, MAPE and RMSE. We will show them both, and R square also. Yeah. Now coming to the accuracy part, what are the accuracy parameters for any regression model? R square and adjusted R square. So why do we need, the most common question, I think. Why do we need adjusted R square if you have R square? What is R square? First tell me. 1 minus RSS by TSS. What is TSS? Total sum of squares. So what exactly is that basically? Okay, I write SSR as SSE. Residual and error is the same thing. Okay. So what is this and what is this? Both are sum of squared errors, right? You know, both are the same things. But here you find the error with respect to your model, with respect to your linear regression model or whatever model. Here you find the error with respect to your mean, right? So both have the same formula, actual minus predicted whole square, summation of. Even this has the same formula. But here this prediction comes from the line. Here this prediction is the average. So now can you tell me the definition of R square? Yes, exactly. So R square tells you how well is your linear regression model doing with respect to predicting the average. Okay, with respect to predicting the average. So let's say if I have to calculate, if I note down the age of everybody in the class and a new person walks in, and if I ask you what is the age of that person, what will you predict? I just have the age of everybody in the class and a new person walks into the class. What would be his or her age? The average of everybody. That will be the first guess you will make. So R square tells you with this first guess, how well are you doing? Okay, that is what is R square. That is the most simple definition of R square. And all the book definitions you already know. Okay, can R square be negative? R square can be negative. So you are comparing with respect to your average. If your predictions from the line are worse than the average, it might be negative. But you will never see that. Again, what he said, theoretically it is possible, but you will never see that. Let's say the age, so you predicted the age for that person, right? Let's say you predicted average, and using a line I predicted 500 for that person. That person's age is 500. Obviously that would be worse than the average. So in that case the R square will be negative. Okay, let's come back to coding now. Okay, now we'll come back to the next data type. Okay. Next, let us look at how do we write loops in Python. So let's proceed. Okay, let's proceed. Let's come down to coding a bit. So I just did that revision for a change. Let's come to coding again. So let us look at the 2 or 3 loops that we usually use in Python. Okay. First we will see at for loop. Again, this is just syntax. There is nothing to understand here. So how do we write the syntax of a for loop? So all of you know what for loop is, right? You would have used that in R already. So it is the same in Python, just the syntax varies. So you write, let's say you have a list 1, 5, 9 or whatever, and now before I go to a loop, let's say if you have to perform operations on individual elements of the list. So so what would happen when I write x into 2? What do you think? It will multiply every element by 2. That is the most logical answer. It will not do that. It will repeat the list 2 times. You can try it. It will just repeat the list 2 times. Okay. So in technical terms, it is called lists do not support vectorized operation. Okay. That means you cannot perform an operation on individual elements of a list using the list name. Okay. This works for vectors in R, but for lists in Python it doesn't work. Okay. So lists do not support vectorized operation. So then if you have to perform operations on individual elements of a list, what do? One way is to use a loop. Using a loop works because there you are not performing an operation on the entire list together. You are taking one element out and then performing an operation. Then taking the second element out and performing the operation and so on. So first you will have to access individual elements. So that we do using a for loop. So I can write for I in x. What does that mean? That means this I will iterate through all values in x. X is a list. So the first value of I will be 1. Next value of I will be 5 and so on. It will go till the end and then the loop will stop. So the syntax is for I in x and then I put a colon. Okay. Then I put a colon. After this I give a space here, a tab space here, 4 spaces. So that is called indentation. So why do we need indentation? Readability, just readability. It is mandatory. Why will Python enforce readability on you? Yes, exactly. Because see, I am not using bracket. In R you use brackets. So you know, if you write a bracket, you know that okay, whatever is in this bracket is part of the loop. But here if you don't have bracket, how will you know what is part of the loop, what is outside the loop? So that you decide based on the indentation. Plus readability of course. Okay. So wherever I use this tab space, that means that will be part of your for loop. And if I start something again from here, that means this is not part of your loop. This is outside the loop. Okay. So that is the purpose of this indentation. So now if I write something here, f of x, f of I. So I have collected I which varies from here and I have done some operation on this I. This will work. This is a for loop. Okay. Just the syntax. Now similarly you have while loop also. Again while loop just like in any other language. So a typical while loop looks like this. You write while and then you write a condition. Okay, then you give a colon and then again indentation. So whatever you write here is part of the loop. Okay, so this is the syntax of a for loop and a while loop. In while loop you write a condition. Okay, and at some point this condition will be in terms of a variable, let's say I. Okay, and at some point you change the value of I, whatever, using I is equal to I plus 1 or I minus 1. So we do this so that the condition becomes false after some time. Otherwise the loop will become infinite. Okay. So we write while loop using a variable and within the loop we make sure that at some point the variable, the condition becomes false. Otherwise it will become an infinite loop and keep on going. Okay. So that's a while loop. That's a basic structure. You will get to know all this once you start using. Okay. So I have given some examples in this notebook. So once you have this file, just have a look at it. Range. There is a function called range which gives you values from 0 till 1 less than the number you write. So if you need from 1 to 10, so range is like the sequence function in R. You know the sequence function in R, what is it? You write sequence start number, right? This is end number and the increment. Same you have range function in Python. Same start number, end number, increment. Okay. But the difference is if you write range of let's say 11, so by default the start number is 0. In R it is 1. Okay. In R if you just write sequence of 10, it will give you 1 to 10. In Python if you write range of 11, it will give you 0, 1, 2 till 10, not till 11 because it is starting from 0. So 1 less than that number it will give. Okay. So if you have to see the syntax help in Python, for example. So for example in R you write question mark and the function to get help, right? In Python what we do is we write shift tab, press shift tab and this pop-up will come. Okay. So here if you can just see the basic help, or if you click on this plus you can see a detailed help of it. So I have done this for range, you can see it gives me range, start, stop and step, and it gives you as a text also what does the range function do. Okay. So this way you can access help page for any function in Python. Okay. You have IntelliSense on Jupyter notebooks also. So if I write array-eng and I press tab, I get all the functions starting with array. In R it automatically will pop, here automatically it will not pop, you will have to press tab to bring it out. Okay. So more or less it's the same as R. Okay. So some examples for loop and while loop here. Yeah. For a condition, if else you can use. There are if else conditions in Python also, just like in R. So how it works, you write if, you write the condition, let's say condition 1, you give a colon, use the indentation, do something if that condition is true. If let's say you have multiple conditions, then you write elif condition number 2, not else if. This is a short code. For else if you write elif. I have those examples also here. Okay, it's very easy, so I did not go through all of it. You just look at it, there are enough comments for you to understand. This is pretty simple. If this condition is true, it will run these lines and directly come out. It will not see if these conditions are true or not. Okay, and if this condition is false, it will see the next condition whether that is true or not. If that is true, again you give indentation, it will run these lines. So you can have any number of elif like this, and at the end you can have a else condition. Okay, again with indentation. So this will run if none of the conditions are true. So I have break and continue statements here. So this example. Okay. So if anybody has worked on VBA, VBA also has the same break and continue function. Okay, it's the same. I'm not going through each and everything of code because it is endless. Okay, so I want you to know only the important ones, and later obviously once you start using, slowly you will progress. But first let's start with basics. Let's get the basics very right. Okay. Will come now. So now we are moving slowly to 2 dimension. Until now we are in 1 dimension. Now with arrays we will move to 2 dimension, and then finally you will have a data frame. Okay. So the next data structure is a array. So arrays are exactly same as vectors in R. Okay. They can have only one data type. Okay. They can have only one data type, and same if you mix the data types, it will convert it to the complex one, just like vectors in R. They are also ordered. Okay. They are also mutable. Arrays. Arrays are not directly available in Python. They are taken from a library in Python. The library is NumPy. Okay. So just like you have different packages in R, you have packages are known as libraries in Python. Okay. So there are different libraries in Python, but not so many as in R. In R you have one library for every machine learning algorithm. Here it is one library, sklearn, which is for everything. For all machine learning models you have sklearn. Deep learning you might have something else. Okay. So just like you import a library in Python before using, first you install it and then you import it, right? So here we don't have to install NumPy because it is pre-installed. The moment you download Anaconda, all important libraries like NumPy, Pandas, sklearn, they are installed automatically. So you don't have to install. but you have to load it, of course, just like you load in R. So the way to load it is import NumPy. You just write import NumPy instead of library package name in R. Now why did I write as NP? I have written as NP there. Now the way to use functions in Python is, first you write the name of the library dot function. Okay, you write the name of the library dot function and then you give the inputs to that function. That is the syntax. Now some library names are very big. So every time you have to use a function from that library, you will have to write the name of the library, which is painful. Write that big name dot function. So we usually give a short code or an alias to the library name, so that instead of writing the full name, we just write the short code. So we give the alias using this. Import NumPy as NP. So that means instead of NumPy, I will be using NP every time. NP will mean NumPy. It's like an alias for NumPy. Okay, so that's what I have done. I have imported NumPy as NP. And then I take a list, I convert it to an array using np.array function. Okay. So if I had not imported it as NumPy, NP, I would have written NumPy here, the full word NumPy here. So it saves me some effort if I give a code to it. Okay. And then if I check the type of this, it gives me a NumPy array. So it's an array. So now you see I created a list which has a mixture of integers and text. So for a list it is fine, but when I convert it to an array, the array automatically converts it, all of them, to characters. Okay, just like what would happen in R for vectors. Okay, now this is the function I was talking about. The moment you write range of 20, it gives you all numbers starting from 0 till 19. Okay, not 20, 20 excluded. Now the advantage of using array is we can go into 2 dimensions using array. So arrays can become a matrix. Arrays are also known as matrix basically. Just like you have vectors in R and you have matrices in R. So here it's the array. Array itself can be a 1 dimension thing or a 2 dimension thing. So I have converted the array to 2 dimensions now using the reshape function. Okay, I have used a function reshape. X is a array there. So name of the array dot reshape, and then obviously when I convert something to 2 dimension, I'll have to give how many rows I want, how many columns I want. So I have given 2 rows and 10 columns. Okay. So when I give this 2 rows and 10 columns, how many elements should be in X? I should have 20 elements in my X, right? If I don't have 20, what will happen? What would happen in R? If you create a matrix which doesn't have enough elements, so your matrix should have as many elements as the product of rows and columns. If that is not the case in R, what would happen? Blank. Will it fill any? Yes, it starts to repeat. Let's say you give 1 to 10 and you create a matrix of size 5 and 5. So 25 elements should be there, but you have given only 1 to 10. So it will give 1 to 10 and then again 1 to 10 will start. It will start repeating. In Python that will not happen. It will throw error that your matrix size is not the same as the number of rows and columns. Okay. Yeah. So now we can, using the reshape function, I can convert it to 2 dimension. Okay. So after converting to 2 dimension, I'll have to use double indexes now. Of course, in 1 dimension, we use 1 index to access whichever element we want. Now we are into 2 dimensions, so I'll have to give which row I want and I'll have to give which column I want. Now remember, the row indexes will start from 0. Similarly, the column indexes will start from 0. So the first column's index will be 0, not 1. Similarly for the rows. Okay. So that way I can access individual elements. Now, so for example, what I have written here is second and first, second row and, sorry, this will give you third row because 2, 0, 1, 2. So third row and second column. Okay. Now what have I given here? So you write the name of the array, square brackets, the rows that you want, comma, the columns that you want, just like in R. Okay. But in R, when you want all the rows, what do? You do nothing, just leave blank and then comma and whichever column you want. Here you cannot leave it blank. You give a colon and leave it blank. That will work. Okay, that's the difference. So I have given a colon and left that blank. That means starting from the beginning till the end. and then I have given a comma and 2 and 1. So 2 means the third column and the second column. Okay, but notice this colon. That means starting from the beginning till the end. If I write a 1, if I write a 5 at the end, for example, that means starting from the beginning till the row which has index 4, not 5, 1 less than 5. Are you getting? So if I write something like this, y, if I just write this means everything, all the rows, all the columns, but you have to give this. This is mandatory. In R you would just leave it like this, but in Python you have to give this. Now if I write, let's say 2 to 5, what does this mean? All the columns and which rows? Row 2 to 4. Okay, the row with index 2, the row with index 3, the row with index 4. Okay, similarly on that side also. You got the point, right? So I have given some examples for all of these. Okay, so y00 will give you first row, first column, 01 will give you first row, second column, and so on. So here second row, all the columns starting from index 3 till the end. Okay, just examples where you can see the data type, just printing. You can give conditions here. So print y is greater than 5. So this condition will be checked for every element present in that array. Okay, and accordingly it will give you whether it's a true or a false. Okay, this is just like in R, no difference here. You can convert it to ones and zeros. This is actually ones and zeros. If you check the type of it, you will get, it's an array, it's a boolean array, an array which has boolean elements. Okay, you can convert it to ones and zeros using if else condition. If true, 1, else 0. So you will get to know whether you are writing correct or not. Most of the keywords in Python are highlighted in green color. See, all these functions are highlighted in green color. So if you are writing something and that is not green in color, you will understand something is wrong. Okay, so if for example I write 1 double equal to 1, I get a true. So let's say if I write 1 is equal to, see, I don't get it in green color. That means this is not the correct way. If I write TRUE, I get it in green color. So this is the correct way. If I write TRUE, it's not green. Okay. Now here is some differences between array and a list. One difference you already would have seen, arrays only have one data type, list can have any. The other difference which you saw, the other limitation which you saw for a list was you cannot perform vectorized operation on a list, right? What happened when you multiplied it by 2? It repeated it twice. That will not happen in array. Array will be just like a vector. It will multiply each element by 2. What is usually expected. Okay. So arrays support vectorized operations. Lists do not support. And of course, they can have a mix of data types. Arrays cannot have a mix of data types. Okay, one last thing before we move to data frames, which is series. Now series come from another library in Python, which is pandas. NumPy is a library which is mostly used for matrix operations. That is why you have arrays coming from NumPy library. Okay, we do a lot of matrix operations, even a lot of machine learning algorithms. Let's say you go to SVM, for example. If you learn the maths behind SVM, you will find there's a lot of matrix operations happening. Okay, even in linear regression, there's a lot of matrix operations happening, because after all, you have to find variables from some equations. You have some equations and you have some unknowns. From those equations, you have to calculate the values of unknowns. What are unknowns? The beta values are unknowns for you. Okay, so all of that happens using matrix operations, which you learnt in high school. Okay, so inverse of the matrix is calculated, then you calculate whether it is a determinant or not, and so on. So all those happen in the NumPy library. Pandas is a library which is used for data manipulation. So data frames come under pandas library. Okay, so same, I have imported pandas using again a alias which is PD. These are not my aliases, this is the usual norm. People take pandas as PD always. Okay, so I have imported pandas library as PD, and then so what is a series? Next data structure is series. What is a series? A series is an array, but it has indexes. It has names rather. Okay, it will have names, row names. You know, in our data frames can have row names also, not just column names. Have you seen the empty cars data? There's a very famous data set, empty cars. The data set, if you see, the name of the car will be the row name. It will not be as a column. It will be as a row name. So similarly, series in Python can have index, but those index can also be values 0, 1, 2, 3, but they can also be names, just like keys in a dictionary. Okay, these also can have names. So how will I define it? I just create two lists. I convert the first list to an array, and then I use pandas.series function, and I give data is equal to temp, where temp is my this list, and I give index is equal to another list. So index is equal to label. So I get this output. I get output where 10, 20, 30 are the values, and the index for them are A, B and C. Okay. So this is a series. Now why did I cover series, though they are not very important? Because every column in a data frame is a series. Okay. Just like every column in a R data frame is a vector. Okay. Every column in a pandas data frame is a series. And you merge multiple series which have the same indexes, then it becomes a data frame. Okay. So you might have, let's say, employee names, and the employee ID might be the index for that employee name. So let's say employee 101 is a particular name. Similarly, you might have age also. For age also you might have the same index, which is employee number. So finally when you merge everything, it becomes a data frame. Okay. So data frame is a combination of series, all the series having the same indexes. Okay. So this is how you create a data frame. Many other ways also. This is how you create from a list or an array. So pandas.dataframe is the function, and then I have defined what data I will be using in this data frame. I have defined the index that I will be using. This index is not mandatory. If you don't give index, it will be 0, 1, 2. Okay, but I have given index, so I have gotten A, B, C. If you don't give, it will be 0, 1 and 2. And then I have defined what is the name of the column. So column name is column 1, which I see here. So this is my final data frame. Okay, so finally we have come to where you went and finally concluded in R. So this is your final data structure in Python. So this is all you need to know about Python. How difficult is this? Not very difficult. Maybe right now it might seem a little difficult because this is your first day and so many new things like syntaxes you will have to remember, but just 3 to 4 hours of practice and you will be comfortable with it. And after this is the same. We'll see how to find missing values in Python, replace missing values with something better, how to do merging in Python, multiple data frames, how to do R bind, C bind in Python. Okay, left join, right join, group by in Python. So all those things we will see after the break now. So it's the same thing, nothing different. Okay, it's all about practice. So master one language and make yourself comfortable in the other. Now it's your choice which one you want to master. Both languages are important, I would say. And now since you know R, you are finding these things easy. Of course, there's a lot to Python, but you learn in batches. I cannot give you everything now. You will get scared and run away. You will never learn Python. So first learn these and start using, take some data set, start doing something. We don't have time for that now. If this was a extended class just like you had at the beginning in R, you would have had I think almost 2 to 3 residencies at least just in R. So that was the time where you would have practiced in the class. Now in 8 hours I cannot help like get you practice yourself in the class. I can do that, but then I will not be able to cover the machine learning part. But I think that would be a better way to utilize our time, covering the machine learning part, and practice you can do at home. Okay, take the Titanic data set, start practicing, start cleaning the data, finding the missing values, replacing it with something, doing data manipulation. Okay, and then finally running the algorithms on it. So this is a data frame.
There are pretty much 7 or 8 things, maybe 10 top things that you would like to do with your data. So we'll focus on those things because that is repetitive in nature. So let's see, and you're right, there are a lot of things online. As you all learn, this new topic, I encourage you all to share your questions, share your learning with your team, because that is how you help others to learn. So I was very happy to see one question that you all posted in the group and someone else answered. Though you may not see me answering all the time, because I want you all to, pitch in, help your peers. That is how you all interact. That will be my motive. But if the discussion go haywire, if you are not able to find the answer, trust me, I'll be there to intervene. So always do that with for your peers and for yourself. That is going to help a lot. Okay, so without further ado, anyone wants to talk about it before we start?
Yeah, hi, this is
Mhm.
Pavan. I think the thing that made it complex was him using sort of, some statistical references, etc., which, I wasn't really familiar with, or rather completely familiar with. Plus the fact that, used fairly complex numbers like, random set of variables from 0 to 1, which included minus 0.777. So I sometimes feel that if the video had been done using simple numbers, it would have been easy to follow the result of the functions
Okay.
rather
Okay.
than having to look through them specifically. But other than that, I think it was relatively okay. Yeah, slightly fast-paced, but relatively okay.
Okay. We'll make it a little slow. I want to take you all together. So if some of you already have knowledge of Python, then do not be, in a haste. Let other cope up. For the first few sessions, let's be a little slow. Help others to, walk with you. That will be the aim. And where I see that you all are together, right? You're on the same platform. That is when we'll take up the speed. All right. So this is the week 2 we are in, and these are the topics that we'll be going through. Basic working proficiency in Python must have been covered in week 1. We are going to start with basic data manipulation. If you missed anything in week 1, trust me, you did not miss anything, because we'll be covering that. So I'm going to cover basic data manipulation using Python. Here we will talk about pandas and NumPy. Whatever we are going to do, it has to do with pandas and NumPy. So you all have gone to the video. Can anyone tell me what is Panda and what is NumPy? What are those libraries for?
So NumPy is for advanced arithmetical functions, and Pandas is for data manipulation.
Okay, excellent. NumPy library is for numerical computations, and Pandas for data manipulation. We are going to use both of those. We are not going to touch on visualization this week. Right? For visualization, we will talk about it next week. These are some ground rules. I hope all of us are pretty, we are professionals. We understand what those ground rules are. I hate to repeat it for our sessions. I'm sure you all will be punctual, respect each other's time, and you would be submitting your assignment in time. Most important, all of you will be prepared for our sessions. So I trust you for that. Let us move ahead. Okay, this is an important slide, though I do not go repeat these slides on all the sessions, but because we are meeting for the first time, the foundation course, it says foundation. It is, maybe basic, but it is very important. So we go through the 2 weeks for Python for data science out of the 4 weeks, and today and the next session, we are going to invest more time, and then you'll be getting a week or 2 to appear for your project. Thereafter, we will work on statistical methods for decision making, and here we will reiterate the concepts of statistics. So today, if you see the data manipulation, I may not be sharing what those min, max, 25th percentile, 50th percentile, 75th percentile would mean when you describe a data, but in the statistics course, you will get a detailed information on each and every statistical information, right? So this is pretty basic, but it is extremely important, and I'm going to go a little slow here. Once we are done with this, then we work on core courses, and here also we have a complete topic, a full, I believe, 3 to 4 weeks to focus on advanced statistics. So we'll be learning about statistics even in this particular topic, but the kind of topic we'll be learning is little, tedious, in the sense that we'll be focusing on principal component analysis, factor analysis, some little advanced version of the statistics. And then the topics that are here, data mining, predictive modeling, all of these would involve algorithm, right? So we have time to work to enter the space. By the time we are here, you'll be very well used to the codes. Now, before the session, before we take any particular data set and explore, here are a few questions for you, and this will be a standard practice. So I'll have few questions ready for you. And these are not only the questions. I like asking questions. I like to hear your voice, right? So I'll be asking questions even during the session. So these are the first few that I have. What are some of the common data types in Python? What do you think?
Integer, string, and float.
Okay, excellent. So we have object type. Yes, Boolean, that's true. Okay, can you name some important Python libraries? We just talked about it.
NumPy, Pandas,
Okay.
OS.
OS, interesting. What is OS?
Again, based on the exercise we did, it helped us find out the directory details, etc. It's a module of some sort, which, yeah, I had to import that to find out the directory details, etc. So
Correct, absolutely. So it takes from the name of operating system dependent module, some of the things that helps us to navigate through our files, folders, etc. So if your file is saved in another location and you are trying to access files from other location, that is not going to work. You will have to import OS, see the current work directory, and change the current work directory to the file location. Thereafter, you'll be able to import the file. I'll show you that in a while. What is the command in Python to check the list of variables and its data types? So when we work with a big file, right, there are different variables. Variables are nothing but the column names. How do you see the column names, and also if that column is integer or float or object, how do you see that?
Art info.
Exactly, that's absolutely correct. All right, so this is the case study that we'll be going through. And it's an interesting case study. We have a bunch of numbers, and we are going to do some cool manipulation of numbers. So I have an exercise for you that we can go through. It says different food nutrients are extremely important for growth and nourishment of our well-being. Keeping a track of all nutrients on our plate and managing it wisely is an essential step in order to maintain our peak fitness. It is vital to consume a healthy mix of vital nutrients by balancing our diet with different foods. In order to better understand the nutritional value of what we eat, a detailed chart of various nutrient composition of different food items has been created. We need to analyze this data to help make more informed eating decisions. So there are some questions that we are going to answer. The data set that we are referring to is right here. So the first column is NDB. Seems like it's a generic ID kind of column, right? In any data that you explore, most of those will have a generic identifier or unique identifier, right? If you look at the government portal and you try to access any information, most of the times you would see Aadhaar ID, PAN ID, customer ID, URN number, etc. So those ID kind of column doesn't have a lot of information to share when we go with building algorithm or predicting or doing any kind of statistical analysis. But this is still given to us in NDB, the first column. Then it's a short description of what that food item is. So for the first one, see, it's butter with salt, butter whipped with salt, because it's all about food items. It is giving you what are the core ingredient or the short description. Thereafter, you have the different columns that talks about the nutritional component. So what a gram of water, energy, calorie, protein, lipid total, we have ash, carbohydrate, fiber, sugar content, calcium, iron, magnesium, phosphorus, potassium, sodium, zinc, copper, manganese, and selenium. So we have a bunch of other nutritional nutrients corresponding to these food items. Let us see how we manipulate this in Python, right? Any data we'll have to explore. So do not restrict yourself working with this data set only. After the session, if you get time, please feel free to take up any data set that you have in Excel, save it in the work directory, try to read it in Python, try to run the same course that we'll be practicing today. Right, that is going to help because practice is the key. Though we'll be using the similar codes time and again, the more you practice, better you will be at it. So we open our Python.
Aruna, on that point, just a request, right? I think it'll be great if you have a couple of additional data sets that we can play around with. If you can just check with the Great Learning guys to see if there are any exercises, additional stuff that they can share.
Okay, I think the institute does a fair good job in giving the data sets, but I'll have a word with the program manager so that if you do not have access to those, some of the data sets can be made available. If not, then I can share some links, the sites where you can get the data handy.
Sure, thank you.
Okay, you're welcome. Okay, so Piyush says, do we get any material when we can learn how and when to use codes in Python and what all are different codes under Python? There are many codes under Python, Piyush, but I do not want you to learn everything. Do not learn everything because we are not going to be the developers. The objective of joining this course is you to become a data scientist, and a data scientist wants to explore the data well, not to build a tool, technique, or an application. So do not try to learn everything. It is very vast, and you will be focusing your energy in the wrong direction. Instead, learn it to the use of Python to explore the data, to manipulate the data, and we will focus more on the concepts of data analytics and forecasting techniques. So team, I would expect you all to talk to me, right? We are not in a face-to-face environment. I hate to do that, but that is how we are going to do these sessions. Please talk to me instead of chatting. At times we may not be looking at the chat windows, so I may be missing on your questions. All right, so first thing that we will do in Python, of course, are you familiar with the Jupyter Notebook? You all know how to open it?
Yes, ma'am.
Yes.
Yeah. Okay. So the first thing that we will be doing is importing the libraries. And here I'm importing OS to help me figure out the working directory. If I do need to change it, then I'll change the working directory. Import pandas, of course, data frame manipulations, and NumPy for numerical manipulations. I'm just going to run it. If you want, please do it with me, right? I'll be slow so that you all can follow along. And if you are doing it on your system, you can absolutely work on that. Thereafter, once you import all the libraries, we need to understand where we are. What is the current work directory? So let me run this. I'll say os.get current work directory. This CWD stands for current work directory. Get means you are asking Python to get it for you. Once you run the command, it takes you to the place where the Python currently is pointing at. So it is currently pointing at this folder where I do have my file. So I'm absolutely correct to extract the file, the food nutrition file, and bring it to Python right now. In case you are not where you have saved your file, then you can use this command, os.ch stands for change. So change directory is what you can write and provide the path. So you go to the file location. Say, for example, if my file would have been this one, then I'll go in this place, I'll right click, click on the properties, copy the location, copy it over, come back to Python. In the os.change directory, you just copy paste the location. That is what you do, and you run. So next time when you run the get current work directory, after you have changed it, your location would be directing you to where the file is located.
Karuna, on this point, right? So not just with this one. So when you say, see, you are aware of what get CWD is, right, as a function. So what's the best way to know what sort of functions are there within that module? Because it's like there are going to be multiple things under it, right? So is there a way to learn, as we try to solve problems, which function to call and how to access them?
You will be very used to it. This is the first session and I know the apprehension, that is why you're asking, but you'll be very used to it. Few of the things that we use, right, that you'll be using most often from OS would only be the get current work directory or change directory. These are the two things that you'll be using. That's all. When you work with pandas and NumPy, few of the things that you'll be working on is to how to read the file. So reading XLS or reading CSV, different kind of file versions. Once you get the file, you should be able to navigate to the first few or last few records of the file, because it is a check that you have been able to import the complete data set successfully. So maybe head command and tail command, right? Once you are sure that your file is there, then all you can expect to do is to go to and check describe. Now, describe is going to give you some kind of summary statistics. When I say summary statistics, if I share a data set with you, a particular number, right? I give you 10 numbers, and I say, okay, what do you observe? You may be doing some mathematics in your mind, right? You may say, okay, maybe the average of all of these numbers seems to be 25 or 30. It's subjective because you have not calculated it, but yes, some kind of logic runs in your brain. So describe function would actually calculate those minimum value, maximum value, what is the average value, what is the variation, all of those for you automatically. Then you also, because in the data set, sometimes you would see that the information is missing. Some of the cells are all blank, and we will have to get rid of the blanks or impute the blanks. Imputation will be taught later, but today we will check how we can get rid of the blanks. So of course, missing value, right? So for missing value, you would be just using is null. This is the command. Then if you have to drop the missing value, you'll be using drop NA. Missing values are termed as NA, so you will drop NA, right? And then maybe you want to check all the data types, what are the columns and the data types, so you may work with info. You want to check what is the dimension of the data, how many columns, how many rows you're working with, right? How many rows are also known as observations. So how many variables which are columns and how many observations that are rows. So you will use shape command. These are the commands that we will work many times. You'll get used to it. Then when we work with a data set, at times you may have to refer to only few cells, right? Few columns, few rows. So iLocation, you can work with iLocation. I have a small example for that, but we will build on. I'll give you sufficient materials that you can refer to, links that you can refer to if you want to build upon your learning. At time, it is important for you to maybe look at a particular column, not the whole data set. Only look at a particular column, understand what is the data type of that column. So then from the data, refer to that column and only impute the D type. D type will give you the data type of that particular column. Like info can give you the information for all the columns together. D type is to focus on that particular column. Simple data manipulation, whether that is division, multiplication, those all will be common. I'm going to share that in case that is required. Less than, greater than, how do you sort? And then of course, if you want to extract a particular information from the data set basis some column, then we have the some code. So I'll take you through that. It is a little complex to write, but I'm going to take you through that. Maybe we can refer to the food item, and basis the description of the food item, we want to only pick those rows. So we'll see how we can check that. And also, you may want to, you have a numeric variable. It doesn't make sense to you to look at all the bunch of numbers. So I'll give you an example. You have a banking information with all of your customers' age. Age of 32 versus 31 versus 30, you really do not know if that is going to give you a lot of information when you build a model. So why not combine the group? So how can you combine the group, or how can you cut the data in separate bins or separate groups? So that is using the cut command. So we have different commands also. I'll share that with you. So these are some of the, pretty much a few things that we will be working today. I'll reiterate these things in the next session, and then we'll build onto it. We will go through some of the visualization techniques. But pretty much, if you are able to work on this for the first few sessions, That's sufficient. There are some mathematical information that will be shared. Just to start with, let us start slow and master these. But I'm going to share a lot of content to you over WhatsApp. So in case you feel that you have more time, you can invest some more time to learn it. All of you can go through that and build on your learning experience. Okay, so with that, let us proceed. So we have current work directory. I was able to check. My file is in this work directory, so I'm good. In case your file is not in the current work directory, then please change it. Go to the file location, click on properties, copy the location, paste it here, and change it, and then we will read the file. Let me know whenever you are ready to import the file if you're doing it with me, and then we can proceed. Maybe after this, after you change, you can again run os.get current work directory. It should direct to where your file is. Okay, so now if you have to import the file, and our file is in XLSX format, so all you need to do is from pandas, right? PD stands for pandas. You will have to read the file. If it is Excel, you will say read XLS. If it is CSV, read CSV. So our file is Excel. So PD dot read, and then there is an underscore EXEL, Excel. Open the bracket. Within inverted comma, you have to write the name of the file. Once you are able to write the name of the file, I would also expect you to view first few records. So let me know if you are able to view the first few records.
Ma'am, just a doubt Subhota here. I am still with that importing the file. This location, I have to put it in current one directory, the brackets?
Yes, in the bracket
Okay.
and within the quotes. That's right.
Single quote?
Single quote, yeah, single double will work.
It's coming as syntax error, ma'am.
Try doing giving a slash here. After C, give us double slash.
This colon and slash is already there.
It's still giving you a syntax error.
Yes, ma'am.
Can you share your screen? Let me see if I have. I think I've not blocked you. I'm going to stop sharing for a while, and I'll allow you to share your screen. We can fix that and then move forward.
I have shared mine, ma'am. Have you got it?
It's coming. Okay. Put one more slash after C colon. One more slash. Yeah.
Here?
Yes.
Across the whole string of the path, you have to do double slash.
One more slash. Please include one more slash.
One more slash there, ma'am.
Yeah.
Yeah.
Click on run.
No, I think you need to use across.
Oh, it is the get.
He's
See,
doing
you're
a get
using
CWD. Yeah.
Correct. Okay. Yes. Good catch. It's change work directory, right? So CHDIR.
Okay. CHDR.
DIR. DIR will be directory, and use get rid of get. Yeah, get rid of get. It is only os.chdir. Yep. Now try to run the read the file from the location. You'll be able to.
Okay, right. Thank you, ma'am.
Yeah, you're welcome. And please, I appreciate the way you took the feedback, but we, yeah, all of us are in the learning phase. We have to help each other. No error is a small or a big error. I'm absolutely fine. You asking in even the smallest things, right? That's absolutely fine. Okay, let me share my screen and we can proceed further. So try reading this file. I'll allow a few more minutes while we are here, and then we can work on these. So for those of you who are able to read the file, let's attempt this. It says view top 10 rows. So it's pretty simple, right? We were able to jot a few commands. Sorry?
It's dot head.
Exactly, you got it. see what it does. If I say get me only, okay, it says view top 10 rows. Do you get 10 rows when you write dot head?
0 to 9.
Okay, do you write 10 in the bracket?
Yes.
Yes. So it's pretty simple. Let me also do it. I'll say data df, right? Dot head. We have to attach. So you will see in Python, there's a normal way. Whenever you have to call a function, a method, you will give this dot. That means it is attaching that function to the data frame. So dot head. If you do not give anything, then it is not going to give you 10 records. By default, it gives you 5. It is going to give you 5 records. If you have to view 2 records, 3 records, 10 records, how many records you want to view, you just have to enter it. If you want to view 10, you have to enter 10 here. If you want to view 2 records, you have to enter 2 here.
Karuna, on that point, when you typed in head, right, is there any easy way or shortcut to know what that function actually does? So because when I was playing around, I just bumped into this. I put a dot and pressed tab. It gave me the list of functions that are there. Is there any easy way, you know, okay, this function is going to do this?
There is a metric cheat sheet. I don't know if you all have seen it, but it is there uploaded in Olympus. Okay. If not, yeah, refer to that. That has the details. That has a cheat sheet.
Shift tab should work, right? When you get a description of a function.
Sorry?
Shift tab.
Tab to get a description of the function. Yeah. And you all have a lot of questions right now because you are new to this. Trust me, these all you'll be able to understand what this does. So if you are learning right now and you're not able to understand what it does, after you are able to execute and you know what it is doing, or you hit tab and then understand what the function is all about, make a note in your notebook and just write simple statements like head will give you first few records, tail will give you last few records. That's also a good way to make a note to learn. Okay, let's see who can attempt this. Can you give me the last 20 records? The last 20.
You just said it is dot tail within bracket 20.
Okay, so then you give your data set, data df, dot tail, in the bracket you specify 20 records.
Ma'am, Nidhi,
Yes,
here,
please.
I have
Yes,
one
Nidhi.
issue. Actually, I have a Mac. I'm not able to, load the file. I'm entering the correct path, but still it's giving me invalid syntax.
Okay. So Nidhi, can I, because Mac will have a little different process. I'm not sure if any one of you using Mac, anyone else? Yeah?
I'm using a Mac. So Nidhi, what's the path you're getting on your current working directory?
I'm getting users and then my folder name. So users and Nidhi. And what I did was that I pasted, where I saved the food nutrition file. So I've just chatted. So this is the command which I'm using, os.chdir, and this is the path where I have kept the food nutrition file, but still it is giving me invalid syntax.
Okay. My suggestion on that one, under Nidhi, just create a separate folder called GL or Great Learning.
Okay.
And then use the similar syntax, which is os.chdir in quotes, single / users / Nidhi / GL. And it should work.
Okay, so basically I should not be in the downloads path, right?
Yeah, downloads, for some reason it didn't access for me as well. So I just created a new folder in,
Okay, got it. Yeah, let me try that. Thank you.
Cool.
Okay, Nidhi, if you are still not able to find the way, let us know, and I'll let who helped. I'm trying to recognize your voice, team.
Pavan.
Sorry? Pavan. I'll let Pavan share his screen and then help you out, okay?
Okay, yeah, thank you.
Perfect. All right, so we were able to work with first. So what did we do? We read the file. First of all, we understood where the current work directory is. For those of you whose current work directory was referring to a location where the file was not saved, we were able to change the work directory. We were able to read the file using read command, pd.read. We were able to refer to the first few records and the last few records using the head and tail command. Next, we are going to check what is the dimension of the data set. Right? These are the few things that we are going to check for every data set, not only right now, but once you are in a frame when you are okay to build the algorithm, then also you'll be doing these all steps. So what is the dimension of the data set? What would you type?
Dot shape.
Dot shape? All of you will agree to that?
Yep.
Okay, I'll also do that. Data df dot shape. Perfect. Now let us also check if we have any missing values in the data set. Before we go to that, here is a print command, right? Print command will print the information, whatever you want, and you're writing it in inverted commas. In these commas, if you write the text, it is going to print that text for you. So in shape, it is only going to return you the number. 600 refers to the rows. So first the information about the rows and then information about the columns, because you have 20 columns. Suppose you want to print that the number of rows are 600 and number of columns are 20. So for that, use the print command. Under inverted commas, you have to write the text that you want to print and then give the command data df shape. And here 0 refers to the first aspect, right? It's the index to the first location in this array list. So it's referring to the 600. And then /n will help you go to the next line. In the next line, you are again printing the number of columns are, and then from the data df dot shape, you are referring to the index of the first location, which is for the column. That is how you are getting these two lines printed.
Karuna, for
yes,
hello?
yes, please go
for
ahead.
When the print command comes, it is always that the second line will be one space indented to the first line. Is it?
No, not really. There must be some. It doesn't. It should not always, but I'm not sure why it is doing it right now. It is intended.
Yeah, for me, for us also, it is doing the same.
Yeah.
So
okay. No, I have printed and it used to come to the same location. So I'll check why. But this n will give it to the next line. Take you to the next line.
You can actually add that additional quotes and add it to the next line, so it will come in the same without any indentation.
See, you all know the answers too. Okay, now we will check for some of the missing values. What do you think?
Karna, 1 minute.
Yes.
Actually, why do we use a comma there? The number of rows are, and then we use the inverted double quote.
This one?
Yes.
This is because we want. So whatever you're writing within the double quotes is what exactly will be printed here.
Yeah, that I understand. After that, we use comma.
Yeah, because
so
what you want to print, right? What you want to print after this, this is the command. This is not the information that you wanted to type. This is the command. So you say that you have to print this, comma, you have to refer to this command, then comma. It is a syntax. It's the way you write. Because it means that you're asking Python to go and fetch you the result basis on this command. Don't take it as a text. It is a command actually.
So does the comma input any space here?
No, space is here. No, it will not. It is going to just do this. We inputted a space here after R. Okay, if you have to check for missing values, what would you do?
Is NA?
Is null. NA means is null. So we will say data df is null. And suppose you only entered this. And I'll show you something else also. So is null will give you information about the complete data set. You will see a true if there is a false, if there is a blank, and you will see a false if there is a value. So it's very cumbersome to find whether you have a missing value or not, right? So you should always develop a habit of writing sum. By doing this, you're going to get a list of column, and wherever you have a missing value, it will give you the total sum of missing values. So if you do that, you see that for lipid total you have one missing value, for ash you have one missing value, so there are only two missing values. And if further you want to see, okay, overall in the data set how many missing values are there, you can just type in another sum, and it is going to give you, in total you have two missing values. So 3 steps. I don't want you to do 3 steps, right? It's just for information sharing. You first say is dot null, but it just gives you a true false indication for entire data set. That's very cumbersome to read. So the best is you say is null, and then type in the sum command, which will give you the missing values by each column.
Just a quick question.
Yes, please.
So the is null without a parenthesis is also throwing some
information
output, right? So how to read that?
So it is telling you all the information, right?
Yeah.
It's very difficult to read. You may not be able to read because it is just going to give you the list of information, and it is not the right way of reading. You're not able to read anything. It is just giving you a bunch of columns information.
Right.
Yes. So no, this is not how you would be able to check missing value.
So adding on to that, when do we know that we have to put a parenthesis and not? Because for shape we didn't put, for is null we are including it.
With
Some we
practice,
include.
yes, with practice. Practice is
Right.
the
So we
key.
need to make note of it. Yeah.
Yeah, and then by 2-3 times you would be well aware where you would put parentheses, where not.
But logically, what is the difference, Karuna? Like with putting one and not putting one, what's the logical?
Usually I would say that is null is calculating something, sum is calculating something, shape is just returning the value.
Okay.
Yeah, and there are other commands also where you will see the describe function, right? We are calculating the minimum, maximum standard deviation, so we'll have the parentheses. When you are telling it to perform some functions, you will give parentheses.
Got it. Thanks.
Okay, you're welcome. Okay, so now what we have been able to identify the missing values. Now, if I want to drop these missing values, imputation of the missing value is critical, and that is what we should do that because, we get a limited number of observations or sample size. If we keep losing the samples or observations because it has missing value, that's a very wrong approach. So if possible, we always try to impute. But imputation of missing value would involve some, some methodology. So I'm not going to go into that right away. We'll talk about some of those in advanced stats section. Right now, we will just drop these missing values. And to drop it, we will use drop NA. It is going to go and perform some function on your data set, and it will delete these 2 observations. Now, it is not going to delete the cells, right? It is not going to just get rid of the cell from the lipid total or cell from this ash where you had the missing values. It is going to delete the complete row. The drop NA will delete the complete row of information. And once you drop, it is a good idea to check is null command again to ensure that if the missing values have been dropped or not. So now you see there are no missing values, and you may want to also check the shape command to check how many values you have. So if you want to insert any any chunk, you can just say insert whether you want to insert below or above. That this way I was able to insert this, and so it is going to give you have 598 observations and 20 columns. Earlier you had about 600, right?
600 and
Yeah. So now you were able to drop it correctly. I'll take a pause, and Nidhi, are you able to locate your file? Are you able to run these codes?
So I was able to, do that CHDIF function, but when I do pd.read Excel, it is still not able to find the file. I don't know, but I've kept it in the same folder. So
Okay.
I'm just following what you are showing on the screen, but I'm not able to do.
Okay.
So this worked for me as Pawan shared. So now I could there was no error for this, but I mean the command where we read the file.
Okay. That is not working.
It's not working.
Okay. Can you please share your screen, Nidhi?
Yeah. Okay.
Team, allow us a few minutes. We'll let Nidhi also come on the same pace. Thank you. So you have written CWD, right? Where is CWD? Module OS has no attribute. os.chdir. So you have changed the work directory.
No.
Yes, just pick one. Nidhi, can you just leave a space between food and nutrition and try it? You're still getting the same stuff.
Can you take us to the file? Just see what the name of the file is.
yeah, it has to be copy because it is second copy, so it has to be a copy of that. So file name will have include a copy.
But that's how it is showing in my
in the folder.
Yeah, in the folder.
Take us to the folder, Nidhi.
So I have to share the desktop, is it?
Yeah.
Wherever you're locating this file, wherever it is located. So in your Great Learning
I share
folder.
the desktop, then I can show the entire this thing, right?
That's right.
Is it visible, the desktop?
Desktop is visible. Go to your location, users, Nidhi, GL. Okay.
So this is Great Learning 1 folder, and this is that file, food nutrition 2.
Copy the, is this the file? Are you sure? Okay. Yeah, copy this file name.
Okay, the file name, okay.
And remove this too. Let's make it simple, right? Remove this bracket too, something. And you also remove the space. And remove the space after food and nutrition.
Yeah. Okay, 1 second.
File name seems to be wrong.
Yeah. And now refresh it.
Yeah.
Okay, it's done.
Yeah.
Okay, now come back to Python.
Copy this file name, Nidhi.
Okay. Sorry, I think I copied the file, right? Sorry.
No worries, no worries. Go to rename and copy. Click on rename. Yeah, and then just copy it over.
Yeah.
Control C.
Yeah, I'm a little fidgety with these things, but
Yeah. First few times, right? Do not worry. .xlsx. It has, yeah. Perfect. And now run it.
Yep.
Okay. Do this data df dot head underscore df. Yeah. Dot head. And in bracket, maybe type 2. Yeah, I just want to see if we get any perfect. Okay?
Yeah, thank you.
Awesome, you're welcome. Okay, now let me share. So Nidhi, if you missed on few steps and you cannot follow, don't worry. I'll send the sheet to everyone. You can just follow along from this place. Just type this is null and drop NA.
Okay.
Yeah. So first type in this one is null. And then, and for others, why don't you type syntax to give me the summary of the data? Summary of the data is again very important part of information that we do not let go, because it at a very quick snapshot view, it tells you what are the high, what are the low, what are the average values, where the variation is. So I'm not going to go in statistics right now, but it is going to give you a bunch of numbers and also give you what is the 25th percentile mark, what is the median or the 50th percentile mark, what is the 75th percentile, etc. And what is the total count of observations for each and every column. So let us do that. Nidhi, you good with drop any?
Yes, Karan, I'm following now. Thank you.
Okay, so now you can just start with this. So I'm just going to use describe function. As I said, describe is to give you summary statistics. Okay, data df, data underscore df, right? We have to be very sure about the name of the file, otherwise it is going to throw an error. Describe. Now, can anyone say, what if I want, if you have not lot of columns, right? You are scrolling it right now, but you don't want to scroll. You just want to see maybe a column in this first column, all the information about the index or the variables. How would you get to that view? If I want NDB, water, energy, all the columns to appear in your first column, and the count, mean, standard deviation to appear here.
Sum.
Table and
Dot sum.
Dot sum is going
Describe
to
dot
add.
sum.
It is going to add. No, it's very simple.
Group by.
Not really. Apply the logic. What do you do in Excel? Change the column to row or row to column.
Transpose.
Exactly. Transpose. Yeah. See, then you're going to get everything transposed. You have your count, mean, standard deviation, min, max, and all of these percentiles here on the column, and you have the information about each of the columns here, the rows, in the rows.
And the transpose is cap T.
Yes. Now, what you get, these numbers, right? If it doesn't make a lot of sense to you, don't worry. We'll invest a lot of time in stats. You'll get a hang of what these numbers are telling you. But mean is the average, right? And we are very familiar with average. If I give you 5 numbers and I ask you to take the average of it, you will just have to add the numbers and divide by 5. This mean column is giving you the average. Count is the count of observations in each of these columns. We don't have any missing value, and hence you see 598 observations for each of these columns. Standard deviation is how much the values are deviating from the mean, right? It is the spread of the data. How is the data scattered from the average? What is the normal dispersion or spread or scatter of the data? Do not worry too much if you don't get the concept. We are going to go in the concepts when we learn statistics. Min is the minimum value in each of the columns. So it seems that for minimum value of water, it's 0.2, but pretty much for all other columns, it's 0. 25% mark. If you sort your data for each column and you want to check, okay, what is the value at the quarter, right? The first quadrant or the first 25% of the data set in a particular column. This is giving you that value. 50%, what is the value at middle, right? It's the median value, the first 50% in the sorted data. This is the third quartile or 3/4 of the data, 75% of the data. What is that number at the 75th percentile mark once you sort the data? And max is the highest value. Nevertheless, what I want to focus is that describe is going to give you the 5-point summary of the data set. Now, this is interesting, right? It says create a vector. So very similar to this, I want to create a column, a vector test, using the top 10 values of the variable protein. So where you see variable, it is just the column, right? Column name is termed as variable. So for the protein column, I want to extract top 10 values. And I want to save it in another object called test. See, how do we do that? So I'm just going to declare an object which is test, and I'll say from my data, so the name of the data is data df. So from my data, if you're referring to the column, you will have to put a square bracket, and the column name must appear within a single a single in comma, you can say, or, and you just type the name of the column. I think it is typed as protein underscore G. So I'm just going to type the name of the column should appear as it is in your data set. Otherwise, it will throw an error. So what I have done, I've created an object. In that object, I'm just storing the value of protein column from my data. You have to refer to column, put the square bracket, and name of the column in this single quote. And because I want only top 10 values, what is the command that you use to get the top values?
Dot head of 10.
Dot head,
Dot
right?
head. 10.
So I'll say dot head, and I
10.
want 10 values. I'll just say 10. Now, will this give me this output? Try running and then let me know why is it not going to give you any output. So I've saved the information in this object. It is not giving me any output. Why is it so?
We need to print test.
Exactly.
Yes, yeah.
We have just
right.
correct. We have just said that we are creating this object. The value is stored, but I'm not calling that object, right? You have to call that object as well. So test, and then it will give you the top 10 records. So it is not sorted. I did not ask that I need to get sorted values. That we will check in a in some more codes. Yes. Do we have a question?
Yeah, sorry, this is Guru here. We are saying more than 10 records, right? It is not 10. It is.
This starts with a 0, right? It is actually 10 records, but you tell me what is missing. It's a good observation, Guru. But a question to all of you. Are you getting more records than 10?
No, 4 is missing.
No.
Exactly. Why is 4 missing?
0. I mean,
Null value.
Null values, right? We took two rows. Yeah, that is what is missing here. But you have actually 10 values. All right. 3 and 4 is missing. Correct, Piyush. Okay, so this was extracting the top 5, values. Now, yeah, please go ahead.
So, does that mean that if we access head through a particular column, the null values are not shown? Because in the previous instance, when we just typed head, the null values showed up, right?
We dropped the rows, right? If you drop the rows, and we did not save it in a different data set. We're just using the current data set, and we dropped the observations. The index of those observations are gone now. So Python had 0, 1, 2, 3, 4, 5, right? But we had 2 values in row 3 and 4, and those were dropped. So index is not changed, but you see there are exactly 10 values. It's just an index number given. Is how the data is right now for you. The index just tells you that because you dropped row number 3 and row number 4, it is not showing up. That had missing values and you just dropped it. Right? Does it make sense?
Yeah, okay. Got it.
Okay, so now we will select top 5 rows of initial 5 variables in matrix format. I want to extract 5 variables, right? So let me actually insert cell above, and I want to quickly see data df head, and I'm just going to print two rows because I want to see these names. Now the question is, select top 5 rows of initial 5 variables in the matrix format. I want to be able to display this small table from the entire big data set. And here I was saying that iLocation maybe is a good to refer. I'll give you a lot of reading options on iLocation, but it is pretty easy. The location just tells you that in Python, the location starts from 0, right? Similarly, this one, the row indexing starts from a 0. So this is first row, but ideally Python calls it a 0 row. 1, 2, 3, 4, it will go on and on. It is going to start with 0. The number of columns also will start from 0. 0, 1, 2, 3, 4, 5 and all. So I want to extract the first 5 rows and first 5 columns. I'll say data df index location, right? Index location. I'm calling this function index location. Because I need to refer the rows and columns, square bracket. Now let me give index of rows. In I location, I have to take first 5. So I'll start with a 0 index. That is what Python starts. Now if you say 0, 1, 2, 3, 4, you'll get 5 records. But if you type 0 to 4, you are only going to get 4 records. Why? Because the last index that you provide is excluded. The last index is excluded. So if you want to get 5, you actually want to ensure that you cover from 0 to 6 columns. So 0, 1, 2, 3, 4, 5. If you write 5 here, it will actually mean 6 to Python. Python is going to exclude the last one. That's how it is. This is for the rows. Similarly, for the columns, I'll say, okay, start it from 0 index, but select 0 column, which will be this. First column, second column, third column, fourth column, right? So 0, 1, 2, 3, 4. But because we have to include this, I'm just going to give one more, which will say 5. It is just going to exclude this and give me the information till protein. So 0 to 5, just include one more in the index. Here is how you get that. So I location. Okay, I see a little bit of chat messages. Let me, while you type in, 3, 4, sorry, my mic is not working. I'm not. Yes, you're right. Okay, no problem, Piyush. Next time, it's the first few time that you are facing the technical issues. Maybe you're able to fix it the next time. We'll be able to hear you well. All right, so what is the data? All of you are done with the iLocation?
Yep.
Okay, perfect. So now we are going to check the data type for a particular column. Now, if you have to check the data type for everything, you will definitely go and use info. But if you are referring only to one column, then you will just write D type, which is a data type. Refer to the column. Again, for column, put the square bracket, and within a single quote, name of the column. So the question is, what is the data type of sodium variable? From my data set, in the square bracket, write the name of the column within the quote dot D type, data type. Also write down a syntax to get the info. We did not do info, right? Sorry, not this. So data type is going to give you the data type of a particular column. What if I want to know the data type for each and every column? So data df, without even referring to a column, because we want to consider all the columns, just the info command will give you all the columns, and here it is telling you that it has these many values. It is not null, but these values are integer. Object is categorical variable, and a categorical variable has different levels. So I'll give you an example. Gender, right? Gender has male, female, and that kind of information will be repeated for all the customers. So wherever you have some levels in your column, like gender or education or marital status, etc., those are called as object or categorical type. Then we have float, where you have a decimal, integer, float, object. These are the 3 types here, I believe. All of you with me?
Just one question there. So,
Yes.
alternatively, string, I mean, when it comes to short description, it is also string, right? So, how does it differentiate between object and itself, string itself?
So usually if it is a string and the value of string is repeated, it is going to say that it is an object. Python doesn't know that. It is going to tell you that it is an object. In the short description, you would see that some of the description are exactly matching with others, and hence it is termed as object.
But we do get string here also. Are we saying that? I mean, if it is not repeated, then do we get string
No,
also?
it will be object
Or
only.
it will be always object.
Yes,
Okay.
object. Okay. Now let's create a new variable. Now you know that when we work with data, of course, there are instances when you add one column. Take an example. You have a credit card data set, right? And there was a particular amount due, say 1,000, minimum due was 1,000, or say 1,000 was due, and you paid up 500. Now in the modeling, when we attempt to take all the columns, and if there are two columns that are giving you relatively same kind of information, there was a total due and you paid up something, it's better to combine the column and form a calculation. When you combine the column and form a calculation, that means that you're introducing a column. So how do you introduce a column in your data set? Here we are going to do that. So it says that create a new column or new variable, which is the name of the new variable should be EPW. Okay, and the new variable should be dividing the energy calorie. So whatever the value is there in the energy cal column, you have to divide that with water. And then once you do that, you have to check the dimension of the new data set. Of course, when you add a column, it means the dimension, earlier dimension was 20 columns. If you add this, your new dimension should give you 21 columns. So let's see how we add this. Whenever you have to add or refer, you give your data set in the square bracket, right? This is how you would either refer, or even if you have to create, you will do that in the square bracket within quotes. Type the new column name, so EPW. And what is this doing, EPW? It is nothing but it is dividing, right? So I'll take the data and I'll say this EPW is actually dividing my energy. Okay, energy is ENERG underscore cal. It's dividing energy with, again, there is a separate column for this data set, which is water. And water is written as water underscore G, and in the water underscore within bracket you have G. So data df, add a new column in the same way as you refer to the column, but the calculation says that this column should hold value which is energy divided by water. So from the data set, refer to energy divided by column. And now if I want to check what is the shape, you can run the shape command and you will see that there are 21 columns.
Ma'am, one doubt.
Yes, please go ahead.
Here we have not given any command to add it in the column.
By saying that you are adding this, right? Data df, when you give a column name, it's not an existing column name, right?
Agreed, ma'am. But suppose I want to add a row.
Sorry, you want to add a row?
Yeah.
But we never add rows to that. For that, you will have to concatenate. Concatenate two data sets. You should have. Yeah, you should have some information. For the current data set, if you want to see first few records, I want to see what calculation is available in the EPW column. So check the head command and scroll towards your right. It is going to add that column at the end. Whatever new column you'll be adding, it is just going to add it at the end. So you have EPW, and this is the calculated information. All of you with me till now? Anyone wants me to wait?
One question. Decimal digits, do we have an option to limit them to 2 or 1 decimal digits?
Yes, we give round 2. It will round it up to 2 values, and we'll take you through all of those. But in case you want to inquire, you want to practice, please do some research and practice. But yes, there is. Check round command. ROUND.
Yeah, it works. Thank you.
Ma'am, for me, the EPW is giving an invalid syntax.
Yeah, okay. What is the syntax that you're... Let me share the syntax, okay? This is what...
I'll just check again.
Yes.
Data W.
What are we using the round command which you just mentioned?
To limit the number of decimal places in the digits, in the result, in the integer.
Okay, so where do we use the round command then?
And after just type in dot head braces 5, after that you just round off 2.
Inside the parenthesis?
I can paste in the chat.
Yes, I've got it. Thanks. EPW. That problem is solved.
Hi Karuna, is it possible to place the newly created column prior to a particular column? Currently it is placed at the last column, right?
I think we may need to change the index position for that.
Maybe. Okay.
Yeah.
So, okay, yes, so iLocation, the index location that we use to, extract first few rows observations, the iLocation command has certain information with the help of which you can change the order of rows, columns, you can do a lot of manipulations. So I'll share an article that you can read and do a lot of experiment on the data set. That will help you. The sequence in which we are going through, so these questions that I am introducing has a concept, right, has a theme, because these questions will help you understand how you extract some value. So today, if I give you a data set and I say, okay, this is your customer data set, you just want to check those customers who bought the value of goods worth 10,000 in a particular month. How would you do that? Or if you want to see, okay, who are the customers who are giving you maximum sale? You want to check at the first few records, you can sort the information. So all of these questions will help you build the logic of how you can manipulate. Do we have a question? All right, so now we create a subset of the data set where energy cal is less than 500. What is the dimension of this new data set? So there are two things. You have to create a data set now. Right? The DF is original data set. You have to create a new data set. So let's name it as data DF new, data DF1, however you want to name it. And you're asked to save only the information where the energy cal is less than 500 in your original data set. So I'll refer to the original data set, and this is the logic that I'm giving. That in the data DF, refer to column energy and only take values that are less than 500. All of this will be saved in a data set, which is data DF new. And for this data DF new, because I want to check what is the dimension, you will use the shape command on this. Let me know if you are able to get the same number of information, observations, 562 observations, and your number of variables should stay intact. You should still see 21 columns.
Yes, we do. Yeah.
Yeah? Perfect. Whoever is ready can go to the next question and try attempting. It says find the top 10 products. Top 10 products, and I have several questions. The first one says, higher the energy calorie, higher the ranking. You want to see the top 10, but it says higher the ranking, right? Which means that you have to sort it. So try attempting this. And let me give you a hint. I'm going to refer to the original data set, right? I'm not using this new data set. So let's refer to the original one. From this, sort values is the command that sorts the values. And you want to sort the values by which column? By energy. So we'll say by, in the single quote again, ENERG. Make sure that you spell it correctly. kcal. And because you want the ranking to be high, you want it in descending order, right? So you just write ascending is equal to false. And you want to check only the top 10, right? So again here, you add a command that says head and 10. See, it's particularly, it's absolutely in sequence. I'm using the sort command, sort values. How do you want to sort it? By energy column. Ascending is false because you want higher the value, higher the ranking. And you are to pick only 10 products, so you will say head 10. So it should give you the top 10. And you can actually see the energy kcal is sorted. Do the same thing, right? It's the same thing, but the question is little reversed. Now I'm saying lower the water content, higher the ranking. So can you type solve for this? You have to, yes. Lower for lower ranking. No, it's still ascending, but we will take ascending as true. It's still ascending, but we take ascending as true for lower. So true false has a significance, right? In most of the command, you would see that there is a particular syntax. The true would do something and false would do the opposite. Similarly, if you have to sort using lower content, then you'll just say ascending is equal to true. Maybe just copy this over. Right? And you have to sort using water. So instead of energy, type the water. In ascending, we just write true. That's it. So this is how you would sort the values, right? First, we were able to extract the values that had energy greater than 500. Try to compare it with the normal data set that you see. For some customers, maybe you want to check if the value of purchase is more than 10,000, 5,000. What is it that you can do? Now, if you want to sort your customers basis the value of sales, then here is how you can sort. So always link it back to the real data set and understand the logic. It will be quite easy to follow. All good till this step? All of you with me?
Yep. Yeah.
Yes.
Yeah. Okay. Now, okay, perfect. Now this is the next question. Create a subset of the data where the product description contains cheese and also list down the summary statistics of the subset. So summary statistics, right? Of course, we know that we can get it from the describe command. Describe command gives you the summary statistics, the 5-point summary, min, max, and all of those. So that you know already. Now, it says create a subset of the data. You know, when you have to create a subset, you have to define an object. So maybe create a new variable, it's a new object itself. But that subset should contain the product description of cheese. So product description is in which column? The short description, right?
Yeah.
So we will refer to this column, short description, SHRT _ DESC. So let's define. So I'll say data df and make it any thing, 1, 2, 3, or say cheese. Right? This is an object I have created, subset of the data. And it says when you create a subset, you need to refer to a particular column. I'm going to refer to short description, SHRT, because that's what it is asking me, DESC. Or DESC, maybe it's in capital. Yeah, short description. Now I have a string command that you can use. It says wherever the string dot contains, the string, the value contains the word cheese. So in the double quote, and if you see all of these are in capital, right? So if you you have to just mention CHEESE, it is going to refer to these string values in the short description column. And you can check the you know, the description of the data set. You can check the shape. Describe will give you the information.
Just one question, ma'am.
Yes, please.
Yeah, so I just try to do in cheese. I mean, try to compare that with a list which contains a single value. Cheese is I don't know if the syntax is right when I say in cheese, but rather than using these functions, is there a way to compare it quickly with you know, another list which contains a single value, such as cheese?
You can, but if that list is somewhere, right? If that list that you're referring to isn't somewhere.
I'm typing it actually as a literal.
In a data frame kind of situation, you can compare that when you write, and then you can compare in array or when you provide that. But in a data frame, it is a little tedious.
Okay.
Yeah, I'm not very sure about it, but I can have a look at it and then share if there is any particular way.
Sure, thanks. I was just trying to understand the compatibility of these comparisons.
Yep, I know.
Thank
So
you.
I can relate to that. My husband, who is a developer, who does all the automation, he keeps typing this tuple and then list. He works a lot of those metrics. Okay, so all good till all of you are with me till describe function. We were able to create a subset. And then we were able to also see that there are 74 observations and 21 columns. And this is how we describe new data set. Now I'll share something very interesting, right? When you'll get the code, you may find some additional codes also, because there are the same thing, you may want to do it differently. So ideally, the sessions that we take, if there are other ways, we incorporate those and send you the file. So at the end, you may see that you have additional codes. Always try to practice, and if you have any questions, you can come back. Objective is just to give you more information, the more methods of doing the same task. And this is not only for this session, but you'll keep on getting this in other sessions as well. All right, so let's work on this. And this is pretty important. I'm not going to use any logic here, but this is the thing that we use quite often. Suppose you have a list of people who have different salary structure, monthly salary, and you are grouping basis the salary bracket. Instead of looking at your 10,000 employee in a particular department that who may have 5 lakhs versus 5 lakh 1,000, 5 lakh 2,000 as the salary package, maybe you want to combine and say, give me the employees in these brackets, in these groups. Maybe I want to look at employees with a range of pay from 5 lakh to 10 lakhs, and then from 10 lakhs to 15 lakhs. And this is how we create the group or bins. And it's done by using the cut command. Of course, we specify different logic when we want to create the group. I'm not going to go with the logic now. That I'll share in a maybe a little later sessions. But by default, how do you create that groups? So it says using the cut function on water variable, you divide the whole data into 6 bins, 6 groups, and list down the summary statistics of all the 6 bins. So first of all, define a column. or maybe define a new data set. So I'm saying data bins is my new data set, which is a replica of my data DF. I'm just creating a new data set, naming it as data bins. Because I don't want to manipulate my original data set, I'll just let it be as it is. As soon as you do this and you check the first 5 information, so let me run it, right? And I will show you. So below. Okay, as soon as you run it and you see that data bins dot head, and I'm just checking first few rows. It is a replica of my original data set with the short description, all of this, right? It's a replica, and we were able to add EPW, so it is also available. Now I'm going to manipulate this data set. I'm saying in the data set, I want to create 6 levels for the column water. So basis whatever value we have for this column, I want to group it into 6 groups. So in the data set, you create one column. The column name is bins, right? Like we created EPW. In the same way, you will create another column that says bins. And from Panda, we have the cut command. So pd.cut, where we are referring it as PD, it means it is referring to pandas. So Panda library cut command, and then you give instructions what you want to cut, in how many levels you want to cut, and what are the different labels you want to give. So every group will have a label, right? These are the attributes, or these are the information that the cut command needs. So data bins, I'm not going to execute this line, but I'll type it for you. For this data set, I'm just going to introduce a column, bin or bins, however you want to make a note of. pd.cut will cut the variable that I define. So I'm saying from my data bins, from this data set, refer to the water column, right? And then cut it in 6 different groups. And for these groups, I want to give it a label or a group name. So that is done by giving a label. It's labels actually. And in the square bracket, within the double quotes, you give the label's name. Maybe 1, 2, 3, 4, 5, 6, however you want to name it, or A, B, C, D, E, F. So I'll just say A, B, D, and E, and F. Okay, these are the 6 bins I have created.
So water spelling is wrong.
Oh, water, yeah. See, some of the things in Python, we get the error, but it's pretty simple, right? It's some mistake that we can avoid. And now if you check first few records, you would see that there is a column that is added here, bins, and it is giving you what that particular observation will fall in, which group. And here I have not provided any logic. So it is by default cutting the values in 6 bases, the value of water. It is bifurcating it in range. You may not see that every range will have same number of observations because of the value of water. But in the real case problem statement, we would also give a logic of how we want to create a bin. So that I'll share maybe a little later. We can set a rule that, for this value, take it in this bin, for this value, group it in this bin, etc. That we can do. Now, if you want to check how many values or how many rows you have grouped under A, under B, under C, and all of these bins, then value counts is used to give you the unique levels. For the unique levels in a column, it will give you how many observations are there. So direct it to the column, which is bins. Value counts is the command. It will give you all the bins, and it is going to sort it based on the value of observations that are there in each of these bins.
No, can you just wait for a minute? I'm just
Absolutely, absolutely. You can use without, you can use even single.
So I guess Karuna, to move that bins column that we have created to near the water column, so that it's easy to do, we can look at iLock command, right? Just to make it easy.
Yes, yes.
Yeah.
You want me to go to any of the steps? Nidhi, you asked me to stop for a while?
Yeah, so I'm just trying to understand. So we added bins, right? Then you gave labels.
Okay, so I'll repeat, right?
Yeah,
I'm adding the bins, which is a column, right?
Okay.
What am I going to store in this column? I want to give grouping to water column. Grouping bases the value that is in water column. So for grouping, we use cut command. So I'm using pd.cut. Cut is the method from pandas library, hence panda.cut.
Okay.
What am I cutting? From my data set, from my data database or data I'm referring to, refer to the column water, make 6 groups. So this 6 is because I wanted to make 6 groups. You can do 10, you can do 7 and whatnot, right? Say, let's make 10 groups. And now I'm saying, okay, for those 10 groups, maybe I'll just create another column, right?
Okay.
Bins 10. And I'm saying for these 10 columns, I have to provide a group name. Otherwise, it is not going to understand what group it has created. So I'm just creating a group name. So A, B, C, D, E, F, G, H, maybe I, and J. That is how I created 10 group names. Let me see if it does that. Okay. So now it has done bins 10. It has created the 10 groups. Now, if you want to see how many values are there in each of the 10 groups, then you refer to the column bins, and I believe it is bins 10. So I'll just make bins 10 here. Dot value counts. Dot value counts is very important because it is going to give you the unique, for a unique level, in a categorical type variable, for each unique level, how many values are there? So you have a gender column, right, in your data set. How many females and how many males you are targeting? You will refer to the gender column and you will run value counts on that. That will give you the count for each of the levels. The levels, I mean the gender, right? Male, female. These are the 2 levels. In education, it will be school, high school, grad, masters and all.
But when we are creating these different groups, what is the criteria? I mean,
not right now. That is what I said. Just this is a facility, right? An option that we have. The criteria is always derived. So when we will work on a problem statement and we have to create bins, I'll share how you can also introduce the criteria.
So here it is just dividing everything in by 10. That's what.
Not a real division of 10. Basis the water value, right? Majority of the water has 0.
Yeah.
So you see a lot of values in the first bin. Then you have some. It is depending on what is the numerical value. If the values are very close, then it is binning it in one particular group. By default, it is taking those values basis the numerical value which is available in water column. It is not following any logic right now.
Okay.
Yeah.
Got it.
But we do need to follow a logic.
Okay, that also leaves that the bins can be done only on continuous variable, numeric variable, not categorical.
Right. Correct.
Okay.
That is the purpose, right? You want to group it because you have different levels. You really do not get a clue of, if this customer is different than another customer. Why not group it if they are similar?
Got it. Yeah, sure. Thanks.
You're welcome. Okay, so can we move ahead? All good?
Yes. Thank you.
Perfect. You're welcome. So now if I ask you to give me summary statistics How would you do that? The question was, if you go to the question, it says that list down the summary statistics for all the 6 bins. And summary statistics are given by describe command. So I refer to my data set and I'll say group by bins and then provide the describe. Describe will give me 5-point summary. This describe.t, T is for transpose. If you do not want to use T, you can skip it. For all the different groups of bin, right? For A, B, C, D, E, F, it is going to give you all of these values. There are a lot of ways how you can do this. I'll leave it up to you. I have shared some of the information. You can just give describe command. You can just run for loops. I'll just leave it for you to practice. In case you have any question, let me know. But this is the exercise that we wanted to cover today. There's the last question I had for you. All of you are getting this value?
Yep.
Yeah.
Yes.
Perfect. So I'll send you some links where you can get the data, though the data may not be clean. So do not take the entire data set, right? In Excel, once you import the data set in Excel, let go any of the empty cells or just sort the values and only consider maybe 100 records where you have a lot of values. So 100 or 200 records for few columns. Take only 5 columns or 10 columns from that data set and run all of these commands. See what it gives you. Running of the commands is important, not the data set. So do not worry about the huge data set. Only take few observations, few columns, maybe 100 rows and 10 columns, and then do all of these calculations. Now, when we talk about data manipulation, though I'll cover this in the next session also, some of the numerical aspect definitely will be covered in the next session. But my objective will also be to share some of the visual representation. How can you make some graphs? How can you understand what the graph is telling you? How can you do some bivariate analysis? So those all graphs and plots will be shared in the next session, along with the numerics, right? Some numerics I'll definitely share so that we keep a track of what we were able to cover this session. You get a hands-on in the next as well. This slide just talks about some of the industry example, various real-time applications of pandas. We work with pandas and NumPy all the time, right? Whether it is in financial domain, or it is in marketing, it is healthcare, everywhere, or it is the stock market, any kind of information requires us to work with the data frame and some of the numerical calculations. So pandas, NumPy are very much in use. And this just talks about some of the domain. So in economics, recommendation systems, stock prediction, whether it is advertising, analytics, NLP, data science, big data, statistics, neuroscience, all talks about manipulation of data. And for that, we would go to and check pandas. Here is a link for this blog. You may want to, once you get this file, click on this link. It will give you a lot of good read information. And this is a common practice for all of our sessions. We will give you some industry examples and reference that you can check to get some detailed information of what we covered. Some examples, not what we covered, but some examples from the industry that they have applied.
Karuna, can you go through the for loop in the last one that you have created, please?
Okay.
Just the output.
You want the output of the for loop that was there?
Just the explanation around it. It just seems to be slightly confusing.
Okay. Okay. So it says that you have created subsets of the data set basis on the bins. So I'm just defining for each bin, I'm creating a subset. So my object A will only contain the observation from my data bins table wherever the bin is equal to A. Right? The object A will only cover those observations from my data set for the bins column where the value is A. Similarly, object B is going to contain only those columns where the observation has been marked as group B. The bin is group B. and so on and so forth. Here I have created these objects. And if I want to create or describe it, then you can describe basis a particular object. So take a.describe, b.describe, c.describe individually, and it will give you the summary statistics. This is another way how you can describe it. So for the first part, right, I'll take you through all. For the first part, we were able to group by bins. The group by bins will group it, and you don't have to create different objects. Right from this data set, you can group by bins and just do a describe command. So for each of the bin, it is giving you the count and all of these. It is also going to give you the information for all the columns. But an easier way, right, or not easier, another way is to create different objects itself. Basis the column bins. Now you are saying that only refer to this column where you have bins. Not this, sorry, this one. Only refer to this column where you have bins and pick the observations that I've marked as A and put it in a different object. So in my one object, I'll have only those observations that are for bin A. Then in second object, only those observations that are called as bin B, and so on and so forth. And then do describe command individually on first A, then B, then C, all of these. This is how you can do the describe on different subsets of the same data, right? Different subsets. Okay, so this is the first part. Second, it says that you can also create a loop, right? So what it is saying, it is storing the bin values in a array. So say X is an array, it is storing the bin values. A, B, C, D, E, F, G if we create it, right? Then it is saying for every bin value, for I in X. So when it is I, it is referring to the first position for the first time. Then it will run this command. So for the first column, which is A, it is saying print I.describe, which will print the description for bin is equal to A. Then it is going to run again. It is going to check this and it will say for I in X, next time it will move to B, right? Because it already did the describe command on A, it is going to move one level and it will say, okay, for I in X, now the I is B. Then it is going to say, okay, print the describe command. So it is going to print the description for bin B. Third time, it will move to for I in X. It has already done for A and B. It is going to move to the third position, which is C. This is a for loop which is iterative in nature, and it is going to iterate one by one for each of the lists that you have mentioned in this array. So for each of the group, one by one, it will iterate. Every time it iterates, it is going to perform this command. This print command is performed individually for every time it moves to each of these array objects. That is what it is doing. So first time it is printing the describe command on group A. Second time it will print it for group B. Third time it will print it for group C. So you see the output. This part here, which starts from the first column, NBD, this one here, is for the group A, right? And then once it does it for all the columns till EPW, it will do it for all the columns. You would see that it has again iterated. Sorry, this one. Up until here, it will run for group A. Then it will iterate. It will move to group B or bin B. It will do the same thing. See, the first column is repeated. It will do the same thing, but this is referring to only that group where the bin is B, and it will do the same thing, and the third time it will follow for C. This is how it is iterating. So again, the steps are given. If it is confusing right now, do not get confused, right? We will go into for loop later on when you will be well versed with some of the additional codes. But for those of you, if it is making more sense right away, so you can definitely follow.
Oh, this is good. Thanks, Karun.
Yeah, you're welcome. Okay, so that's all I had for today. Today we will talk about visualization. I do have few questions for you, but the objective of this session is also to take you through the hands-on, because hands-on is the primary objective when we learn a particular language. So we'll of course have hands-on case study and a small part of industry applications, so where visualization or understanding of the data helped and what difference did it make. First of all, let us try to answer this. Basis whatever you have learned in the videos, can you name few libraries used for visualization?
Seaborn, SSNS, and matplotlib.pylot.
Matplotlib, Seaborn, and PyPlot, right? Perfect. What is static and dynamic visualization?
Static is the one which is actually not interactive, and maybe dynamic is the one when we can use some sort of interaction with that.
Right. Correct. Static is the once you make the plot that stays in that 2D dimension, 3D dimension, but dynamic is where the charts are changing as and when the data is ingested or data is run through that line of code, the chart or the graph updates itself to show you the variability. And dynamic visualization is often used in medical field. So MRI scan and all of, if you see the screen during MRI scan or any of the tests that is done, it will show you dynamic visualization. Those things change, right? As and when the processing is done, or you add a lot of data in your medical data in the data set. You want each observation to pass through that. Maybe it is hourly data of one patient and you want to observe the change. There, the dynamic visualization is used quite often. We'll work with static only as part of our session. Then what are the different types of visualization techniques?
Bot plot, box plot, scatter plots.
There are many, right? Perfect. Okay, so this is just a view to help you understand where we are now and where we will go. So first step, it's also a data science project lifecycle. So when we get a use case, right, when your industry comes and tells you, okay, this is the problem and you have to solve that, you first collect the data. Basis the data collected, you do the descriptive analytics. And here, of course, you have to explore the data well. When I say explore the data well, you explore it numerically and visually. And you also make some adjustment in the data. So if the information is missing, or if there is incorrect information in any of the column, how do you fit those all information? Or suppose if you have to make your data in the correct format, not the data type of the variable is not correct, how do you change those all information? So all of those form part of descriptive statistics. We are still here, right? We have yet not studied descriptive analytics. During the statistic courses and advanced analytics, we will work on descriptive stats. After we work this, and understand, okay, this is the data, this is what is actually happening, then we move forward and try to understand why actually did this problem happen, right? With the help of data, we understand, okay, why did this problem come into picture? And that is where we start thinking about diagnostic analytics. We do a lot of search basis a particular variable, which may be the target variable or which may be the variable in question, and we try to link it to several other variables, maybe outside of the domain, maybe within the domain, but different line of business, etc. So those all are diagnostic analytics. We also do a little bit of regression techniques, but not to predict, but to understand what are some of the variables that are playing a lot of importance. We also want to do segmentation to understand, okay, if the market is a question, right, then which segment is driving the sale volume? So all of those are part of diagnostic analytics. And after this, we want to predict, right? Okay, this is the data, this is why it is happening. These are the columns that are important. When I say columns, these variables. And if these are the variables, then how can I make a model to predict tomorrow, if these are the variables that we are capturing, tomorrow this is the value of the target variable. Let us try to understand it with an example. You have accessed or you are in a bank, and your manager says that there are many people who are defaulting, and we need to understand why we have a lot of defaulters, because it's a risk to our business. They are running away with money, and it's a huge financial loss. So you get the data, you understand different information from the data. So you may have the name, age, the occupation, the salary structure, the EMI, maybe the number of dependents, marital status, gender, the location the person is staying in. There are a bunch of other information that is collected. The last payment, what was the amount of the payment, etc. And in delinquent in any particular month. So you get all of those, you clean the data, you explore the data using numerical information and also visually. And then you try to establish a relationship between those independent variables, between age and marital status, the salary structure, between the number of dependents and all of those, right? And in the data set, you have all the information for the customers who may have defaulted and the customers who are also your good customers, because you want to understand what is the difference between them, right? Why is this lot defaulting and this lot not defaulting? You want to understand the behavior of both the groups. So you explore the data well. And then in the diagnostic analytics, you may try to form a particular segment. And segmentation is again a concept which we will learn with the help of clustering. So we form a segment in the data set. Okay, if these are the group of people who are defaulting, do we see similarity? Or if these are the group of people who are not defaulting, is there just one group, or are there two different groups? But those two groups are different amongst itself. People in those two groups are unique, and that is why they are not defaulting. Maybe you get 3 other groups for defaulters. All of them are defaulting, but basis their demographic information, their payment structure, their salary structure, all of those, you may identify 3 different groups. One could be, the pensioner. One could be really young age group, etc. I'm not sure what the data will be, but this is at a high level. We can segment to understand the customer behavior. Then we can do a correlation where we understand, okay, if salary is low, is the person defaulting more? Or is a person defaulting more because he now is married? So his marital status says that he's married and he has, 2 children. That helps understand the bank that he may be having a lot of financial responsibilities. Things like that. We try to associate and understand what is the behavior in the diagnostic and analytics to know, okay, this is the reason that may have impacted the person to default or not to default. Then after we have understood the data in these 2 sections, we move forward and say, okay, the problem statement is that I don't want the people to default, right? Because that's a huge hit to the bank. So how can I build a model wherein I feed the customer information and the model will tell me, in future, will the person default or not? Right? That is what is happening with all the machine learning algorithms. You have a set of old data. With the old data, you explore it, you understand what's happening, and then you build the data on the old data itself, right? The past data itself. But the model could be run on the new data or the new applications that is received by the bank. So you get fresh applicants from 20 new customers. You don't know what is going to happen because no one has seen the future. But because we have made the model, the predictive model, you can run through those customer information and the model can predict, okay, customer number 1, basis the information that you have fed, he will not default, he will be a good customer. Customer number 2, he may default. The probability that he will default is 80%, so very high. Be very careful when you give the loan, or make adjustment in your interest rate, make it real stringent. Things, all of those form part of your predictive analytics where you try to predict. When you try to predict and build the model will tell you certain information, those rules that will help you to generate business insights and recommendations. You may see that, you know what, in your data set, pensioners, though they have taken the loan, they are not defaulting. 100% of the pensioners have not defaulted, and they form only 10% of the population of the overall customer. So which means that the bank should target more to the pensioners. If they are in need, they should definitely get it. Right? Things like that. So those all rules or insights, recommendations become part of your prescriptive analytics. This is where we have to reach. We are still in this stage, but I'll take you through all of this final stage that we will reach. So this is a total life cycle of, the project life cycle, I would say, of any use case that you work on. Any question from any of these life cycle stages? Here is the some of the information on exploratory data analysis. So we understand the spread of variables in the data set. We'll talk about this in statistics. Detect any outliers in the data set. Right, where I said that by mistake, so you are capturing age of the customers, and one of the customer had age of 37, and someone entered the information 37, incorrectly entered a 0 also. So the age becomes 370. Is that possible? That is not possible, right? So that is an outlier, and that is an incorrect information. How do you impute that? So detection, not only you detect, if you understand that the value that shows up is incorrect, and that is where your domain knowledge comes into picture, right? And then you also update or impute. Obtain clues on relationship between variables in a data set. Now here, let me give you a question. So I ask you to buy a product. Okay, the product is priced rupees 100, and I ask you to buy one product. And you say, okay, the total amount is 100. So I say, okay, Piyush, go and buy 5 products of the 5 quantities of the same product. So now you say, okay, the price is 500. I say, okay, buy 10 quantities of the same product. Do you see that there is a relationship between the quantity that you buy for product and the price that you have to pay? Yes. Would you say, yeah? So that is the relationship between variables. Now I took a very simple variable here, and everyone can associate with that because we do a lot of shopping. We understand that we buy more product, we spend more. But this kind of relationship can be understood between any variable in your data set, and that is what we are going to explore. We are not going to work on, from a statistical perspective, but I'll in this session, but I'll definitely tell you what is that correlation, what does it mean, because here the relationship is actually the correlation. What is the relationship between two variables? So we'll talk about that. And spot missing values in the data set that we did last week using isNull. So that is only spotting. So you knew that there are missing values, and we dropped using drop any command. That is not the end. Every time we don't just drop the missing values, because where sample is a constraint, if you drop missing values, then you're losing a lot of samples. To get the sample from the client may be expensive, so we rather impute. If imputation is a way, imputation should be done, so we impute so that we retain those observations. So we'll talk about imputation of missing values after or during our statistic class. Let's talk about industry example, how Netflix used exploratory data and analysis. So may I have a volunteer, please, who could read this for all of us? Anyone?
Can I read the
Yes.
one?
Yes, please.
Yeah, a great example of this is the immensely popular show House of Cards, and how Netflix used data to create the show. They started by collecting massive amounts of data from their users, such as the kinds of shows and movies they watched and what actors and directors were the most popular. After crunching the numbers, they were able to identify that director David Fincher was among the most popular, as was actor Kevin Spacey. Interestingly, they also found that the original British version of House of Cards was very well received by these same users. The numbers weighed very heavily in favor of combining these three elements, the show, Spacey, and Fincher, which prompted them to buy the rights for the show and create an American version, which released in early 2013. Did all this data work? The answer to that is a resounding yes. The show proved to be a massive hit, and Netflix gained around 2 million new subscribers in the first quarter of 2013 in the US alone. They also got a further 1 million new users from other markets, and this influx of new subscribers helped them reimburse the production cost of the show.
Thank you, Saugata, for reading it. I actually was speaking in mute. Sorry about that.
Okay.
So this is about Netflix, right? And how Netflix helped gain attention of the customers. They understood what is a pattern, where the customers like watching and what they watch. They combined all of those to gain more customers. Can you correlate this to any of the things that have happened? Maybe.
Yeah, Karuna Ari here. I work in the OTT space as well. So, data is just so crucial these days. So just for everyone, OTT is the over-the-top services, such as Netflix, Hotstar. And one of the things that's kind of really picking up from a data perspective is personalized engines, search engines. So for example, if you're going into Netflix, the movie title that you should see may be completely different to the movie thumbnail that somebody else sees. That's how much data is kind of coming. It's fascinating. Everything in the OTT space these days is very, very data driven, and thanks to Netflix, they set the bar very high.
Absolutely. The data is I think data speaks a lot. If used in the right way, it can shape a lot of things positively. When I was reading this, I could correlate to, how during this lockdown, the government said maybe in Indian channels, I know we have some of you who are not in India. Who all are not in India right now? If, could you please unmute and talk?
Not in,
Pavan, right?
that's
Which location are you in?
Myanmar.
Myanmar. Okay. Anyone else?
Yeah, Guru here, but I am locked down. I am in India, so I actually work in Thailand, but
okay, and you are locked down here.
I'm locked down here, yes.
Okay. Anyone else? Perfect. So, but all of you know, I understand Indian structure, right? So, in the lockdown, they introduced the television old, I think old sessions that they had for Ramayana, Mahabharata. Then there are a lot of old episodes that they exactly why, because they knew that they're gonna. So they did not introduce all of those on single day. They introduced it gradually because they saw the difference. I'm sure someone was doing some math around that because I could feel that in my home. My parents were hooked to the television, and so where they say that you should be very careful. The elders may not go out of the home because it's very risky. They thought of a plan, right? And the data must have told them that this is the right way. Some logic along with data. So that did work very well. And after those all ended, now again the situation is back to track where I see all of them, senior citizens, walking out of the house in the evening, in the morning. Earlier they were pretty inside, hooked to television. So something I just correlated while Swagata, you were reading this. I'm sure a lot of information is fetched behind the scene. This is another one, very interesting. It's how visual analysis helped cure cholera. In 1854, there was a major outbreak of cholera in London. Many then prevailing theories failed to associate the transmission of cholera to hygiene, assuming that cholera was non-contagious or that the disease agent was airborne. A doctor named John Snow discovered the cause of the outbreak by making a map indicating where the victims lived. So the map showed a cluster in Soho, and Snow identified a water pump in Broad Street as the epicenter of outbreak. Excavations showed that a nearby cesspit leaked fecal bacteria into the pump well. Snow convinced officials to remove the handle from the pump, thus ending the outbreak. So this is pretty interesting how a person understood, okay, these are the people who had cholera, where are they living? So they did some cluster analysis and understood that this is the region where the outbreak of cholera is, and identified and then ruled out. So the person must have collected data and plotted it, right? Another very interesting example. In some point in time where we'll go through the industry examples, you will also get a detailed link to view all of these industry examples. So the kind of work with the help of statistics, with the help of numbers, you would be able to explore. I don't see it here, but yeah, I think from the basic stats or advanced stats, you will see the link, reference link. This is our case study that we'll be working on today, and it says honey production. So in 2006, global concern was raised over a rapid decline in the honeybee population, an integral component to American honey agriculture. Large number of hives were lost to colony collapse disorder, a phenomenon of disappearing worker bees causing the remaining hive colony to collapse. 12 years later, some industries are observing recovery, but the American honey industry is still largely struggling. Now, honey mostly comes from overseas, with 350 of the 400 million pounds of honey consumed every year originating from imports. So the data set that we are going to see now provides insight into honey production supply and demand in America by state from 1998 to 2012. I believe all of you should have this data, right?
We have.
Yes.
Yes. Yeah. Thank you.
Okay, so could you please read the data and maybe in Python only. So could you please read the data and also read import pandas, NumPy, Seaborn packages. So I'll do this first one for you. Why do we write ASPD? Why not just say import pandas? Anyone ask this question to yourself?
Yeah, I think
Sort
this
of
is
assigning.
It's an alias, right? Yeah, a name that you give, because every time if you write pandas dot, that's a long name. Instead of that name, you can just write PD dot. And where the name is short, we don't use anything. So Seaborn, right? Instead of Seaborn, you can write anything. You can write S also, but the usual practice is to use S and S. So I've imported pandas, NumPy, SNS. I'm just going to import. What should I import? Because I have to plot now.
Matplotlib.
Matplotlib.
Yes,
Matplotlib.
absolutely. So from Matplotlib, I will just
PyPlot.
import PyPlot. Yeah, and I'll name as PLT. Okay. And because I also want to show any of the information right after my plot, it's a good idea to just attach it with Matplotlib inline. So Matplotlib inline will just help you in case you want to plot something and you have the details also to show up down below. It will help. At times, even if you don't use it, nothing will happen, but it's a good practice that you just use it with Matplotlib. So I'll use it, and I'll also read this file. I'll say,
Aruna Piyush.
yes, Piyush, tell me.
In the videos of the tutor has downloaded one more command, sns.set color underscore codes equal to true.
Hmm.
So what was that command? But when we are running this command, the error comes out as true is not defined.
What is the command? Set
SNS,
color.
Yeah, sns.set function is color underscore codes equal to true.
So you have to work that in any of the plotting. If you work it on a plot, then the color will show up. If not, then it will not. The color, I think,
when
will
I was
default.
importing, the error was coming. The true is not defined.
Okay, I'll check that then.
Sure.
Karuna, I have a question.
Hmm?
So when I was trying to read the file, I was getting an error, but then I just searched online and I used this header equals to 0 and encoding is equal to Unicode escape, and I was able to read the file. What exactly is this? This what does it do? Do you have an idea like what's happening with this?
Nidhi, right?
Yeah.
Why it should work out?
Yeah,
pd.read CSV, and within double quotes, if you write honeyproduction.csv, it should work.
Actually, it was not working for one of the other data sets which we have. I think FIFA, I guess. So I just used this, and but I didn't quite understand that what happened with this. Why I was able to import with this, and what is this encoding thing?
Okay, let me check the data set. It should work on all. So when you say header is equal to true, it means that the names of the columns are in the first row, and if you don't, then you'll have to specify non be something. We don't use it quite often. It says that the columns in every column, the first row is of the file is the header. So that without even using header is equal to true, you should be able to import. You're saying FIFA, right?
Yeah, there was actually FIFA or Auto. Maybe I think I was trying out with. I think with Auto maybe.
Automobile.
Yeah, we have one more data set, right? So that I was not able to import, and then I think used it, and I was able to do it. I was able to import the data set. So that's why this question why.
Okay, I'll check. I was able to work on automobile yesterday with Piyush, and it did work. Automobile worked. FIFA, I did not check. I'll check it for you. Anyone also faced any problem with FIFA and automobile? Okay.
It has to be with double inverted or single inverted. I believe both will work.
Both should work, yeah. But I use double.
But in this case, it is not working. Honey production.
Honey production, you have used double?
Single.
Can use double? Is it working?
No, I have used double also. But
it is not working for you?
No.
Probably import OS is missing.
Check the name of the file, whether it is downloaded as Honey Production or Honey Production 1.
What is the error?
Error, it is showing.
Why don't you show your screen so that we all can see? Yeah.
Yes,
Let me stop sharing. Oh my God! See your file name. Go to your file wherever you have saved this file.
This is in download.
Okay.
Yeah, this is the one.
Which one?
This one.
Rename this file. It is not going to work like this. You have a bunch of
basically there is a space in Honey Production and this bracket one. So this was not there in the command, so that's the reason why it's not actually taking the file.
Okay, there's space here, no, right? Okay. This should be working now.
Yeah, but you should you should not.
Come.
Yeah, but this is not a good way of doing it. So why this happens? You are downloading the file again and again.
Yeah.
So this is not a good way to do. Maybe once you download, rename the file to a better name.
Okay.
Right.
Okay. Got your point. Thank you, ma'am.
Okay, you're welcome.
Thanks, everybody.
The other trick over there is just when you're doing this particular thing, it's best to copy and paste it from the desk, from the Jupyter notebook.
Yes, you can also rename and then paste the name. Rename, copy, and then paste it here. Okay, so perfect. Can we read first few data set, explore the data set, and so these three things, right? Why don't you check the first 10 records, last 10 records, and also dimension or shape of the data set. Also give me the summary statistics. We have done this. So first 10 records, last 10 records, shape of the data set, shape, size, however you want to write, and summary statistics. These these commands. And also check the data type for all the columns. So I'll give it, but it's 5:43. I'll give you about maybe 4 or 5 minutes.
Shape.
Yes, shape is a command.
Shape, so last 10 records and shape of.
Okay, so last 10 records is one thing, then shape of the data set is another thing. Shape, and also for info it will be mydata.info, right? And then
Describe.
yeah. Okay, so these are basics. I just wanted to recall from where we worked last time. Now there is a describe function, right? I want you to use this. You type in describe and also do this .t.
Transpose.
Yes, transpose. This is a neater way to get your data. When you have a lot of columns, right, it will just be pretty okay to use transpose. And you can just keep scrolling. So this T is for transpose. Here we were able to use mydata.info. So what do you think this is telling you? What kind of data type you have for all of these variables? So columns are variables, right? Or attributes. So what are these type of data?
Yeah, we have majority of the numbers available as part of the
Excellent.
CSV file, and we have only one string, right? Or the categorical sort of data.
Categorical.
That is
Perfect.
the state.
Perfect. So we have year as object, state as object, and remaining all other are float or integer. What about this year? Do you think it should be really integer or it should be an object? So in the year column, you see all of the different years. It should be categorical, right? Where you see 10 records for 1 year, then you have 20 records for another year. Ideally, year should be a categorical kind of column. You may have only 5 or 6 years in your data set.
Yeah.
Yeah, but it is referred to as integer. Well, we are not going to work on this right now. There is a way to change it. I'm going to show you later. But just to to help you keep on thinking that these are some of the things that we do take a note of when we explore the data. There are different ways how to solve it, which we will learn gradually. But right now, identify what are the patterns, what could be imputed, what could not be imputed, does it make sense, etc.
I think, Karuna, the other thing with this data set was if you go to the first question that was there, it asked us to check non-null values. When we checked it, there was none as well. So that was an interesting observation in this data set.
It was, yeah. Yep. Did you observe the null values? How many null values did you observe?
0.
Yeah. There is no null values in this data. This is a cleaner data set. But in case we have the null value, if you see that is null.sum is giving you some of the missing values, then we either drop before we do all the visualization, or we impute and then do the visualization. There's a neater data set, so we don't need to drop or impute.
So, sorry, one more quick question. When it comes to looking at values, is it as simple as just looking at the min and the max in the describe table?
No, not really. Not really. It will not show you. It will, if for a categorical variable, your describe will, tell you that there are non-numeric information. It will give you the count, and it will also give you for which variable you have the maximum information. Let me see. Can I do include is equal to all? Let me see if it works. No. There is a way you can check for the data type not understood. Okay, there is a way where you in the describe you run everything and it should give you the details. But there is no way you can check missing values using the min and max.
No, sorry, not the missing values. There were two questions, right? So one is to highlight the null, and the other one was to look at the extreme values.
Yeah, extreme values are min. Correct. Yeah, this is how you would say you would use it.
No, but this information, Karuna, so the one on the top, right, input 0, it actually comes up with the command mydata.head, right? So by default, you're saying that mydata.head would give you those extreme values of the 5.
No.
Head would give you top 5 entries in your CSV file.
That was my point. So the extreme values. So how do you then
Yes, that is the describe. Extreme value you will only get in describe. Yeah.
Describe. Okay.
Yeah. Describe is giving you the 5-point summary.
Okay. Got it.
Okay.
Yeah. So that's where you'll see the min and the max.
Nice. Okay. Got it.
Yes. Why is describe not giving me the information? Just give me one more try, okay?
Sure.
No. I'll share with you then later. I'll look at it because it is for a categorical variable. It is going to give you that information where you will be able to see that there are non-numeric values, and it is going to give you the count and all. So I'll work on this and then give you the information a little later.
Thank you.
Perfect. You're welcome. Okay. So now, can you try this? How many states are included in the data set? What? How would you check this?
Yeah, I got it. Can I say it or type it?
You can say, you can type anything.
Just put it there. Just typed it. It's my data dot state dot nunique function.
Nunique, absolutely. Nunique is the command that you will have to type to get the number of unique variables. So you type in your data set, right? The data set is my data. You refer to the column because it says how many states are included in the data set, and state is a factor type or categorical variables. When we say categorical, we understand that there are same states repeated for many observations. So you'll have to make a note of that column name and nunique. Now, when I want to see what are the states, what are the common states, what would you do? It is just going to give you a count, right? Yes. So nunique has given us the count. When I want to understand what are the unique columns, someone answered. Okay.
I try to use iLook.
You try to use iLocation. All right. There is a pretty easy way. Let me show you how. You just use unique. So you say my data state dot unique. It is going to give you all the information, all the unique states, names of all the unique states. Now, if I ask you, do not look at this, okay? Sorry. If I say calculate the average production for each state across all the years, we have to understand what is the production for all the states and determine the average production. And for all the years, right? Year is not a constraint here. It has to be for everything or the overall data set. Just look at state and your total production column. So Rajkumar is, and Rajkumar, right? That's the complete
Yeah.
name. So Rajkumar seems to have done all the homework because he is answering all the questions now. Thank you.
So thank you, but I'm just up to it.
Yes, yes. I'm happy about it. Okay. So you make a note of the two columns that you want, state and your total production, right? But you have to understand the name of all these columns should be exactly how it is in your data set, otherwise you'll get an error. At times the errors that you get are not something really big mistake you have done. The errors are pretty small. It can easily be fixed with little more attention to your code. So if you get an error, don't be, oh my God, the error is here. But if you just check the code, you may observe that maybe the name is not written properly, there is a dot that's missing, etc. So just wanted to share that. So group by is a command. We all use group by in Excel also. So group by, and we want to understand the average production of each state. So I'll group it by the state. But I do want the average, right? So mean is again arithmetic function. Mean means average. You can just use this, and it is going to give you a bunch of additional numbers with e to the power plus 0.5. It's a big number. So the better thing here, if you get all of these, you just round it, right? Someone asked the question about how do you see the decimal up to 2 decimal places in the last session, and you also were able to use the round command. We'll use the round here, and I'm saying that round it to 2 decimal maybe. So it is giving me for each state what is the average production. So this is the complete command. I have one more question for you. We all did this question. So I want you to work on this. Here's another way how you can get the same information, right? You change it in a data frame and then do the same thing. It is just the same information, but in a different way. So you may want to look at it whenever you get this file. Nothing new. We are just using the same kind of command. Let's look at this, and I want all of you to try it out. How many years data is provided in the data set, and what is the starting and ending year? So let's break it. Maybe the first part will only answer how many years data is provided in the data set. Are we talking about 4 years, 5 years, 15 years, 16 years? How many? And let me ask this question, right? Not to pinpoint, right? I don't want to put you on a spot right now if I just ask this question, but I want to understand if it is making sense to any one of you. So maybe
it's n unique.
Yeah. Yes,
Sorry.
it is n unique. You already answered.
Yeah. Sorry, yeah. I didn't know that we were going to.
No, not at all. You're good. So thank you for answering, Guru. It is n unique. So you'll just point your column and you'll say n unique. Do you see that some of the commands you already remember by now, and it has been 2 sessions? There will be a session very soon, maybe in the statistics class, where you will say, okay, just walk me through the code. Do not type the code. You'll be in that zone. Okay, now let's do this. What is the starting and the ending year?
I think here is where the year not being a string actually helps. Yeah. I don't want to tell the answer. I'll leave it to others.
No, you can say. Anyone can say. I'm not going to take name. Please.
Min and max.
Exactly. Yeah. Exactly. So my data, year, and you just, because when we attach a method, a function, we attach it with dot, right? So dot min, dot max. You can just use this and use max. Okay.
I just want to clarify a doubt. Rajkumar has put print P. Would we really require the print P?
So print P is printing the information that is stored in here. and what he is storing here is my data year dot min. So he's actually storing the minimum year and printing it here. You can just write P or print P. Does it make sense, Guru?
Without that also we are able to
Yeah.
display the display it. So that command print P may not be required itself, right?
Not required. You can
Right.
just type in P.
All right.
Any reason why this command would not work? My data year apply map. I think this, anyone has any information on this?
Ma'am, the reason why I'm asking that question, I think as a part of going through the functions and the lambda function, the extension of lambda function was to apply. There are other forms of lambda function, I believe, part of the course which talks about passing the data frame rows to a function. The function can be an NumPy function or a regular Python function. But just naming the function within the parenthesis will apply that function to all of the values for that series or array or whatever against which the function is executed. So
you, yeah, go ahead.
Yeah, that's why I'm. So basically, the question is, the my data year will return all the years, and I believe the return type would be series, right? Series data type. And pass that through the apply map, and what that means is, give the aggregate return of the values in the form of max. So this is where I was like, how to what kind of data type of a particular access path returns seems to have an impact on how you use the subsequent function. So I had this question. Yeah.
Yes, I'll take this question a little later because it will require explanation, but I think I'll share some audio in the group. But apply map function, when you want to apply a function to data frame all of the columns, or maybe each of the element of the data frame, that is where we use apply map function. So it can be it is used to return a single value from single element, so year, and it can return the maximum of the year. It can be applied to the entire data frame using one column at a time, or it could be applied to entire data frame to all the columns in the sequence.
Yeah. In this case, I'm getting an error message. So
okay, right now I keep these questions posted.
Sure.
Swami, we'll work it on.
Sure. Yeah.
I have one question from Nidhi. So Nidhi, though we know that there is another way to work out some of the questions, right? Some of the coding questions, I'll take it up later. So I have your questions. There is a question from Piyush also, right? Piyush, your question is not typed. The one that you asked me, if you could please type it, I'm going to make a note so that in addition to what we are doing, if you write any other code that should return the same kind of information and you're not able to see that, I'll take it up after the session so that we do not lose the time here, but you will still get the answers. There are different ways to write the same query, so you'll get the answers for your way of writing the query as well. So type it in the chat window. I'm making a note so that I can answer later. And Nidhi, you wrote this one, right? Unicode scape header true. We don't write it. It's very tedious, but I'll still share. Okay, so let's go ahead and which state has seen the highest volume in production and in which year? So here we are adding another component, state and total production. And we want to understand which year was that in. Are you able to get the answer?
Yeah.
Okay.
My data and dot sort values.
Okay, sort values. Yeah. That is another way. Yes. Sorting also will give you the same kind of information.
Yeah.
So I'm using the total production only. So I'm storing the total production wherever we see the maximum total production, and I will also print the state and the year, right? So let's see how we do that. So I've said from my data, pick this total production column. Okay, and I want to print it. So I'll say wherever from my data, the total production is maximum, right? That is what we have to do. So I'll just say wherever the total production is maximum. And after this, what I want two things. I want my state and the year too. So I'll say just print both state and comma year. So it is going to give you the same information. So first of all, I have saved in total production, I've saved this is equal to the maximum of total production. For that maximum, you print the state and the year as well. This is another way of writing. The same codes could be written in multiple ways. So if you want to explore your way, because I give you some time to answer question, if you want to explore your way, please do so. This is another one that Ari has mentioned, and it's working fine. So I location, I'm trying this code. Okay. Perfect.
Yeah. Anna, this is Guru here. I just typed in the chat, right? So can we use that?
Check it for yourself. Check it for yourself.
But the answer is not like what we are saying. I'm getting a different state. That's the reason I'm asking.
So you what you're saying? Honey production, state, year, total production dot max. What are you seeing? Looking as what do you get the answer?
And I'm getting as state is WI, year is 2012, and total production is 46. It's an exponential number.
Yeah, it is. I don't know if it is able to tie max function to any.
Okay.
Right? It is taking all the three components. So it must be doing some crazy stuff because you have to tie max command to a particular column, right? And here we need to understand what is the highest volume of in production. So total production should be tied to max, and then you print all of those. Okay, then the next one is what is the average yield per colony for each year? Average yield. This is pretty simple. I think we just did this kind of question, right? Where we said by state, what is the average total production? Did we do that?
Yeah, just one question, ma'am. So in the previous one, number 18, and then finally you had put two open braces. The list of list is a representation of list of list, but just only one list. Any reason why you had to put that way? The state, comma, year. It is a list of list with just one list.
Not really. There is no particular reason. I think it is going to. I have a habit of if I take 2-3 columns, I do use double brackets. It is not working.
It's not mandatory. Okay, sure.
It is not working. It is not going to work. Yeah. It is going to give an error.
Yeah, it's giving an error. So I was just thinking so what is the sensitivity in the command about it is what I was trying to understand.
I think whenever you're referring to multiple information, see, this is a criteria, right? Where you're saying max is this. Then you're also inputting the other criteria, which is on an aggregated function. There, you need to use this. It seems that an aggregated function is performed on one column, and then you're matching it with other.
Okay.
But like Ari used, or I think Ari you used, right? Where you said total production, state, year, and then at the end of max. So it will calculate funny thing. It doesn't know where to calculate the max, right? And that is why we first impute on a particular column, This is a kind of aggregate function. And then when you have to combine with other columns, we do need two quotes within the list.
Okay.
What is the average yield per colony for each year?
Yeah, just on the previous question, Karuna, just explaining the thought process of what I put in, right? I think as I was working through this, when you actually sort the values, and especially when you're analyzing, you want to be sure that whatever you're seeing is the right value, right? And then kind of trim it down. So when you put that sort values, it kind of then showed you clearly, okay, look, I'm looking at the right answer.
Exactly.
And then you kind of, brief it down to say, okay, this is the specified outcome that you want displayed.
Yes, you can do that. I've seen many people trying sort first and then doing showing the result. That is also a good way to do. I agree. So here I'm using average yield per colony for each year. So I'm using year and year col. Now again, I have to use aggregate function. See, anything, max, min, group by, anywhere we have aggregate functions, I'm using a double bracket, and then I'll match it up to group by. I need the max average yield per year, right? So the group by will have year aspect. And because I need average, I want to calculate a mean. So it is going to give me this kind of bunch of number. It doesn't make any sense. I would like to round it. So 2 or maybe 0. Just don't round it. So it is going to give you a round off number. So this is the average yield per colony for each of these years. This kind of question, so the kind of questions that we are going through is also important, because when in a data set you would like to explore it in a way, right? The average value, the maximum value, the highest value, the lowest value, you do want to explore by different combinations, and hence these questions are there in the practice. I'm not sure what question you will get in your project, but whenever we work with data, try to pick up these columns and try to work on these. These are some things that we'll be working on to provide some insights. Okay, are we all good up until this step? I got some questions. I've taken a note of those, so I'll not invest time in explaining those or going into detail fixing those for you right now, because we'll run over time. But I'll definitely get back to you. So Nidhi and Swami, I have your questions, right? And Piyush, type in your question, because I did not get your question, but I know that you asked one question, right? I completely forgot. It is not there in the chat. So write down your question in chat, or IM, and I can help you with that. Any question? Yeah.
I do have a question. I use the same formula with the sort values. I will post it out in the chat. The part which I struggled was finding the mean and the round value, because it was throwing some errors. So again, we can take it afterwards, but yeah, I was just trying to figure it out using the sort values, but unfortunately couldn't get it.
Okay, but sorting is not going to give you the average, right? Sorting is going to give you the high or the low. We know that. Okay,
yeah,
cool.
That's right. Yeah.
Cool. So what is the reason behind sorting it?
No, I wanted to sort it out and then get the value and then round it up, but this seems to be a much easier option. I was just trying to use the sort values and then round it up.
Okay, cool. Perfect. And do we have any more question? Set color error is true, not defined. Yeah. Okay, thank you, Piyush. This is from Ari, right? And this is from Piyush. Perfect. So now we will, any other question on any of the codes? Nidhi, are you good? Because I'm not hearing your voice. Are you able to follow along? Yeah. Okay. So let us work on this visualization now. And it's pretty interesting. It says that, is there any correlation between any two numeric variables. Test the same using visual techniques. I'll take a minute to show you some correlation. So all of us buy pizza, right? So we buy pizza every Saturday and Sunday, and they offer us a huge discount. So one Saturday they said that, okay, any one of you will purchase it, we'll give you 50% discount. What do you think is going to happen? So they started with 10% at 10 a.m. in the morning. So this is the discount, right? 10 a.m. They started with 10%. Then midday, they increased it to maybe 20%. Towards evening, they increased it to 30%. Toward night, they increased it to 50%. What do you think the sale will be? When it is 10%, do you think that some people will buy it? Is morning time, may not be very interested. When the discount increases by afternoon and evening, you will see maybe an increase in the number of people who are buying it. So more people are buying now. And in the night, maybe you see that there's a 50% discount. Why cook dinner? Let us all have pizza. So there are many people now buying it. So we see majority of them buying now. What is this kind of correlation? If I want to draw a straight line that passes through all these points, so at a smaller discount, I see smaller number of people buying. Discount increased, I observed that I have more customers now. I further increase the discount, I see that more number of people are buying. Further increase the discount, I see majority of them are buying. So if I want to draw a straight line that passes through all of these points, I see an upward trending line. What can you talk about this? What insight is it, giving you?
As the discount increases, the quantity of the sale increases.
Absolutely, right? This is the relationship between the quantity of the item sold versus discount. And if you see a straight line going up, which means both the variables are increasing, right? If one increases, the other also increases. Then we say that it is positive correlation. Correlation is positive. On the other side, suppose you have another observation where you see that, as the price of the product is increasing, less number of people are buying. Price decreases, I have more number of people buying. So price increases, I have lesser people buying, right? Price decreases, I have more people buying. Just the other way. I'm showing it here just the other way. And I want to draw a straight line passing through all of these points. I see a decline in trend, which means that higher the price, right? Higher the price, lesser are the people who are buying. Lesser number of customer count. For the same product, same brand, when there is a very high price, maybe less number of people are buying. But when you reduce the price, there are more number of people buying. So if the price increases, the number of people who buy the product decreases. So when you have this kind of information, you see a downward sloping line, and this is also correlation, right? It shows that there is definitely a relation, just that the relation says that if one variable increases, the other decreases. So it is a negative correlation. Or
directly correlated and inversely correlated.
Yeah, directly correlated, inversely correlated, positive correlation, negative correlation. The range, right? If you want to measure what is the numeric value of correlation, the range varies between +1 to -1. Always, you will see that the range of correlation always is between +1 to -1. This is the range, and of course we have a zero value somewhere. Now, can you give me an example where you can get no correlation? Where you see that there is no correlation.
Temperature increasing and number of COVID cases not decreasing. Somebody said it's going to reduce, but it is not reduced.
I like it. Yes, that could be. Yeah, I have not done the calculation, but as we are looking at the temperature decreases or increases, whatever is there, if the COVID number is here, it was just going to not change. So there is maybe a very little correlation because there is a fluctuation in the COVID numbers. It depends on how many, what is the population, if the people are going out and, socializing more, so you see number increases. But only looking at the temperature and impact on the COVID, you would see a flat line. Maybe the COVID number doesn't increase or decrease with whatever change is there in the temperature. So there's a no correlation. If you see a flat line, it means the correlation score is 0 and there is no correlation. So this is the idea of establishing a relationship between two variables. We're going to talk about it in the stats class, but because we have to understand, we have to visualize, I also wanted you to understand and then give insights. So I'm just going to take few variables. The question is there a correlation between any two numeric variables, and test for the same using visual techniques. I'm going to take some numeric variables, and I'm going to plot a pair plot, right? SNS dot pair plot. It is very common. You will be using it quite often. So SNS pair plot, I'll just use from my data, I'm going to use few columns only. So numcol. I'm going to use yield per call, then total production. We do have stocks, so I'm going to use stocks as well. And I think there is a price. Let me see. It is already plotted. So price per LB and prod value. Okay, sorry. And then prod value. So I'm just going to plot a pair plot using numcol, yield per call, total production, stocks, price per LB, and product value. It takes a little bit of time to come up. It's a little heavier. But let's see what it tells you. And I'll put this in front of you, and I'll also show you how you read. So if you have to read, the diagonal is just the histogram. It is just telling you what is the structure of the data, right? What is the shape? So we will not concentrate on the diagonal now. You just concentrate on off diagonal, and you can pick any of the triangle. It is just a replica. Replica, the lower triangle is a replica of the upper triangle. So you can pick any, and the way you read it is, for example, if you want to read for this one, right, this graph, the x-axis talks about the number of colonies and the y-axis talks about the product value. So this graph shows you the relationship between product value and number of colonies. If you want to talk about this graph, for example, then look at the x-axis by checking the extreme end, and you will see yield per call. So this x-axis talks about the yield per colony, and the y-axis talks about the price per LB, right? It's a common y and x-axis for any of this graph. So try running this and pick any two to share some views about correlation.
Karuna, on this graphs, is it? I mean, I'm just struggling to read it. Probably just me. Is it possible to put the y-axis or x-axis on some of these things, or is it a common?
I didn't understand your question.
Sorry, I was just saying in the graph, you're seeing a lot of data.
Mm-hmm.
You're seeing the y-axis, but not the x-axis. The x-axis
is also there. It is here.
Oh, okay, right at the bottom. Okay.
Yeah, it is at the bottom. And I've tried to, I've made it simpler for you. So if you, in the same one, if you type corner is equal to true, you will be able to see one side, because both the graphs, both the triangles are replica. So why not just use one triangle, because it makes a lot better sense to provide insight. So now look at any of the columns and share your opinion. Pick any two variables. And you can do it on your screen. I'll just have the code up so that you can talk using your screen as well.
Can we please copy paste that command into the chat window, please?
Sure. I shall send it to everyone so that you all will get it. True is none. Guru just answered your question, Piyush. By the way, you can check it. And that is true. See, the corner is equal to true. Even T has to be caps.
I tried with caps also. There was
Yeah,
same.
it didn't work. Okay. So anyone who is able to run this command and would like to talk about it, tell me which two variables are you referring to and what is your insight? Do you see any correlation? A strong correlation, not a strong correlation. So the higher the value, right? Whether it is negative or positive, if it is towards 1, which means 90, 80%, 90%, 85%, 95%, these are strong correlation. But if you see the values near 0, which means 20%, 30%, 40%, it means that very weak correlation.
See, Sogota here. Can I start?
Yes, please.
Yeah. I am looking at one which is at the bottom, that is stock versus product value.
Okay, okay.
Now, the relation between them doesn't seems to be doing any justifiable remarks.
Okay.
Because wherever I see more stocks, the product value is lower, and with lesser stocks, the product value is going up. There are a few outliers in that, where higher the stock, higher is the product value.
Correct. So a very good interpretation, Subodh. So Subodh, right?
Sogata.
Swagata, okay. Very good observation. So here majority of the stock is concentrated between 0 to 5, right?
Yeah.
0.0 to 0.5. Now, for the majority of the stocks, the product value is very low, but there are some number of stocks that are towards the higher end, and you see the product value also increases. So there may be a situation that these are outliers. Maybe. But overall, if we only talk about correlation, then I can draw a straight line showing an upward trend. So we can say that it's not a very high correlation, not a 90%, but maybe, it's not even 50%. It could be 60, 70%, 70% maybe. So there is a correlation. It is positive, of course, because as the product value increases, the stock also increases. Barring this, outlier, we see that there is a correlation towards positive side. Not a very huge correlation, though.
True.
Yeah, the clear correlation between production value and number of colonies, which is quite obvious.
This one, yes, absolutely. Number of colony and production value. Highly correlated, right?
So
What about this?
Can we
That is
say
also
like
positive related.
yield per column is highly correlated to price per LB? Because the most of the chunk which is there in yield per column is the value in between, and same is in the case of price per LB at the same level.
So, may I get your name, please?
Rahul.
Rahul. So Rahul, when we see correlation, we'll have to look only at one chart, right? We cannot look two charts. Yeah, that is why. So try reading it this way. If you want to talk about yield per colony and price per LB, then only concentrate on this chart because it has the x-axis which talks to yield per call and the y-axis represents price per LB. So only look at this chart.
I think there is a clear correlation between total production and also the product value. It is scattered and it kind of dies down at the bottom, but there seems to be a correlation.
Which one? The product value, you said?
The total production and the product value.
Yeah, definitely. Very high correlation, right? Overall, of course, there are some points here and there, and the points will not be in just one line. The idea of correlation is, can we draw a straight line going upward or downward? Here, it's a good observation there. Now, in yield per call and price per LB, Rahul, I see that not a very huge correlation. I cannot draw a straight upward or straight downward. Maybe downward I can draw. I can draw a little downward, right? But not a very straight upward. Definitely not.
Yield per call and number call is a downward trend if you see that there.
Yield per call and?
Number call. Number call.
That should be yield per call and num call. Let me check where the num call is.
Bottom second. Yeah, the first from the top of the first scattered graph.
So it is the yield per call and the num call. Yeah, this one, right?
So that's a negative trend. So if you see it is.
I see that I can draw a straight line here. Can you see? Can you draw a negative line? So let's do one thing, right? I can understand that you all are able to pick up the logic behind the correlation, whether it is high, low, but we are not able to be, we are not able to surely conclude what is the correlation, is where the correlation is very weak. We are not able to determine whether it is negative, positive, and what the number is. So why not look at the correlation score, right? If I give you that this is 35%, then you see, okay, this is positive 35%. Or if I tell you maybe this is negative 20, then you say, okay, very weak correlation, but it is negative correlation. The line must be going down. So is it a good idea to look at the numbers instead of these visualizations then?
Yep.
Yeah, let's do that. There is a way to do that. So let us actually type this code. I'm going to create a correlation matrix, right? Where you can actually see the correlation scores. And you can pick the same thing, the same information up until here. Where's your my data? Okay. So I'll say my data, pick these columns, and you have a function like you have min, max, mean. You also have a function that says CORR for correlation. This is the function. So let me run this. It has run this code, but I don't see the results. Can anyone say why?
That's because you have assigned it to a variable.
And you have not printed the variable.
We are not printing the variable. Absolutely. So we'll have to print the variable. Now tell me, we were talking about some of the observations here. Which one we were talking about? Yield per call and num call, right? So can we look at here real quick? Yield per call and num call, we thought that it is negatively correlated, but because it was very weak, it is very weak. It is only 24%. So we were not very sure whether we can draw a right or a downward trend line or an upward trend line. So the scores can tell us whether it's positive, negative. So the direction score can also tell you the direction, right? Exact direction and exact score. From here, we can also observe that total production and num call very, very highly correlated, positively correlated. We have some other, I believe, look at this one, 90, total production and product value, as you all said, extremely highly positively correlation. Total production and stocks, 87%. Someone was referring to stock with something else, right? Product value. See, it is 72%. Stocks with product value, somewhat it was correlated. We were not sure if it is highly. It did not look that it was extremely highly correlated, but it was correlated. So we were debating whether it is 60% or 70% or 65%. The actual score is 72%.
How do you convert this into a percentage?
We don't usually convert it into percentage because the range is only +1 to -1.
-1, okay.
Yeah. But yes, if you do want to convert any number into percentage in the for any variable, then in the bracket after a function you can say normalize is equal to true. That is another way, normalize. I'll take you through that. Yeah. Now, if I see a bunch of columns and you have all of these, and it is a long list of columns. You're working with a very, very big data set. You have 100 of columns. Assume that you have 100 of columns. And you see a bunch of numbers. Would you be able to look at each number and identify if it is highly correlated or not? That isn't a good way to visualize, right? Your audience will be completely lost in 100 different columns by looking at these vast matrix. Right now, we only have how many? 6, 7 columns. And there are a bunch of numbers. It's a little difficult for me to read. Imagine you have 100 of columns. Will you be able to read properly? Or you need a better visualization tool?
Better visualization.
I think the one below is trying to do that.
Heat map.
Yes, yes. But we will make a better one, right? I don't like this yellow color, but I'll make a better one. Okay. Sorry about the background noise, team. The kids are very excited to look at the rainbow. It just rained and the rainbow is out too. Okay, so let's work on this. I'll first set a figure size for my figure. There's a figure that I'm going to draw, and I'll use figure size many times when you want to create a better picture, the size of the picture, etc. So plt.figure helps you to set that, and within that I'll just say fixed size is equal to, maybe give the width and the height. I'm just going to use 8 by 8. I'm also going to do some formatting, right? You see these numbers are pretty small. I don't want the numbers to appear very, very small. I want it to be very legible. So I'm going to use SNS again to set the font. So I'll say SNS set, and let's use font underscore scale, and I'm just going to use maybe 1, 1.2, 1.5. So let's use 1.2. You can try using 1, 1.3, 1.5 for yourself. Now the name of this chart is a heat map, right? We call this as heat map. So I'm just going to use SNS heat map. And what I want to use this heat map for this information, right? This data, which is stored in core. So I'm going to say use heat map with the help of whatever I have calculated in correlation. I also want these numbers to show up. So there is a particular function, not a function, a command, which says ANNOT, ANNOT. ANNOT, which stands for annotation, is equal to true, which means that I do want these numbers to show up here. And I'm also trying to say that because the range is between +1 to -1, correlation range is between +1 to -1. So I'm going to use the axis for the minimum and maximum scale. So for that we have two attributes that says vmin, and I'll just assign a -1, and I'll also attach a vmax. These are two attributes to define the min and max scale for the legend axis. So I'll say +1. And now I'll say, okay, now show me this plot. So plt dot show. Let's see what it does. Now let's try to read this. So again, what did I do? Let me share. So first, I set the figure size. If I don't set it, it may come very small. So let us actually see how will it come. I'm just going to comment it out so that you also get to view the other side, right? If you don't use it, it's going to come very, very small for you. So it's a good idea to set the figure size. Now suppose I don't want to set the font scale. What will happen, right? I'll just comment it and show you. It is still taking this font, maybe by default because I had set the font scale already. But if you don't set the font scale, it will be very tiny as it was showing up in the previous view. It will be very tiny. So we set the font scale. Now it has adjusted after I gave the command. And what happens if you don't give this vmin and vmax, right? So I'm just going to get rid of it. and I'll paste it again, right? What happens? Basis the correlation score, it has automatically taken the min and max to what it thinks is the right one to take. So though we know that the correlation would range from +1 to -1, it will not go beyond -2, -3. Why? Because there are no values that needs to be shown after -4. This maybe is a -3 range, so you still is able to see this information, but we don't have -4, -5, -6 anywhere. So the tool thinks that there's a right axis. But if you do want to show to your customer that this is the range and here is where you fit, then you can define all of this information. So all of these are not mandatory, right? You may use it the way you want to use. Even if you don't use it, it is not going to be wrong. You may want to change the figure size. Maybe I want to keep the same height, but I want to increase the width. So I change it to maybe 10, right? Or vice versa. Sorry, width and height. I changed the height. I'm going to keep the height the same and I'm going to change the width now. Maybe this is a better one. So you play around with this and understand what is the right way. But now it is pretty easy for me to read. The darker shades are towards the negatively correlated values and the lighter shades are towards the positively correlated values. Where we have a weak correlation, towards positive it will be in the orange and towards negative it will be in purple. So if you just see this, can we not make out that these 24, 24, these are orange shades are very weak correlation. This is towards little strong correlation, as and when the score fades, the color fades, which means that it is a positively correlated. And if the if the color is really dark, it means that it is negatively correlated.
Can we set the color here?
Color, yes. There is a CMap that you can use to set the color. I don't like it, so but you may want to set. So I can think you can try CMap is equal to, and let's use Plasma, which was what I used. And there are a lot of bunch of other formatting. It is going to change the color. There are a bunch of CMap formatting options.
Karuna, can you explain once again why did we use annotation?
Sure, I'll just share why. Look for yourself, right? Because sometimes it's good to do, practice, and then see. What happened? We lost the numbers, right? So though we see the colors, but we don't know to what extent. So annotation will give the number of correlation. What is that value of correlation? If I want that to be appearing on my heat map, then it's good to use annot is equal to true.
Thanks.
This one.
So just one question. So now we have a lot of these variables. I mean, a lot of these fields being compared, right? Plotted. So how all of them are together in the negative side or positive side for whatever that got fixed into this matrix? Like for example, the one at below
the price per LB, this one?
Yeah, go to the negative 0.25, and then everything on the. I mean, how did it? I'm just trying to understand the negative 0.25 versus.
Where do you see negative
the positive
0.25?
On the right, -1 to +1.
Oh, okay, here. Oh, yeah, access. Yes, please tell me.
Okay, is this about the box plotting of all these matrix values on the left against this -1 to +1? Because I'm just trying to correlate the positive values on the stocks, like everything is stocks in that line versus.
No. Don't confuse this with this. Yes, a good question. Don't confuse this with this. This is just a legend. Like you plot a graph, and in the PowerPoint or in Excel, right? You plot a graph, and if you are showing for 2 years, would you not tell the audience this color represents this year and this color represents this year? Kind of legend that you provide.
Yeah. I mean, the legend aspect, I got it. I was just trying to see if this whatever standard normal distribution, whatever -1 to +1, is being tagged against each of these variable combo.
No, it is not. It is not.
Not,
No,
okay.
no. Yep.
Okay.
Not really. It is by fluke that you see these scores here. It may come up here. Yeah, it is not that way.
I have a question. It is on the function annotate. So is it related to core, and we can use annotate for any other function?
Yeah, annotate for any other function too.
Oh, thank you.
Yeah, you're welcome. Okay, let me show you something because you had that question. And it is quick to do it, right? I don't have to do a lot of code changes. So I'm just our investigation. I'll just show you something. You had a question about the access. Now, do you see the difference? It is just how we had the variables. This purple was actually here down below because it is all negative. Now it is up. So this color is nothing to do with the axis where the variables are placed. So variables will not be placed basis the axis color. Does it make sense?
Yeah, I got that. The only thing is the actual values. So there is an exact, I mean, in the x-axis you have 6 variables, and the y-axis you have another 6. Now all these are all these are forming the 6 into 6 matrix. But whichever for each of this x and y combination across this permutation, how 6 of them together fall under a -0.50. I'm just trying to understand. So is it always, how does it continue to be that perfect matrix while they distribute between -1 to +1?
It never does the overall calculation. You should never do overall calculation. It always has to tie up with one particular variable at a time. So this matrix is 6 by 6 because it is tying one variable to the other variable. Ideally, only the half triangle should be seen. The rest half is a duplicate, right? So you should ignore the upper or the lower triangle. Take one. And the way we read this is the diagonal is identity because look at the diagonal. I'm comparing x and y to its own variable. So numcol versus numcol. For the second one, it is price per LB versus price per LB. So it has to be 1, right? It has to be 1 always. Would you agree it will be 1? So suppose I have,
Basically, you knocked down the upper triangle, but it's just the lower triangle that we are probably for the ease of visualization.
Exactly. Yes, exactly. And we never say that, okay, this is the overall score, but we check variable by variable. And we pick 2 variables at a time to see if the variables are correlated. That is the essence of understanding the correlation. And you will see when we will talk about regression and all, you will see that I will ask you multicollinearity is a problem. Right? When we predict something, then the 2 variables should not be correlated. So you see these scores here, and stocks and product value or stocks and numcol. If I have to predict something here, then I would not be able to work with these 2 columns in my model. It is going to give me a bad result. So we'll have to fix for multicollinearity. That is the reason why we talk about correlation. And also when we provide insights, we can club it only with the other variable. It has to be only done in pair.
Got it. So just in that same line, right, the stocks, the lower triangle on the stocks, it is against the 4 x-axis, right?
Yes, yeah.
Now, all of them together on the right is -0.50.
No. This is just the scale. It tells you that in your heat map, if you see a lighter shade, which means it's positively correlated. If you see in the heat map, wherever you see an orange, it is somewhat positively correlated. If you're in the heat map, you see a dark blue shade, it is highly negatively correlated. If you see a light purplish shade, it is somewhat negatively correlated. So it is kind of legit.
Is it to be understood that all of these stock variable, I mean the stock row versus each of that x variable,
yes,
all of them are negatively correlated?
The price with all the other, yeah. the price per LB, not the stock, but the price per LB with all the x-axis, they are negatively correlated. You are right. You see the scores? They are all negative.
Got it. I got it. Thank you. Yeah, got it. Sure.
Sure,
Yeah.
sure.
Yeah.
Appreciate the question. Why? Because these are some of the things that we need to clarify. And that is why, the presence of human is important when you learn. Yes. You have a question? Okay. So good that we had.
Sorry, I have one question. This graph that it's coming up in the screen, is there a way to pop this out and look at this separately?
In R, there was a way. In Python, I haven't tried, but yes, there definitely has to be a way to pop it out.
Okay.
Yeah, I can find more about it. I've never tried it. Usually, it's the entire file that we work on. So there was never a reason for me to pop it out, but yeah, I can work on it and share.
The cat plot. So there is one of this cat plot and subplot. Will that help here? The subplot. I think in one the courseware had this subplot where it was trying to eject a part of the graph into separate plots, and the cat plot was also trying to do the same against the
Cat
category.
plot is for the categorical, right?
Yeah. So subplot.
Not the subplot.
Okay.
Don't think that. Yeah. Extraction of plot out of Python, right? Perfect. And was it Ari, you who asked this question?
Yes, Karuna, that's fine. Yeah.
See, I can understand your voice now. Some of you.
Dangerous.
All right. It's dangerous? Don't worry. You are safe to ask questions. Okay. Let's talk about this. What is the general production trend from 1998 to 2012? What do you think we can do? What kind of plot? A general production trend.
Point plot.
Yes, absolutely. So I'm just going to set the figure because that's my favorite, right? I don't want to see a very small graph coming up. So every time I have a habit of setting the figure. I think that's a good habit. So if you can, take that best practice, please feel free to. I'll just set the fixed size to maybe 12 by 8. Point plot, and I want to see the production trend by year, right? So maybe I'll say from my data year, and I'll again say maybe my data and type in the total production, and then be able to show the plot. So there's a larger plot, and you see what do you observe from this plot? I know that point plot you all will be able to write. In case you want me to type the code, I can do that in the chat window. But what do you observe from here? In the problem statement, sorry?
It has been more or less flat or declining.
It is declining, right? That was there in the problem statement also. They were facing some issues with honey production. Majority of the times they were importing. So though in the earlier year, we saw that the production was not very consistent. Say in 1998, it was high, then it reduced in 1999 by some point. I don't say it drastically reduced, but by some point, then it increased. So I'm saying for the first part, it was not pretty consistent, but later we saw that there was a decline. Gradually, there was also an upward trend. So maybe they were struggling to, get back with wherever they were with production. They could not. Apparently, we again saw that after 2004, the honey production started declining, and overall trend does show that the production declined over a period of time.
Ma'am, can't we have labels on this?
Labels for what?
For denoting the amount of production per year, which will be appearing on the graph.
Total production but don't you think that is going to be very, very clumsy chart? Because in the total production, you already have it here. This is the range. Yeah, and this is kind of average. Min, max, average. That is what it is showing. Okay, so now this is very, very interesting. It is, I think after this we are running short of time, but we have few more to go.
Karuna,
Okay.
before you go to the next one, in the total production, you are getting 2, 3, etc. I'm getting along with the zeros. How did that change for you?
I don't know how did it change, but I did notice that. It has taken the access, so yours is the correct one.
All right.
Okay, so next one. See, at times it happens that we have many categorical variables. Like in state, we have about 33, 40, 44, right? That's what we observed. But if I want to see the total production trend by different years by state, then will we plot for each and every single state? That will be very tedious. It's good to do the plotting of all the states in just one command. So that is done using the facet grid. Now, what is facet grid? It is a kind of framework that defines the number of columns and number of rows we want. Number of rows may or default to how many variables we have. You define the number of columns and basis the data set, what you want to plot by which categories. So here we are plotting by state, which has different categories, different states. It is going to give me just one big plot with all the state year by year production. So let us understand this code. It is a little tedious, so you'll have to do some practice. So the first thing that I'm doing is defining an object, right? Assigning an object G, or you can do anything, G, K, whatever. What I'm doing here is using the facet grid. Facet grid in itself is a framework, right? So sns.facetgrid. I'm using my data, all of the data, and I'm saying the columns are my state. That is where what I want to represent. And I want it to wrap. So I want 3 columns. You may, or maybe 5 columns. It doesn't make sense to put 3, maybe 5 columns. Some of these information are redundant. You can type height. You may leave it. It will auto fit. But the important thing is define the facet grid from SNS. Define your data. What is the column that you want to project, which has different categories, because you are using facet grid, which is a good option for categorical information where you have multiple categories. Define the number of columns in which you want to view the graph. Then you use the same thing and you use map to plot it. We'll use plt.plot, which is the matplotlib by plot. And I'm going to use year in the x-axis and total production on the y-axis. Right, and then the marker could be anything. You can put a dot, you can put a cross, you can so X, you can put an asterisk, whatever you want to show, because it helps us to determine that okay, this is for the first year, this value is for the second year. Every marker denotes the number of year. So it's a good option where you have multiple categories in your data. We do not every time use it, but it is a good usage where you have one variable with several categories. And it is also a little heavy, so it will take time. But yes, this is how it has shown. So you have, for the x-axis, you have years, total production on the y-axis. So Guru, to answer your question, I have the bunch of zeros as well, but it is raised to the power 7, right? That is how it is taken. If it is showing complete zeros for numbers for you, like 2,000 to 20,000, etc., that is correct. Here we have different states, and it shows me the trend of production. So at a very high level, we can see that state of California had a very high production. It was never consistent overall. As the year passed by, there was a decreasing trend, but the production itself was very inconsistent. For some other states like Colorado, you see that there is a same pattern of production throughout. And the production is very small to make a big difference at the overall production level. There will be some other state you would see. See what's happening with North Dakota. High production, right? Very high production compared to all other states. And the production also shows a little upward trend. So maybe this state is alone pulling the total sale volume. Overall sales volume. not the sales, the production volume. And similarly is the case for South Dakota, where the trend is towards a decreasing trend, but very inconsistent production. And the production is not as high as you see it for North Dakota. So by state, when you have to make inference, or why do we do visualization? To provide insights. When you have to provide insights about what is happening in the data, this is some great charts or visualization technique. Here you just at one go, you're able to form your opinion on what's happening for these states. Right? Some of the states never produced after a particular year. So this state, Maryland, stopped production after 6 years. That's a great insight, right? Nevada stopped production in the latter years. So, and South Carolina did not start production in in the earlier years, but it started whenever it started production and only produced for 3 years. So this is the kind of insight I think is very, very important when you recommend to your customer, so that your customer can understand that you know, this is the reason what is driving the total production or what may be driving the total production. There's just one piece of information, and you have to tie it to all other pieces of information in the data set to make a concrete insight or recommendation. Let us look at some interesting graphs now. So this question talks about, is there a linear relationship between number of colonies and value in production? So if in a state we have more number of colonies, would the production be high, or it would not? So linear relationship means that linear means straight, right? Straight. When you are trying to draw a circle, that is not linear. It's circular. So linear is always straight. So I want to establish a linear relationship to see if there is any, right? Whether it is a flat upward, flat downward, it is just a flat line, horizontal. What is that relationship between the two variables? And I'm talking about number of colonies and value in production, only these two. Which plot do you think you would be using?
LM plot.
LM plot? Perfect. So I'm also going to use a cat plot because you mentioned maybe slightly later. Let's work on the LM plot first. SNS dot LM plot. And what do we want in x-axis? I want my number of colonies, right? Because I want to see if numcol. And then you also provide y-axis. And in the y, I want my prod value. Again, you specify the data as maybe my data. Oh, sorry. I'll share something else in terms of formatting. So when you say that you want your, the picture should have a height. So I'll say, so let's not give any height right now. I'll just say this and maybe PL tissue. So let's do this and I'll make some changes here. It's a pretty small graph. May not be really a better way to see it. I'm just going to add height to it, right? So I'll say height is equal to maybe 5. So now it has adjusted height, but the width has not been adjusted. You can give a fixed size, but there is another way. You can just say aspect. Aspect multiplies with the height and adjusts the width accordingly. So if height is 5, aspect 2 will make the width as 10, the double. You can use it 1.5 or whatever, so it is going to adjust in the ratio. So this is a better view. So LM plot, and I have specified the x-axis, y-axis, my data, height, and aspect is just going to multiply by height. So width is adjusted with respect to height. You can set aspect to 1, which means that your height and width will be same, or 1.5, however. So this is another way you can use the fixed size. But what do you see? Is there a linear relationship between the numcol and product value? What insight can you generate from this?
Yeah, I think that's where I was actually asking. As x increases, if y also increases, it's positive. Otherwise,
Yeah.
it's inverse. But the line graph also has above and below to it as x increases when it comes to y.
Where?
So the plots, right? The scatter plot. As the x increases, the y is both above and below the line.
Right, right.
So what does the line
So,
represent here? Yeah.
okay. So the line is the line of best fit. And it is also a regression line. So we have yet not spoken about what is regression. But the logic says that we can draw many lines passing by all of these points, right? Can I not draw a line like this? It should pass by these points also. And I can draw a line passing by these. We can draw multiple lines passing by any of these points. But this line is the line of best fit that tells me that majority of the points are passing by this line or they are very near to this line. So it's a kind of trend. A kind of trend. When we'll read about regression, then we will also understand what is the importance of this line, right? And how this point will give me a small error versus this point. So I'll share all of these maybe a little later, but right now, because we have yet not read about regression, so this line is a line of best fit that passes through majority of the points and it shows a trend. Like in Excel, you can draw a trend line. This is that kind of line. So of course, these points, there are multiple points and some of the points can lie above or below this line. But majority of the lines are either very near to this line or passing through this line. This is how this line is drawn. If I try to draw a line passing by these lines, then not many points will pass through. Not majority of the points will pass through that line. Or the line will not pass through majority of these points. That is the logic.
Is there a way the correlation? So would mean that means that the determination of correlation is affected by this. Like for example, it may be 65% instead of.
Correct.
Yeah.
Absolutely. And we see that there is a linear relationship. As the number of colony increases, the production value increases because now more number of colonies will be producing honey. Logical also, right?
Yeah, got it. Thanks.
Okay, perfect. Now I'm just going to do the same thing, right? I want to use this, but I want to, this is including all the states. Every state has different number of colonies. I want to color code these points by state. When you want to do the color code, so this point may belong to AL, you don't know. This point may belong to South Dakota, you don't know, right? All of these points are corresponding to different states as well, because the colonies are scattered all over. So what if I want to see which of these belong to which state? I can just type hue. Hue is to give a color, so I'll just write hue and I'll introduce the category here. So wherever you have a categorical variable and you want to understand what is the impact of that original variable with respect to the categorical variable, you can introduce that as hue. It is just going to add color to these points. So now it is giving me different lines, one per line per state and different color of lines. Because we have multiple states, it doesn't make a lot of sense to me, right? It is not a very good representation, I would say. But from the utilization perspective, this hue command is used to give a color to wherever you have a category. So for every category, you will see a single information. Right, and this is not a very good representation because we have multiple states and the negatives, positive all over. Some of the colonies are producing, some of the states don't have colonies that produced throughout the year, etc. So it is not going to give me a very good view.
Also, the X and Y has changed, so the representation here is different now.
Yeah, here is a better representation. See, this one. It's the same thing. Maybe I tried some other thing there, or I must have redone. This is a better one. I have used year here. So it's telling me that for every year, there is a positive trend for all the colonies.
Karuna, Guru here. This graph, I'm not getting the.
No, this is the graph that you will get. Sorry. This is the graph you should get. Are you getting this? Anyone getting this kind of graph?
I am getting this.
Perfect.
Yes, yeah.
It
No,
was
I'm getting
because
the earlier graph.
change the aspect to 2. We were using aspect to 1. Maybe it's the size of the graph that mattered. But if you change the aspect to 2, it is going to enlarge and fit well. And then you can see that maybe these are the orange, so all of these correspond to these states. These colonies are for these states. Then where you have blue dots, these are for these particular states. Then you have some colonies in purple, so which state do they represent? So all of it is going to tell you that Texas, Tennessee. We can see a pattern also, right? Number of colonies are larger for these states and these states. And number of colonies are shorter for or smaller for these states. So this is what we can interpret from this chart. Okay. Now, and you can do the same thing for year, right? So that's the same thing. All of you are getting the graph? The same graph?
Yeah, just one question there. How do we determine what is the right aspect to get the right view?
Usually, it is definitely experiment, first of all. Second, if you see that the size is impacted, then you change it. You'll do some manipulation. Usually 7, 714, 816, 510 works fine. But there is no definite number. Yeah, there is no definite number.
Because it changes the X and Y value also, right? Accordingly.
Yes, basis the number of information that you are representing on X and Y, it will always change. So we cannot define the one height or one aspect value. You'll have to manipulate depending on the data that you are showing in visualization.
Karuna, I'm not getting this graph.
And I mean, I'm not getting the same graph.
Try this. Let me copy paste this over in chat window, right? You can try while I work on another one, right? Sorry.
I think the problem could be maybe you are working on the year, hue equal to year. Here I believe the hue equal to state is it?
No, I changed it to state.
That's right.
Which is the box plot. So anyone wants to talk about what is box plot? Any idea what is box plot?
Box plot is more towards the deviation across your, I think multiple data, what we can interpret is your outliners, the distribution with the, what you say, the first
distribution.
The quartiles.
Yeah,
interquartile range.
The quartile
Correct.
range. Right.
Correct. So it doesn't only show you interquartile, it shows you everything. The min, max, the
Min,
first
max,
quartile,
min.
second and the third. And these are the outliers. Anytime you see these points, it will be outliers, whether you have the points on the upper on or the lower. Seems that there is no outlier on the lower side for any of the years in terms of total production, but we do have a lot of outliers on the upper side. That's what this graph tells me. But a box plot is an excellent way of understanding by different columns what is the distribution of the data, and this is how we also identify the outliers and impute it. There's the visualization, we also do it numerically. So we won't do it numerically here, and I'm not going to give you a definite answer for what is the 25th percentile, what is the 50th, or why is it median, etc. We'll talk about that in statistics. So do not worry about that calculation aspect. At a high level, you should understand that the box plot gives you the distribution of the data, and wherever you see the points lying beyond the min or max, those are the outliers. The middle line that you see here is the median or the 50th percentile. Right? This is what you can understand. So how can we draw this? Let us draw PLT, and here I'm just going to use subplot because there was a question, right? So I'll use subplots here, and I'm going to use the fixed size of see here are many years, so I can use a fixed size of say 20 by 10. It is very manipulative, right? And you will get a hang of it once you practice. And also understanding your data. So I'll say SNS box plot. And I want my year on the x-axis, and I want the total production on the y-axis, and then you just give your data is equal to my data. And last PLT dot show to see the box plot. So it's going to give you the same box plot that we had, and you also see that it is every year has a lot of outliers. Are these valid or not valid? Do we need to impute or not? We're not going to do it today, but yes, this shows me distribution per year, and on an average, right? For the first few years, the distribution, the production on an average has been high. During the later year, the production has reduced. The range you see from the 25th to 75th has reduced. So later part of the year, we are not able to produce as much as we used to produce in the prior years. That is what we can conclude from this graph. So as side note, I'm also going to give you some cat plot, because there was a discussion today on the cat plot. Let's do it. Let's do it here only. Let me add another. Let me insert another cell below. And let me quickly do the cat plot. I'm afraid if we run out of time. So I'll just say sns.catplot. And again, I'm just going to use the same thing, right? So year is equal to my, x is equal to my year. And let's use y is equal to numcol. Numcol, okay. And I'm just using kind is equal to maybe strip. There are many kinds. There is strip, there is, I think, there are different kind that is available. So if you check Google for cat plot, you will see that in the kind there is swarm, there's strip, there are many types of kind. So it just gives you different visualization impact on how the data shows up. So I'll show you what I mean in a while. My data, and I'm just going to say orientation. Orientation can be two. Either you set it to be vertical or horizontal. Not a great lot of difference here. In the box plot, it is very helpful. But just so that you know, we do have orientation as an attribute, and that could be set to horizontal or vertical. I'm just going to use my height is equal to 5 and aspect is equal to maybe 3, because we have a lot of years. Let us see if I get anything. Perfect. So this just gives me the concentration of the number of colony by year. Doesn't tell me a lot of things. It doesn't tell me that majority of the, of course, there are colonies, more number of colonies in the prior years, but and lesser number of colonies in the latter years, but I cannot be very definite if it has reduced significantly, right? Of course, there is some drop in the number of colonies, but I cannot say a significant drop. So cat plot will give you this. I think there is another one which says swamp or swarm in the cat plot. Don't know what it is, swamp. Let's check swarm. No.
I think the P, okay.
Yeah, swarm. It's just telling you. So it's another way. With kind, you just draw another visualization. Good to have visualization, but it is not mandatory. Some of the information is not very mandatory, but because we discussed, I had the time, I was able to show it to you. I would encourage you all to explore. And we don't use, a lot of visualization of these types. It is used to the extent it is required in the data set to give meaningful insights. At times, we just go by simple PLT plots and all. The line plot or the point plot, the linear. So, but SNS plot, right, the heat map and SNS, they are very, very important. So some of the, and the box plot. So some of the information will be repetitive whenever we talk about it during our next sessions as well. But some of the things you can take away from today's session is how to use facet grid, how to use hue to give different color when you have different categories of your variable, how to use box plot, heat map with different information, and SNS plot. There are different attributes to the pair plot also. See, the diagonal is histogram. You can change it to kernel density using the kind. So I'll take you through that gradually, right? You'll be introduced to new concepts gradually. I don't want to bombard you with all the different codes. So let me not make it very complex. Let us revise what we have learned today. And I'm going to send you this file because we use some additional commands that you may not get in your Olympus file that will be uploaded. So you'll receive another file in your maybe WhatsApp later today so you can practice. Right? Any question, team? Make sense? Does it help?
Yeah, the only question currently I can think about is that the heat map, the facet grid that you so I mean it's for what type of graph?
The heat map or the facet grid?
The facet grid.
Oh, facet grid is for the graph where you have a column in your data set. Like we have a column of state, right?
I get the purpose of it, but the actual type of graph that comes below looks like a line graph. Is that a line graph by default?
That's a line graph. Simple point.
So there is a change to that. We can change that also.
You can, yeah. Why not? You can draw histogram. You can draw different kind of graphs. But the facet grid just tells you that you have the option to have multiple levels in your data. The graph type can be changed. You just change it here. And the best way is to also Google out some cool graphs if you want. But the graph type could be definitely changed.
Okay, so would this be the most generic and abstract application function for the graph, that any type of graph can be fitting into this? It's just a facet grid. Becomes an umbrella.
Yes, facet grid becomes the framework, and then you can fit the graphs. Yeah.
Okay. So every other graph that we discuss can be part of facet grid.
Yeah, you can try. You can definitely try.
Yeah. Okay.
Definitely. You can try point plot also. You can try. Not the pair plot, right? Pair plot is just to show you the relationship between two variables. So not the pair plot, but the point plot, the cat plot, all of those you can.
Okay. Sure.
Okay, these are some of the numeric. I'm just going to see if we did cover. So we covered numeric as well as the visualization. All of you are good with whatever we covered till now?
Yeah. Yes. We'll be sending this file, right? Because some things are not working. I will try it later.
Yes, I'll be sending you this file because some things, if you did not work during the session, you may try, and if you still face the problem, then you can send me a message, right? I'll be checking the message later today and tomorrow. Other thing is, not all the codes will be there in the same file that will be uploaded in Olympus because we did try some additional codes. So like the cat plot and the subplot, all of those. So it's better to use this one. You'll be getting it later today in your WhatsApp.
Just shared a link. I found that link really helpful. It has all the stuff that you just showed us with examples.
Okay, great. So team, if you can copy over this link, right? And Ari, please send this kind of link in the web, in the WhatsApp, because what happens, this chat will go away, but your WhatsApp will remain, right?
Sure. No, I just came across this now, so I just thought I'd share.
Please do, sir. Now, this is regression. Again, regression. So do not worry too much about the concept. I have not even taught statistics, right? So you have not got an introduction to statistics. Regression is far beyond in the topic. So if you do not get a lot of information or insight from this, do not be overwhelmed. We will talk about that gradually. But yes, any best thing that you see, always feel free to share.
Sure.
Just if there are any time, just one question. So, how do we check equals to null? I mean, is null fine, but when we pick the conditional, the is null always returns the true as well as false for the entire set. But if I have to just pick the true alone,
But what is the purpose? As in, why do you want to do that?
One of the questions that I got in the quiz is to impute that.
Impute is null?
Yeah.
So when you say impute, you are calculating, right?
No, it asked me to impute, identify nulls and impute that with 1.
Okay,
and then find the mean on top of it.
Correct. Got it. So it's the finding the null, right? So you can type it using is null. So you have or sum. There are X number of missing values. If you have to impute, we have used drop NA, right? Which drops the value. You can, if you have to impute it with just one number, you can write fill NA. Fill NA will fill the value. So fill NA, and then you can type it 1 equal to 1. That will fill all the missing values with 1, and then you can impute the mean using the mean.
So is there a yeah, because I didn't find that function in the courseware. Is there any link that I should, even the cheat sheet did not have that.
So the best thing is, in case you get those questions and you are not able to find out, Google is your best help. The second thing, as and when we'll go through this in this course, we will definitely use the fill NA. You will use all of those commands gradually, if not right now, but in 3-4 sessions, you will be using the fill NA.
Okay.
There are a lot many commands that we'll be using. But yes, if you get this question, bring it to the team, bring it to the WhatsApp, and we'll help sort it then and there.
Sure.
Yeah.
Thanks.
Okay, you're welcome. All right, team. Thank you so much for being flexible. We have spent 37 minutes over. Appreciate your time and my connectivity. Thanks to it today. I expect we don't get into this next time. Any question for me?
Yeah, if you could just tell us how to add data value on the each chart, the data value which is just missing.
You want?
Yeah, it is. Yeah.
So in
data
a data
value, if
frame,
you could just provide it.
In a data frame, there are two things, right? Where you want to add a bunch of other rows, bunch of other observations, and you have those observations in a different file. Then you join both the files together, right? Bring the values from other files and join it. But where you are just adding a column, which we do, we bring entire data set in Python and then manipulate. When we manipulate, there is a need to add a column. So that is done exactly in the same way like we added EPW in the first session.
Yeah.
Right? So you add a particular column and then also justify what the calculation should be. If you have that in any other data set, then you bring it over to this data set using iLocation. You can do that. From the other data set, extract it and then add it here. So if you want some kind of examples, maybe let's talk about in the next session, and I can give you, or I can send it to you as separate piece of the code, if that is what you are interested in.
Yeah, sure.
Okay.
Thank you.
You're welcome. All right, team, I would not hold you for long. So all of you, thank you. I'm already seeing thanks and thanks everyone. So Saugata, thank you, team. So let's talk next week. You have your project. If you run into any question, you want some kind of information, not in reference to your quiz or project, but from the concept perspective, then I'll be available so we can connect. Otherwise, all of you, all the best, and let's talk when we meet with the statistical stat session.
So this is the Excel output we have. So what lessons can we learn? So let's first look at the most popular measure, the arithmetic mean. Mean 79.8, here it is 54.46, 58.48. Now arithmetic mean is, all of us know, defined as the sum of all observations divided by the number of observations. Everybody knows. So in a formula notation, if you write it is sigma x by n, something like that, you will write. 79.8, 54.46, 58.48. Arithmetic mean can be combined for 2-3 groups. For example, your class average arithmetic mean, if I compute, and I know the arithmetic mean of the batch that came here in July, and then I want to find out the overall what is the mean of both the classes. I will take the weighted average, using the number of students in the class as a weight. So n1 into x1 bar plus n2 x2 bar, or w1 x1 plus w2 x2 divided by w1 plus w2. I cannot do the weighted average for the median and the mode. In other words, arithmetic mean can be mathematically treated. It is a very comprehensively defined measure, very comprehensively defined, and it is based on all observations. It can be computed for more than one group as an overall weighted average, which I cannot do with the other measures, median and mode. But a big drawback for arithmetic mean. Arithmetic mean is affected by outliers. The word outlier means extreme values, extremely high or extremely low values, called outliers. Extremely high or extremely low values can be affected by outliers. That's a cautionary tale I put here. I want you to look at this slide here. Now, if you see this, every learning part you have caution. I always put, I like this, caution. So in other words, read all the chapters of a book or concepts and generate some cautionary tales where the technique can go wrong. It's not always that I do this, I do regression, I do all this. Where regression can go wrong, where arithmetic mean can go wrong. Caution. Affected by extreme values or fluctuations in sampling, called outliers, O-U-T-L-I-E-R-S. Extremely high, extremely low. Arithmetic mean is not a reliable measure to use. Cautionary tale, caution. The whole course you can write it as a cautionary tale. Where things can go wrong, you should know as a specialist. Otherwise, you go wrong and you may have to go from the job. There's a risk. You have to be precise where things can go wrong. An example of an outlier I will give you, because everybody understands cricket. Bradman scored in one match against England some 600. Australia scored some 600 and odd runs. So, arithmetic mean of a player, 10 players, 1 not out, so 60. So everybody got Padma Bhushan. So 60, a very good average. But Bradman himself scored 337 runs. Century before lunch, between lunch and tea, another century, tea and close of play, another century. 337, he got out later. And the great critic Verity was writing, if I were to tell about the overnight not-out batsman Bradman and Pansford, children will tell me, keep your imagination within limits. The wicket-keeper used to take rest because there is no need for him to gather the ball. The ball will be pulverized, sent to the fence. Bradman never used to hit a lot of sixes, very risky shots he used to say, but all ground shots. He was a master. So, Bradman's 337 you remove, What is the average of the remaining 9 players? Some 20 odd. So you should thrash them. You should not give Padma Bhushan or Padma Shri. They don't deserve anything. That what the hell is going on? But what to do? That is Bradman. So Bradman is an outlier. You're able to see extremely high or extremely low value that will distort the picture, and therefore in those situations arithmetic means weakness. Outliers can disturb. Now we come back to the case from the Excel output. Of course, we have to find out outliers and all, but primarily it tells me a story. When I look at the mean, look at the median, look at the mode, all of them point to an interesting thing. The work climate is perceived to be substantially superior to pay and promotion, regardless of what summary measure I use. Measure of central tendency, it is called, either the mean or the median or the mode. It's very clear the work score is substantially larger than pay and promotion. Pay and promotion more or less clubbed together. Let us not do any hair split. Pay and promotion both are worse. Let us not find out which is the worst. Both are worse. But the work climate, if you see, 79, 54, 58, 82, 55, 58, 72, 60, 52. You find any summary measure, it's very clear that the nurses like the work environment, which has substantially a higher score than this. When you are writing a report, don't write like this. As can be seen from the above table, the work score for mean score for work is 79.8, whereas for pay it is 54.46, and for promotion it 58.48. That is known. The table itself should say the work score, perceptual score, or the environment, work environment, is substantially superior to pay and promotion, and within brackets put the scores. That's a style of writing. Then what is the meaning of insight? Meaning of insight is, this is no doubt interpreting the data, but some insight I can get is, in spite of a rather poor pay and promotion score, the nurses still like to work in the hospital for the work environment. Does it mean, I'm raising a question, that if only you address the problem of pay and promotion, the work score may still zoom further? Exclamation mark. That is insight. Are you with me? That's the insight. But I'm asking, is it possible? Because if pay and promotion perceived to be poor, in spite of that people love to stay in the hospital, the nurses would like to work there. That's what is called the work culture. Does it mean if the hospital administration, if they redress the problem in pay and promotion, will the score of work environment still go up further? Are you with me? That's the insight. That's the question that you should ask. Then, if you see the other way, anyway, pay and promotion, even if it is poor, they are happy with the work environment. Why should I worry? Why should I address these problems? Let me keep quiet. Then what may happen is, over a period of time, because of the frustration in pay and promotion, the work score will come down. You cannot assume perpetuity and people will continue to give you good score. The frustration will set in, and at some point in time, they will start diminishing you even in the work score, and therefore you better address. That is management insight report writing. One of the skills you should develop in a course like this is your ability to write a fantastic report, major findings, implications and all that. What is after all your project? capstone which you are going to do. Introduction to the study. The scope, why you are undertaking the study, data and methodology, analysis and discussion of results, major findings, implications to the analytic professional, limitations of the study, scope for future work, signed, sealed and delivered your capstone project. Right? So, what insights? How the client will make use of this report? The question, my dear friend, don't think that you can keep quiet and pay and promotion. They will continue to give you high score. It can come down. You better address. And if you address, this can go up even further. It may become 85, 90. It is to your advantage. Then the pay and promotion score also will go up. There is a harmony. And one of the biggest aims of the hospital is to retain the nurses. You do not want to lose them. You better take action. That's important. Are you with me? That is statistical insight. That is the way you should write a report. What do the numbers tell? Whether it is median, whether it is mode. Now let us look at median. What is this median? Let us look at median and mode before we comment. What is this median? If you see, the middlemost observation in a data set, when you arrange the data set in the ascending order of magnitude, also descending order. I pick up the middle value is the median. Median is not only a measure of central tendency, median is the average of location. I locate the point. I don't calculate anything. I locate it. I arrange the data and pick up the middle value in the ascending order. Look at this data set. For example, 7 students in computer science exam, they get this marks. Arrange the data in the ascending or descending order, pick up the middle value. 1, 2, 3, 4, 5, 6, 7. So, n plus 1 by 2, it's the fourth observation. This is the median. That means 50% of the data values are above the median. 50% of the data points are below the median, middlemost. Now, median has the advantage. It resists and fights in a much better way. It has the power to fight outliers or extreme values. Why? Because I'm taking the middle value, the extremes are whisked out. They are whiskered. They are thrown out. Why? I'm looking at the middle value. It is a much better measure when there is outlier present in the data, whereas arithmetic mean is influenced by outliers. Median is location. I pick up the middle value, and therefore one of the plus points of median is it has resistance and the ability to fight outliers present in the data. Are you with me? Outliers present in the data. Okay. Now, you have said this outliers present in the data, it has got the resistance. But what is the problem of median? I have the average median of this class. I have median of another baby program class. I cannot combine the two median. Why? Because the first class I have taken the middle value, 50th percentile of the middle value. By arranging the data in the ascending or descending order, the rest of the values are not considered. Similarly, in the second class, it will be absurd on my part to take the average of the two, even if it is weighted average, because it is not based on all observations. And therefore, if I want the overall median, 55 students here, 65 students there, the entire 120 students I must arrange in the ascending order, pick up the median, and therefore median cannot be mathematically treated. As a result of the plus point, there is a corresponding minus point. Just like antibiotic side effects. It cures something, but it has some other value, some other problem. Similarly here. But there is another way to look at it. I take 1,000 observations, it resists the outliers. But still the middle point is taken due to prarabdha karma or past karma. The rest of the values are thrown out. Mercilessly. Is it correct? That's the question. That's median. Middle value is identified, the rest of them are thrown out. But the rest of them are required to identify the middle value. The moment it is identified, they are dropped like hot potatoes somewhere. Unceremoniously dropped. Mode is that value which occurs most often. Or the largest occurrence value is the modal value. Median is used for this. We said market research everywhere. Data, when I want to find out, I use that. Box plot uses median as a reference point because it can find outliers. Mode is a very powerful, very useful measure when you want to keep in the inventory the most popular collar size of the shirt during festival season. Diwali or Christmas or Pongal, whatever, you have to keep the most popular ready-made garment. So you look at the collar size, most popular one, mode is used. Or Bata shoes you go, mode is used. But a caution, what is a caution? Mode may not exist in all situations. When I plot the graph, I may have a pattern, something like this, a multimodal situation where I will not be able to identify uniquely the mode. That's the caution. Caution. You learn like this subject. It's a magnificent subject. Even a poetry and literature student can touch it to not bite. You have to love this. You have to look at the whole subject. Like the Mona Lisa's painting. You have to look at different angles, different things to appreciate. Like a creative art. The glory of this subject. Do not mechanically study. You have to appreciate. So pattern, again, multimodal. In quality control, what do you say? You are mixing, my dear friend, stratify. The 7 QC tools. Check sheet, histogram, scatter diagram, stratification, Pareto chart, Ishikawa diagram, control chart. The 7 QC tools. Stratify. You are mixing the production in the first shift, third shift and all that. You are making an avial which is sometimes not tasty. A khichdi. One source of variation at a time. So the mode, some situations, even if it is a problem of mixture, even if you address, there may still be a pattern of more than one point, which is a peak point. So mode cannot be used in those situations. Now, mean, median, mode. Are they the only 3 measures? No. You have harmonic mean, you have geometric mean, other measures are given in the book. They are also used, but these are most popular ones, so we study that. The computer gives the output. Where do you use the harmonic mean? Where do you use the geometric mean? Geometric mean of 2 numbers, how do you define? Root of A into B, AB means root AB. Geometric mean also can fight outliers very well. You use geometric mean when you want to compute the cost of living index number. Cost of living index in the country, you take the current period and all that, and the essential items, commodity in one basket, something maybe like a bun, bread, tea, potato, onion, and all that, how the prices have gone up at the consumer side. The government of India works out the cost of living based, unfortunately, on the wholesale price, but you'll have to do the consumer price. See, when you buy finally the fruit in a shop, the apple is 25 or 30 rupees per piece, whereas in the beginning it may be 18 rupees. So if the cost of living is worked out on 18 rupees, it may be incorrect sometimes. Geometric mean is used for cost of living. Similarly, speed. I will put a question to you. I will ask straight a question to you. Let's say you take from point A to point B, you walk. Okay? In the beach, Marina, let's assume. Same distance A to B, and then you come back to A, your journey. A to B, while going, you were able to clock 4 kilometers per hour. Okay? While coming from B to A, because you had to walk against the wind speed, you are able to clock only 3 kilometers per hour. What is the average speed? If I ask you, one of the multiple choice answer is 3.5. To trap you, it's wrong. I give you a hint also. Now, how do you do this? Huh? Yeah. Arithmetic, no. Arithmetic means 3.5 is wrong. Average speed. Distance you said, yes. Correct. But the distance what is given? You walk from A to B 4 kilometers, B to A 3 kilometers. Now, she is right. If you want an unconventional way of learning, that will be any distance you can assume, the answer will not change. The easiest way is, which I was taught by some great teacher when I was in the 8th class or 9th class. Assume the distance to be the LCM of 4 and 3. 12 kilometers distance. While going, I would have taken 3 hours. While coming, I would have taken 4 hours. In 7 hours, I have covered 24 kilometers. The average speed is 24 by 7. Which you define in statistics as the harmonic mean is the reciprocal of the arithmetic mean of the reciprocal of the observations. I had a hearty laughter when I was taught like that harmonic mean, not to the teacher, but in the bathroom when I was taking bath. Because I could not laugh at the teacher, I will be punished or I may be mistaken. But it is so easily explained, assume the distance. So what do? Harmonic mean is the reciprocal of the arithmetic mean of the reciprocal of observations. So it is the reciprocal of, let us say, 2 numbers A and B. It is the reciprocal of the arithmetic mean of 1 by A plus 1 by B. So 1 by A plus 1 by B by 2 of the reciprocal of observation. So 2 by 1 by A plus 1 by B, which is 2AB by A plus B. You are doing the problem like this. I can do like that. That is the teacher's greatness. I salute those people who taught me. And in all humility, that is the reason I am able to stand before all of you. Those are the great days, the concepts. And I also have during Saraswati Puja, some of the greatest books like Fisher's, the Snedecor, some of the world classic statistics books. I never part with anybody. In the Saraswati Puja, I keep it and touch them in the Vijayadashmi day so that I get knowledge. And really speaking, you go to those great gurus, you learn. I am not a guru, but they are the gurus. We are only using some computer and then trying to do some magic here. But they are the people who created the knowledge. Google doesn't create knowledge. Google disseminates knowledge. Don't mistake. Sometimes Google can be wrong. I'll show you some places. It can be wrong. Don't totally believe. Sometimes it can be wrong. Google doesn't create knowledge. Does it create knowledge? It disseminates. The person who created the knowledge is the greatest. So this is the part. Now, let's quickly go back to answer the question our friend has asked. Let's come to the brass tacks. So now let's see one by one. Arithmetic mean, median. 82, 55, 58. So what has it done? It has arranged them in the ascending order. Now you ask a question. Yeah. The median is selected. What is your question? Yeah, obviously. In other words, when I have got 50 observations, 50 plus 1 by 2, it will be 51 by 2 between 25 and 26. Therefore, it has taken the average. Yeah. But if you use the principle of quantile, I can define it slightly different. But that's what the software does. Quantile. Okay, 55.5, it has to take that. Now, See, the definition is 50% above, 50% below. So if between 25 and 26, if I take 2, that means 24 observations are before 25, 26 and 24 are after 25, 26. That's it. Hence you do that. Now mode 72, 60. Now I will give you the flaw in Excel. We believe Excel, am I right? I will reserve this for you and then find out what is the flaw. Mode it has reported 72, isn't it? I will come back to that. You circle it, you put a color there, a filler. Fill it with some green color, yellow color, keep that output. Okay. The standard error, as I told, standard deviation, it is asked. What is this standard deviation? The standard deviation is based on a quantity in statistics called variance. The variance is defined by a formula, some sum of x minus x bar squared by n minus 1 for the sample. For the population, it is divided by n. This is the variance and this is defined as s squared. The population variance is defined as sigma squared, sum of x minus mu. Mu is the mean of the population divided by n. The whole world gets confused in statistics. Once, if you cannot convince somebody, you can confuse them using statistics. Arithmetic mean for the population, mu. Mu is the population arithmetic mean and it is estimated by x bar. We all of us know that. X bar is a sample mean. So the definition is, I take all the observations divided by the number of observations. Mu and x bar, no confusion. Population units I take divided by capital N. Let us say capital N is the number of units in the population. Small n is the number of units in the sample, which is a subset of the population. Now, no problem. So, what inference I have? I am saying this x bar infers something or represents a good estimate of mu. It estimates mu. No problem. I take the sample 10 students in the class salary divided by 10 and I say this is the population salary of the class. Estimated. Everybody understands. Now, what is the variance in statistics? I subtract the mean, which is mu here, the population, from every observation, square it. It is the sum of squares measured from the mean, deviation. Subtract the mean from every observation, square it, then average out divided by n. That is called variance. I understand. In other words, the variability in the data, a deviation or a departure from the sample mean, each sample point represents, I square it, divided by n. The variance comes. Okay. Now, the first question is, if this is defined as sigma square, if I take the square root, it becomes the standard deviation. The first question you should ask is, why should I take the square root? Why not I leave it with the sigma square? Why am I taking square root? Please answer. Brilliant, 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 brilliant. You are the eagle of the class. Excellent. Some 2-3 eagles already I have identified. And class is full of eagles now. Every member in the class is an eagle. Excellent. Same unit of measure. Excellent, excellent. Wonderful. So you are taking the square root, standard deviation. So the standard deviation measures the departure of the data points from the arithmetic mean. How far the data points are scattered or dispersed around the central tendency. Is it a distribution which has a large spread or a small spread? Let the light come, I will draw and show you the standard deviation. Okay. Now, the same way I should have divided the sample denominator also must be n. Am I right? But there n minus 1 you are doing. Once I start understanding the subject, one googly you are putting. The moment I understand another concept, another googly comes. And you will have to face them. Why is it this is n minus 1? Does it mean if I divide it by n, it is wrong? Next question, devil's advocacy. Why is it n minus 1? I am dividing here. If I had told me it is n, I also do it n, no confusion. Take the square root. One answer is computer divides it by n minus 1, sample variance. You can check Excel or anything. This n also should be n minus 1. No, you are confusing with the degrees of freedom. That is later. So, they both are spread across. That's not the answer. Now, no bell curve, no. Don't come to the bell curve at all. Neither bell nor curve, no. We'll come to that. We'll come to that later. We'll have to give you the proper perspective. We'll come to that. That I know. We have told also. But why n minus 1 there? Should it not be n? That's the question we are asking. Devil's advocacy. Sample reduce 1. There's no such rule like that, my dear. Now, there are 3 estimates in statistics. Efficient estimator, consistent estimator, unbiased estimator. Now, efficient estimator and consistent estimator, I can put n there. N minus 1 is not required. N. In other words, putting n is not wrong. That's the first thing. If you are divided by n, it's not wrong. But why are you dividing it by n minus 1? Because I want unbiased estimation. Unbiased. What is the meaning in statistics? Unbiased estimation is when I take a sample of 10 students in the class, I could have taken the 10 students 55C10 ways. 55 students are there, 10 students I pick up at random. Every 10 student selected out of this population will have an arithmetic mean. It's not, I take one 10, another 10, another 10, I will generate lot of arithmetic means. Then the mean of all the means will be the class average. That's called unbiased. In other words, if I keep on doing this several times, every time I compute x bar, then I generate a number of x bars, then x bar or the mean of all these x bars will be the true average of the class. Intuition. Now, similarly, when I take the variance based on the 10, another variance, the expected value of all the variances will be sigma squared only when the denominator is n minus 1. That is the definition of unbiasedness property. And therefore, I will have to divide it by n minus 1. In other words, without going into the derivation, property of unbiasedness warrants the denominator to be n minus 1. Dividing it by n per se is not wrong, but it is recommended you do n minus 1. That is an academic, scholarly, statistical interpretation by me. Generally, we take n minus 1. Unbiasedness property. So, that's the answer. But we don't have to worry about it. Computer makes the job easy. But in a multiple choice, if you are given some 8, 9 numbers, you may be trapped by dividing by 10, one of the multiple choices, then you may be crying. So I'm just cautioning you. Sometimes you write a exam, a green belt or some exams you write, they trap you. They don't give you computer, they give you a calculator, ask you to do it, 200 questions, multiple choice. One of them, they are trapping you into this. Be careful. So that is why I'm saying this. So now, if you look at the standard deviation also here, as you can see, 8.29, 14.75, 16. So what exactly the standard deviation is? Do you like this distribution? I'm just hypothetically drawing a bell curve. So we'll come to that later. Let's say this is the average here. Now, do you like this distribution? Or, in other words, this has a higher spread around the central tendency. Standard deviation measures the departure of the data points from the central tendency. Let's say hypothetically it's a bell curve. You do this. Would you like this, or you have another bell curve which is embedded there, or you are shrinking the departure from the central tendency, the data points, and I ask a question, which is better? Second one is better. So the idea in a process control is to reduce the standard deviation of the process, so that you are in a position to meet customer specification limits, which is design quality. So the whole aim of bell curve is to understand the pattern in the distribution, whether there is a chance cost or assignable cost, and the idea standard deviation smaller is better. Look at a stock market. I have several stocks. I might buy a stock where the standard deviation is reasonable, like the Hindustan Lever. The risk return trade-off. The return is on my investment on the stock, which is the gain in the stock price plus dividend, anything received, divided by the previous stock price. And I have a standard deviation which is considered as a risk in finance. So the risk return trade-off, standard deviation becomes very important. So would you like to buy a stock with a higher standard deviation than another one? That's a matter of risk appetite, because without risk there is no gain. So what fundamentally you do in standard deviation is, you have here return here and a risk here. Risk in percentage, return also in percentage. Let us put the risk is measured in standard deviation. You have low, high, and you have high risk, therefore high return, some stocks will be here. Medium risk and medium return, some stock. Low risk, low return, some stocks will be here. And I need to balance this and which one to take. Then I will say I have 10 lakhs. I will spread it across several portfolios so that the overall risk is minimized. I will not put everything in a high risk one. It depends on the risk appetite. The famous Markowitz model where he won the Nobel Prize, risk return trade-off, efficient frontiers. So nobody will put everything in one basket, 2, 3. Spread the risk. So standard deviation is an important thing. Here look at the median, look at the mode, look at everything, and look at the standard deviation. You find here all of them. So the work environment is a fantastic one. Kurtosis, what is this? Kurtosis is pickedness. In other words, I may have something like a bell curve here, but just to see here. Pickedness. More picked. The curve is more picked. That's called the leptokurtic curve. Leptokurtic means more picked. Kurtosis measures the degree of pickedness. As opposed to this, I may have a very flat one, totally flat. That's called a platykurtic, P-L-A-T-Y. So the first one is lepto. This is leptokurtic. Leptokurtic, K-U-R-T-I-K. This is platy. It is flat. So platy. And just about the right level, mesokurtic here. Just about the right level. Meso. And your bell curve is a mesokurtic curve. Neither tall nor short, but just about the right level. Pattern in the data. That means for this you will have to draw the histogram or box plot and find out the pattern. But broadly I am explaining what is the term kurtosis there. Now, the most wonderful thing is people do not attach much importance to kurtosis because the central limit theorem comes there. The skewness is lack of symmetry. When there is no skewness, mean is equal to median is equal to mode in a bell curve. All the three measures are equal, completely secular. We can have a concept in the constitution. What is the definition of secular? Mean, median, mode. They are friendly in a normal distribution. All the three are equal, no fight. All are equal. Mean, median, mode. Symmetrical. That means, what is symmetry? If I move one point here, if I move another point here, one standard deviation, 68% of the data points will be covered. Bell curve. The rest of them will not be having that symmetry, skewness, lack of absence. But a bell curve which is more peaked, you will realize later there is what is called a T distribution, that is also symmetrical. But mean, median, mode, all the three are not equal there for that. There is a difference. Okay. Now, skewness is lack of symmetry. Negative skewness, positive skewness. When we come to box plot, I will explain this skewness again. But let us now focus on the most important thing in this case study. Yeah. But right now, let's say all is not well with the hospital. Now, the basic question which you should be asking, which you are not asking, is what problem skewness and kurtosis and all that, particularly skewness, what problem it poses? If you are asking, if I have a bell curve, have you heard the term Six Sigma? All of you, you answer no. You are asking me question, now I will ask you a question. Six Sigma, what is it? 99.9% you are wrong to the power infinity. Next.
3.4 defects per million opportunity.
Huh? 3.4
defects per million opportunity.
Per million parts. Okay, ppm. Or 3.4 defects per million opportunity, TPMO. Physically, it can be parts. Okay. What is 3.4 defects per million? You measure it on what? You tell me. You measure it on what basic assumption? The Six Sigma assumes a bell curve. Otherwise, this 3.4 will not come. Bell curve is required for Six Sigma, that you have forgotten to tell. There you are not asking skewness, kurtosis and all that. You are accepting blindly bell curve. Have you ever questioned Six Sigma? 3.4 defects per million is based on Six Sigma is a statistical measure of a bell curve where you say 3.4 defects per million opportunities are ppm. Okay, now why they are saying that? It's because in a bell curve, actually it is not Six Sigma. Do you know that? Second, googly. No. The process average shifts over a period of time. It's not fully centered. There is a 4.5 and a 7.5 in between Six Sigma. The average of the 4.5 and 6.5. And the 4.5 sigma in a statistical table will tell you 99.99966% of the parts produced are error free. 0.00034%, which is 3.4 defects per million, is actually 4.5 sigma, the second point I am telling you. Why is it called the Six Sigma? Because I want to err on the safe side. If it is 7.5 sigma, I would have got an exceptionally good standard. But on the conservative side, if I make a 4.5, I still achieve 3.4 defects. And this 4.5 and 7.5, somewhere in between, is the famous Six Sigma, which is the average of the two. The name given Six Sigma, but actually it is 4.5 sigma. If you are writing a green belt examination, you should know this. Why? Bell curve. If it is not a bell curve, this measure will not hold true. So the question which you should ask is, why you want a bell curve? Answer me. Let us have a discussion. What is so great about a bell curve? Think about it and come back. Then we'll finish the case. Later, we will highlight that. Right now, a critical thinking skill. An exercise, I give it to you. Why bell curve? Why bell curve? Right, 10 points. Don't Google. On your own way, you think and do it. Because if you keep on Googling, you will not learn. Go gaga over Google. Write an article like that. Forget Google. You are the Google. You can be Googled later. Who knows? Later you Google in your projects and all. Now you don't Google. I am asking you to think. It's called critical thinking skills. Don't make Google think. You think. Why bell curve? Keep it with you. Let me complete, generate the answers we will discuss. Right now, let us focus on the case study. So what we have learned from the case? We have learned by and large, what is the range? Everybody knows. What is range? Maximum minus minimum. Okay. Now there is one more measure. Supposing I want to compare Gujarat and Bihar on a particular measure, particular parameter. Gujarat is a fully developed state. Bihar is not a fully developed state, underdeveloped. Supposing I do that, I find some mean and standard deviation. Obviously, you will get an impression Bihar is very bad. Now, standard deviation divided by mean is called the coefficient of variation, which is the CV. The coefficient of variation must be used to compare different segments or different groups, not standard deviation alone, because it may be misleading. The coefficient of variation is a pure number in percentage when you express. It does not have the problem of the scale, it is a pure number. And it is a percentage which measures consistency in the data. For example, in cricket you take, somebody scores 55 runs average with 5 standard deviation. Variation is 11%, 5 by 55. Somebody scores 135 with a standard deviation 60. Variation is very high. Now in cricket, I cannot afford to say only a person with 55 plus minus 5 is required. Because I need a Virendra Sehwag to win the match. If he clicks, India wins. But when Virendra Sehwag or Tendulkar gets out, a Rahul Dravid and others must come and bat. They stem the rod, 55 plus or minus 5. They are also required. Are you with me? So it's a combination. Whereas if I have a vendor who has to supply an item with precision, I cannot afford to have that. I will have 2.5 centimeter plus or minus 0.01. Then I will get a vendor whose coefficient of variation is the least. So this is called relative spread. Relative spread is coefficient of variation, which is standard deviation by mean. And if you do that, you can get the spread for this work, pay and promotion, ladies and gentlemen. I will just show you here. So let me put here again font size 14, coefficient of variation CV is equal to TUC is equal to, I use standard deviation 8.29 TUC divided by mean TUC 10.39. Edit, copy, 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 paste, paste, paste. I find 10.39% variation is seen in work climate. In pay, it is 27.08 and more or less the same, around 27.36% for the promotion. The variation, the relative spread. this shows not only work environment is better, it also tells a story. Not only pay and promotion are rather poorly perceived, they have a fantastic variation in the data. 27% variation as opposed to 10% variation in the work environment. That means problem is confounded now, a bigger problem. So something is disturbing. You will have to find out. Major findings of the study. 1, 2, 3, 4. You write 4 bullet points. All summary measures point to work environment is performing the best, substantially higher scores. Not only pay and promotion are rather poor, they have a higher variation in the system, compounding the problem, requiring immediate attention to stem the rot and retain the nurses. In spite of a poor pay and promotion score, the work environment is doing very well. That shows if only you address pay and promotion, the work environment will still go up further. All the 3 measures point to this, and all factors considered at the macro level, the work environment is finding to be the best singular outperformer in the whole data set of the nurses. Of course, I'll have to go to individual things. Now, are you just able to see how to write a report or a bullet points, major findings? Yes.
One question. Why are we going with the CV? I mean, can you give us an example?
I give the example. Just no.
This
Gujarat versus Bihar. Or I have 4 regions, 4 salespeople are there. Okay, I will show you. Just ask a brain teaser for you. See this now? 2 people are there, salesperson, mean sales per year 50 units, standard deviation 5. The other person 75, standard deviation 25. How do I compare the two? If I go only by the mean sales, the second person is better. But now I work out the variation. The first person is 10% variation, second person is 33% variation. The moral of the story is don't get carried away by absolute number. Look at the scatter. Even though the salesperson has achieved a higher average, his performance is not consistent and seems erratic. Hence coefficient of variation. But his erratic is also a fact. Whereas this person is constantly achieving 50 plus minus 5. He is safer. Suppose on the negative side, suppose let us say standard deviation here is 35. On a particular day, he may achieve fantastic. So it is not that you remove the salesperson too. We are not saying that. We need all of them. Hypothetically, let's say this is getting 75, standard deviation 45. So it's a matter of concern. You have to tell it. See, we are not recommending anything. We are looking at numbers. You may say that his sale is poor, 50, but he is maintaining consistency. Like a Michael Bevan or a Rahul Dravid. They are also required. When the wickets fall like 9 pins and Glenn McGrath bowls and Tendulkar caught behind, he's gone. McGrath is jumping with joy, but you switch off the TV because you love Tendulkar, but he's out. Unfortunately, that is a tragedy, isn't it? Then Rahul has to come and help you. So all these are required. See, we are not saying this is good or bad, we are not saying, but this is erratic. It's a judgment. That's what we are saying. Whether in that context, you will have to give them a feedback. You have got 360-degree feedback, you have got a performance appraisal in the company, you are asking me, don't they give you feedback? Even if you are unhappy, they give you the feedback, isn't it? See, as far as subject is concerned, nobody can match you. You are number 1. But you see, that is called the sandwich technique. But you see, you don't get along well with the people. But overall, you are all right. That means that year you are not going to get anything exceptional. Feedback, sir. Therefore, these are all things. But they have to give the feedback. Whether we are happy or not is different. Okay, I have answered your question. Now, let me just sum it up very clearly for you. Articulation. Summary measures, their uses. We have not done so far any graphics or anything, but we just look at the numbers in the hospital case. The primary objective of the hospital is to retain the nurses. Retention. They should not leave. Today it's a big problem everywhere. And they are measuring 3 factors: work, pay and promotion. The hospitals by and large are doing well with respect to work, but poor in terms of pay and promotion. The scores are very low. They would like to know why. So we do the number crunching. We say that all is not well. And these are all the realities. Now, then we explained what is skewness, what is kurtosis, what is the standard deviation, what is mean, median, mode, what are the strengths and limitations, how do you look at numbers. And finally, we said also one more factor called the coefficient of variation. All are there in the book, just packaging them to you. It's 15-hour course, so we try to look at this very simple concepts. And we also have used Excel. How do we get the number crunching? Using a summary table. Now, I have asked you to look at the mode part. Am I right? Let us now, for a change, open RStudio, all of you. Now, I am going to show you the summary results of the same data, same example with R. To open, all of you. Because you are veterans now, you have done the introduction part and you are all terrific now. What is so special about R? What is special in Excel? How to take advantage of both will be my perspective. Now, let me show you some of the powerful features here. First of all, I do not know whether you have used this X assigned arrow and all that. I am going to use a very simple one. R accepts it, so let's not argue. So, let me just show you what is that. First is you create work directory. Set WD. I put here set working directory. Let me see my drive here. I put a pen drive, which is H drive. Okay. And baby hyphen Chennai 7. Okay, let me put here. Within quotes, H colon backslash. So you create a folder. I have put here backslash baby hyphen Chennai 7. Okay. And in that, let me see data. So I have here data slash data. This is the folder. So what I mean by that is, I create a working directory where I have a folder. Within the folder, I can have a data which is residing there. In that, I am going to put all my data sets. I may have 7, 8, 9, whatever. So that I can reference it when I do that. That's the idea. So set working directory, you are a master in this, isn't it? You have done that? But I am just saying, is it? Set WD means set working directory. And the drive I have is my H drive. You may have a different drive. Colon backslash baby Chennai 7 oblique data. I think Chennai 8, but I put 7. Doesn't matter. Chennai 8 now. Whatever. So you can put here H colon or G colon or C colon or D colon SMDM slash data. You can put. And data is a folder, subfolder in that. And the idea of working directory is I can reference it when I read a file. Okay, this is the first command. I'm just doing it extempo. If I make a mistake, you can correct it for me. So let us now, we have run this, am I correct? So this is correct. This command is correct. I'm using RStudio, not RConsole. You're all there with me? All of you? Please do it with me. Okay. Now, I say here my data. My data. Or you can say Saurabh's data. Or if you say Preeti data. Anything you give, or data. My data equals a matrix which I define equals read.csv. Now, comma separated values. In Excel, you have an option to save this file called health in a CSV format. I have already done it and sent it to you. Text files also can be read by R, but simplest format is Excel file, you save it as a CSV and define the names of the column in a short form. Don't put a long name. Then R will give work dot some stupid thing it will give and drive you crazy. Just put some simple names. Here work, pay and promotion. That's a health file which you can see. I will show you the file here which we have already seen. In this file here, data. This is the one. Am I right? This is what we have the file. This is a CSV file. And R is case sensitive and therefore you have to be careful. Read.csv means read that file CSV which is residing in data folder. Therefore the name of the file is health H. I have to put a quotation because it's a CSV file, health dot CSV, and then I also want to be sure and a comma header is equal to true. Header is equal to true. Are you with me? My data is equal to this means the file health.csv is assigned to the matrix my data or a vector my data. I'm assigning statement. It's like a Fortran or a Pascal or a basic or C+. X equal to x plus 5 means x plus 5 is assigned to x. It's not an equation. So my data equals read.csv. You read the file with the header and then assign it to a matrix called my data. Very intuitive. And health.csv must be within quotes, comma, header is equal to true. Generally, after the comma, CSV, I leave a space and a comma and a space. But if you don't leave a space here also, it will be accepting. No problem. Header is equal to true. T capital letter, TRUE. Some versions accept T, but I put true. I write it. I like to write. There no objection. I write it. Now let us execute this. That means this file is read. This file is read. Now read this file. It's read now. Correct. Now it is read. I want to know whether it is correctly displayed. So you put my data return. So I execute this my data and return. Yeah. This is the file you have got. Yes or no? Let us now understand my intuition. From statistics you go to R. Hello. Please listen. From statistics you go to R. It's not programming course. Very, very easy, effortless you can get. Because the header is assigned, it does not mean, suppose I want arithmetic mean. Mean work. Mean is MEAN. Small m is a command. Within bracket work you put and return. What do you get? Don't Google now. You just come to, we are writing it here. Don't Google now. We are doing the thing, whole thing in the class. I will write. You will be with me and we will have to do it. Please don't do Google or pre-scripted things. You will not learn. Please listen to me. This is an experiment I am performing with you. Otherwise, I could have given you some script. It's useless. You have to be a champion of analytics. Unshackle yourself from routine ways and be innovative. This is it. My data. Supposing I put mean, let's say here, mean my data. You just put MEAN, mean my data. What happens to you? Please tell me. What error has got? Object not found, isn't it? Sorry, mean work. Sorry, sir, not mean work. Mean work. Sorry, I want the arithmetic mean for work. Mean is the command in R. MEAN. What do you get? Object not found. Why? I have no doubt got the header assigned, but I must specify for my working file. It is fully assigned. You have only said header is equal to true, but you have not assigned it. And therefore, in a data file, if I have got 100 columns, mean my data dollar work, if you put, it will accept. But if you have got 100 columns, my data dollar will you put? You are an intelligent person, lot of attachments you have. So what you do here is, ladies and gentlemen, attach my data. I have attachment. Attach my data. Now you work out the mean and all, it will come. Attach my data. Attach my data has come. Attach means all the things are properly assigned. Now I want a summary my data. Hello. When I put summary, what happens is computer does not understand nurse 1, 2, 3, 4, 5. It will foolishly give summary, median, mode and stupid things for that. 1.3 average nurse and all that. Absurd to the power infinity to the power infinity. So you do not want that column. So what you do is, I want a summary, and therefore what I do here is, I create another working file for me, let's say, which is M capital my data. I put M capital my data is equal to my data, and a square bracket I put here, comma, this columns 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you look at this, names of the columns here, this is nurse is the first column, 1, 2, 3, 4 and 5. So, comma, hospital is required, first column is not required, 2 is to 5. 2 is to 5. Sorry, my data, comma, 2 is to 5. Take only column 2 to 5 is my data. Okay? Now, summary my data. MYDATA, capital M, summary my data. And if you want, I can extend this a little more. Okay, summary my data is the command. A beautiful, magnificent summary comes in R, effortless. And in R, you get the number of nurses. Hospital is a string variable, but yet it says private hospital 19, university 14, veteran administration 17. The sample sizes are also indicated magnificently. Work, pay, promotion, summary table, which is the minimum value of the data set, the maximum value of the data set, the first quartile, which is the 25th percentile, the median is the 50th percentile, the mean is given 79.8, the third quartile is given, the maximum is given. Now you find exactly the same answer which you have got, median and all that, but I don't have mode. I don't have mode. R doesn't give mode as a summary. Okay, it doesn't give the modal value as a summary. We will say why. We said mode, there is no unique mode. Sometimes mode can be bimodal, multimodal. As a matter of principle, R doesn't give. Now, why R is giving only this and not the rest of them? The summary table in R is based on a 5-number summary plus the mean value which is given here, 79.8, 54.46, 58.48. If you exclude mean, it is focusing on the minimum value, the first quartile, the median, the third quartile, the maximum. They are called the 5-number summary exploratory data analytic method. This 5-number summary you always do where median is the reference point because it fights outliers. Mean is given as extra for you, but it is based on minimum value, first quartile, median, third quartile, maximum. These are called the 5-number summary. Okay. These are called the 5-number summary. Okay. Okay. This is there. Now, the advantage is it gives you a compact output. Now, you can write this. You can get an overall summary. It also gives you additionally, automatically, without your asking, how many hospitals are there in each type. As a measure. Am I right? Okay. Now, one more thing, the advantage here. Yeah, Excel doesn't give directly, but you can find out. No, I've just come to that. The minimum value is 63. The quartile, first quartile is the 25th percentile. What is the meaning of 25th percentile is that I arrange the data in the ascending order and pick up the 25th percentile from the data set. So like the CAT score or GMAT score, what is the 25th percentile? Means 75% of the people are above you, 25% are below you. That is summaries. It is done. It is, if you write the data in the ascending order, I can show you 1/4 and then 25th percentile, you can figure it. 1 minute. This is 25th percentile. Median is the 50th percentile. 50% are above, 50% are below. Third quartile is the 75th percentile. 25% of the data points are above this value, 75. So what is that value? We find so. You can do it in Excel, you can do it anywhere. Now, maximum value of the data set. Now, this is called the 5-number summary. Arithmetic mean you remove is called a 5-number summary. Now, this 5-number summary is going to be used elsewhere. Now, I want to show you an interesting thing. By nature, R doesn't give the mode value. Supposing you want to find out the mode, you will have to write some code. Okay, I'll just show you a sample for you is, let's say, I write here frequency. Frequency is equal to, frequency is equal to table of S dot vector ascending order of work. I create this table, okay, S dot vector of work. That's a table I create. Ascending order, the vector work is there. Then I write here mode is equal to names of frequency. Names of frequency, and then I write here frequency double is equal to max of frequency. Maximum occurrence I put here, and then I have here more, frequency is equal to max of capital F. Capital F. Now mode equal to 72 and 84. Excel is wrong. You go to Excel now, data in the ascending order or descending order, you find out 72 occurs 5 times, 84 also occurs, and R has correctly reported, Excel is wrong. Now I am saying sometimes you have to apply your imagination. You go to Excel, descending order, you just see the data set. How many times 72 occurs? 5 times. How many times 84? Therefore, is it not Excel wrong? There is no unique mode here, and hence R. Therefore, R by itself doesn't give mode. If you want, you can write a code. The idea of showing this is not to say how to write a code, but to point out Excel can be wrong. The mode in Excel is not correct. It's not 72. It's also 84. You agree? Why R is not reporting mode as a matter of routine is because sometimes mode cannot exist unique. And hence R output doesn't give mode. Okay, before the cup of tea, we are late by about 10 minutes. Yes, sir. Which one? If you go to Excel, 72 occurs 5 times, 84 also occurs 5 times. So what is the mode? Is it 72 or 84? R reports both by writing a code. So in the summary table, whenever you use summary table in R, the reason it doesn't give mode as a matter of default is mode may not exist. If mode exists, it has to be a unique value. I cannot write 2 modes. 72 as well as 84 is alright, but I cannot interpret that. Which one should I take it as a mode? There are 2 values. Both are occurring 5 times. And hence, in the summary table of R, mode is not reported. Are you with me? Why mode is not reported, I am explaining. Is it clear? So we have got a summary table. Now you can interpret and write a nice report. Now, supposing in Excel I want the summary for each type of hospital. What will you do? Summary for each type of hospital I want. You will do some filter and then create this. Now I will show you here the beautiful thing here. Just see here. I don't want this summary. So, but by data, by my data, M capital, by my data, okay, indices is equal to hospital, comma, fun, F-U-N, fun is function, is equal to summary. To put this now, you will get beautiful here. Each type of hospital gives a summary. Tuck it, tuck it, tuck. Now, hospital, private. So when the private hospital is 19, university VA is set to 0, it gives you the summary measure for the private hospital, for the veteran administration, for the university, by the click of the mouse, by my data, indices is equal to hospital, fun is equal to summary. Gives you straight away a summary. For each type of hospital. Yes, indices is the reference point to the hospital. I want to index it with the hospital. Because hospital type wise I want summary. So now you can write a report based on this, which hospital the work is better perceived or worse perceived. Across the hospital, are there differences in perception? R gives you just like a Tirupati Laddu, directly Balaji Laddu coming to you without having to go to Tirupati. In Excel, you have to do it, you have to go to Tirupati and get the Laddu. So some places R is better. It's a very powerful statement.
So in this tutorial, we have learned about what is Python and why Python is getting the popularity, right? And what are the most used part of Python you need to know if you start your journey with Python. Like the libraries we have in Python, how can you do data manipulation and data visualization with Python? And what are the descriptive analysis part you can do with Python, right? I hope this tutorial will help you to start your journey with Python as well as the artificial intelligence, right? Please do let us know in the comment section what you feel about this whole tutorial, and also please go to Great Learning Academy where you will get almost 80+ free courses, and after complete your course you can claim your certificate as well. And if you want to do these courses in your mobile application, that is also possible using Great Learning app. Thank you so much.